Hey, what's going on? You guys ready for some tank watching? Oh, right when I... Ooh, NSF stream just crashed. VMix just took a dump. Starbase Live is still up, though. All right. Hang on, I just gotta yell at Max.
Discovery, go at throttle up.
Vin, what's going on? It's Alex's fault. All right. Blame it on hydrogen. Can we? Is that doable? So check this out, dudes. If you haven't seen this, if you're wondering what's going on, Booster 19 is on that pad, that pad. This pad's over there, at down in Boca Chica. This is the first time a Super Heavy has been on this pad, and what they're doing is they're checking out all the plumbing to make sure that you can fill propellants, and they're testing out all the pad cryogenic systems and booster interfaces to make sure that they can fuel Super Heavy. This is the first time that pad is being used. This is pad 2 at Boca Chica, if anybody cares. Pad 1 is over there. You could just see the chopstick on the right. This pad is brand new. It was under construction the last time I was down in Starbase, but it didn't look like that. Hey, Jay Speed, 132-month resub. Thank you. Okay. Yeah, so if you look, they're loading up liquid oxygen, right? This is the liquid oxygen tank. That's the liquid methane tank right there. The bottom of the methane tank is the top of the liquid oxygen tank in this design. And you can see from the frost lines that the LOX tank is almost already up there. It's already almost full, and they just started loading methane. If you kind of sit here and look at this, you could see the frost line go up. That'll tell you how much fuel and oxidizer is in it, because Starship is using fully cryogenic propellants. Starship's using fully cryogenic propellants, so what happens is when they fill them up, that's a nice way of saying the propellants are really freaking cold, because it's liquid methane and liquid oxygen. In order for those to exist as liquids, they have to be really freaking cold. They're usually gases down here. You have to freeze them to get them to liquefy, right? So what happens is when you pump cold propellants into the cold booster, it's going to sweat a little bit. It's going to get really cold. What that is actually doing, these frost lines on the outside of the booster, is actually condensing humidity in the atmosphere. And that's why ice accumulates on the outside of the tank. It's the same thing that if you take a cold beverage out of the fridge, right? You get the outside, you get condensation on it. See? I got my cold water right here, but you can see there's fog, right? You can see the condensation that's happening on the outside. Now, this isn't liquid oxygen. There would be no plastic bottle. It would just freeze the bottom of it off. But this is let's say a smaller temperature delta example of what's going on. Don't drink LOX. It's bad for you. Your insides will not be happy with you. So here's what we're going to do. For probably like the next 15 to 20 minutes, I'm going to be here with you guys, and then I'm going to go on the NSF main cast for commentary here. Do we know how long they're planning to do the burn? I'm not 100% sure if they're going to static fire this thing. Who knows? Don't start venting. Hey, it's a natural bodily function, all right? You guys don't have smell-o-vision, so I'll vent whenever I want to. Sweat. Boost your sweat. Boost your sweat. Stainless steel is... All right, sorry. Can I drink room temperature LOX? Yeah, sure. Just do this. There you go. That was actually room temperature nitro LOX, but whatever. I don't think we've ever heard an EJ vent. The mic compressor makes sure that doesn't happen. Not even kidding. Not even kidding. The mic compressor makes sure that doesn't happen. I used to have to hold it. Once upon a time. Pad vent. Oh, wait a minute. Wait a minute. Phil, if they're venting the pad. Okay, so see this little guy down here? That's gaseous oxygen coming out of the pad. If it's coming out of this, pyramid looking structure right here, that is what's called the GSE bunker on the side of the new pad. If you're venting out of there, that means that they're evacuating propellants out of the plumbing going to the booster. Now there are other vents. One there, there's one there, there's one up there. These little kind of slats on the side of this thing are they're little vents. But they could be evacuating propellants out of the pad. If they're doing that, that might mean static fire. I don't know. I'm not really sure the procedure here for this pad. Another vent opened over there on the other side. Are they doing a wet dress rehearsal? I'm not sure if it's a wet dress rehearsal. I'm pretty sure they're... they're validating plumbing data here. That's what I would do if I have a brand new, I mean, if it was me, if we had a brand new pad with a brand new booster, right? Pad deluge. Hold on.
Let's see what happens.
Hold on. Wait for it.
So that was a test. That's all it was. No engine fire. That was a rehearsal. That's all that was.
I thought the engines were going to go off. So when guys, on this pad, just for some visual cues, if you look down here and you see that full of water, like what just happened, that usually means they're going to fire. But what I was saying is that this is the first time you've loaded a booster on a brand new booster design on a brand new pad. You're basically starting from scratch. So what do? You test it and make sure everything works. We just saw the water systems working correctly. The pad deluge system was working. Now keep in mind the pad deluge is not the sound suppression system. Those are two different things. Sound suppressor shoots up in this design, pad deluge shoots down. So that was the deluge design, not the suppressor. That's different. The sound suppressor shoots water out in geysers all over the place out the top of a manifold on the rim of the pad. It's that pipe right there. I don't think it was a spin prime. Is that concrete shielding the tower? No, those are metal. It's metal panels. It's metal panels that have been, yeah, they're actually stick welded to the side of the pad. The reason why you have metal panels here is for when Super Heavy comes back in. Because if this is the chopsticks right here, when Super Heavy comes back in, right, and gets caught, it's sideways until the very last minute. So when it's coming down, the flames from the Raptor engines are pointed right at the pad. That's something that they learned from the first pad because it got toasty. So this cladding right here on the tower is there to deflect the flames and not roast anything inside of this. The road closure is for 12 hours, so we might be here a while. This might turn into a little bit of a long stream. Dude, we totally just got jebaited. Abso-freaking-lutely. Yeah, you guys want a sense of scale here. That's a regular person-sized door. And that is probably a little bit on the bigger side because it's up armored, because it's right next to where the business happens. But yeah, see the door over there? The sense of scale here gets completely thrown off from if you're looking at this on TV. It gets completely, you don't know how big this thing is until you go and see it. Now, the road is closed today. Highway 4 is closed, but Highway 4 is probably about 100 meters that way. You can see this from the road, which is really cool. Highway 4, now this is from the dunes. This is looking west. Highway 4 is right there. See this kind of flat area right here? It's right there, and you can drive right up to this thing. What did I miss? We just saw a deluge. They turned the pad deluge on. They did not turn on the sound suppressor. So what happened there was they tanked the vehicle, right? Full of liquid oxygen and just a little bit of methane. This type of configuration we have seen in the past in the Starship program. This configuration signifies a static fire. Now that dude, I haven't tank watched in a little bit. It's taking a second to come back to me here. They wouldn't static fire with all those cats nearby. Those are not close to the pad, dude. This is all stuff that's, dude, those are probably about 300-400 feet away, about 130 meters away. They're a long way away. It's just that those excavators are gigantic, and that's the Liebherr 11,000, which the Liebherr is behind the tower in this picture. Looks like maybe got some D8s over there. It's all Caterpillar, man. That's good stuff. We love Caterpillar. I love heavy equipment. I have a long ride to Nashville. They can take as long as they want. you have a short time to get there? Have to be there at 8 tomorrow, so yes. How many shots do they have with the water? More than that, dude. I mean, the new pad systems are, the new water tanks are way more capacity. So once again, I'm going to join up on the NSF stream here in a second, guys. I will still be talking to you guys in chat, but if I'm hosting the stream, I'm going to have to be making sure that the whole stream runs on an even keel. So, yeah, that should be happening in about 20 minutes. No events currently, that means they're doing a leak check. If I had to guess, they're probably testing stable states here. So guys, it's not only just when you're testing out new systems like this, especially when it's complicated as this, it's not just about you know, okay, let's see if it can fire. All right, fire it. Okay, we're good. It's about testing what's called contingencies. So you don't say say you're going to do a static fire in the future and the static fire doesn't work. Now what do? The vehicle's in a certain the booster's in a certain configuration. How do you revert it back to a safe configuration? That's oftentimes what these do test. It's not just about, okay, let's go to static fire, put it on the pad. All right, it fired. Okay, we're good. Now, ultimately, they're going to want to do something like that. But you're going to, before you do that, it would be wise to test what happens if it doesn't fire, right? Because it's the first time you're testing it, right? You don't know what it's going to do. You have a good idea of what it's going to do, but you don't know for sure. So testing what's called testing stable states in flight configurations is very important for launch data. Like, that's very important data that will be very helpful during launch, right? So right now, I would say the vehicle is in a stable state. They're not fueling it. The propellants are boiling, though. They're boiling off, but they are increasing the pressures. The tanks are at flight pressure here. I know because none of the vents are open. Now, on the methane tank, you're not going to see venting because it goes through a recirculation system and they scavenge the methane. They actually recondense it. There's a pneumatic gaseous methane line. It's not that one right there, but they do scavenge gaseous methane and it goes back down into the system to recondense. But the tank vents are closed. So these tanks are at flight pressure. They're in a flight state right now. That's why they turned the deluge system on, because they were testing it. So once again, it's about testing stable configurations of the vehicle. You know, it's not just about sending it on a static fire and being like, yep, push the button, let's go. Because what happens if you push the button and nothing happens, right? You want to test for this stuff. You want to make sure you validate your what's called contingency procedures. So, okay, what happens if, we go to fire and one engine doesn't fire? What happens? Like, two engines fire instead of one, right? Does the vehicle catch itself and stop the static fire, right? And if it does, what do? Do you drain the propellants? Do you leave it there? Do you let the propellants boil off? Do you turn the scavenging system back on? It's contingency procedures. Okay, what happens if this happens? Okay, if this happens, the booster needs to revert to this position. So we need to figure out how to find our way back there. It's like, I like to say that there's only really one way that this can go right, but there's 1,000 ways it can go wrong. That's something that SpaceX does say. They say that when they scrub and stuff, but think about it like right now, they're finding their way through a maze. And if you find a dead end, you don't just sit there and bang your head against the wall. You backtrack and you find the end of the maze. The end of the maze being flight, right? And the start of the maze being the start of your launch campaign. Sometimes you have to trace your way back to the start and then start over, right? That's what they're testing right now. They're testing the proverbial dead ends that might happen in this maze of launch operations, so to speak. Is it just me or is it tilting? Nah, you're just doing a Forrest Gump. Your head's just tilted. I think your head's tilted. Testing is trying to break the thing. It's not. This type of testing is non-destructive testing, goalie. They're not trying to break it. They have upper limits of where they think it's going to break. This is more about, you know, okay, we go to fire and it scrubs. What do you do? Because the computer is controlling this thing during a static fire. It's controlling it during launch. There's nobody flying this thing like a drone operator or something, right? It's not like we're playing Kerbal here. There's an avionics package that's on super heavy. Frick if I know where it is. It's usually up on the top of the booster, but you can't put it there because there's, you know, there's the Starship there. You can't put that up there because it's a hot staging ring, right? So if you go to tell the computer has guardrails, right? If you tell the computer to go fire and it sees that an engine is too hot, or you don't have good pressure in the fuel line, it'll stop. It'll stop it. It's called a red line monitor. It'll stop it if it sees something that's, well, in the red, right? Okay, no, this is not good. It's not supposed to be like that, right? You can also use this to dial in your control parameters, right? What constitutes booster fuel line pressure being in the red, or what constitutes engine temperature being in the red, or the engine could be too cold. It's possible. You have to get it to the perfect temperature. If it's not at the right operating temperature, it could be too cold, it could be too hot. It's most of the time it's too hot because you're using cryogenic propellants and we're super cold here. Hey, Peace Boy, 30-month resub. But yeah, this is it's about testing your control systems and then making sure your control systems, like testing where the limits are, right? But not destructively. You ideally don't want a destructive test here. You got to find your way through this maze, but you don't want to blow up the pad either. And that is a very possible thing. We've seen it. We saw it with Ship 36. They blew up the entire test stand. I wonder what tuning a rocket engine is like. It's I mean, they have fuel map settings, Hellfish, if that's what you're asking. It's fuel tables, like a car, similar, but what a car engine does and what a rocket engine does is a little bit different in terms of like manner of operation. It's easy to adjust the mixture on a car, but you're just changing the pulse width modulation on your injector, on your fuel injector, right? Like that's easy to do comparatively to this. How do you adjust the mixture with something that's constantly blowing up? You can't use pulse width modulation modulation or pulse duration with a fuel injector to make sure that this flies correctly. Now you can do that with RCS. You absolutely can do that with RCS. Yeah. RCS just uses 2 fuel injectors controlled by a computer. It's very much like electronic fuel injection on a car. It's very similar, only aerospace grade and costs a ton more that we can't afford. But like with an engine that's, you know, like a Raptor, you can change the mixture. I won't say how. They can change it. The only reason I know that isn't because I have some inside knowledge. It's just I watch McGregor live all the time. And I've noticed that, and I watch a lot of rocket engine testing. There's very much, you can very much operate rockets at different mixtures and different throttles. Sometimes throttling the engine will net you a different mixture depending on your turbopump geometry, your turbopump design. It really depends. Every rocket's just a little bit different because nothing has like It's not like they're using, every rocket is using one type of injector, right? Every fuel injector plate is different on a rocket engine. So some of them are throttleable. The way the fuel is delivered can be used to modulate throttle on the engine or modulate mixture. That is that's how like a Falcon 9 engine can throttle down so it comes to land, right? Like that's really important. But with a full flow stage combustion, there are other ways to control the mixture, but it's not something as simple as just like adjusting a fuel table. But I know because I've watched so much damn Raptor footage, right? That I know they can control the mixture just because the flames are different colors coming out of the back of the motor. The flame being a different color coming out of the back of the motor indicates a different, higher exhaust gas temperature. Higher EGT on a rocket engine means that you're burning at a different mixture. It's like MAP gas versus regular propane. Same idea. You change the mixture. How do you adjust for turbo pump speed? 619, I'm intentionally being vague here. There are ways. You could have a rotor brake. Rotor brake could do it. Like a helicopter. You could change head pressure. Change your feed pressure. So with a rocket engine, the tanks are pressurized, right? So you're always going to get tank head going into your impellers. Changing that can change the mixture a little bit. You could do that, but you're risking cavitation there. If you lower the feed pressure into your rocket engine too much, right, you'll start to get bubbles in the line. And 619, I'm sure you've heard me say at some point that you know, if you have a liquid fuel engine and that liquid fuel engine ingests gas, it's not going to end well. There you go. You could use a bypass, but due to it depends on the engine, Hellfish. It really does. It depends on the engine. You could use a pre-burner. You could stage your propellants like what Raptor does. So Raptor relies on methane atomization and oxidizer atomization, or oxidizer heating. That's what the stage combustion cycle is. So a Raptor engine, so like Raptor 3, for instance, is a full flow stage combustion cycle. So you have a pump you have a pump over here that's pumping methane and a pump over here that's pumping oxygen, liquid oxygen, right? ART, right? And each one of these pumps is basically a jet engine. Only this one is designed to run fuel rich and this one is designed to run fuel lean. And so a jet engine takes liquid jet fuel and gaseous oxidizer, right? And it makes jet. You make a jet coming out of the back of the engine from the hot gases escaping the vehicle, right? Each pump, or I mean, I would call it a power head, but that's using space shuttle engine terminology, I guess. Each power head on Raptor is basically a jet engine. That one's running fuel rich. This one's running lean. So this one has way more oxidizer in it. The oxidizer pump has way more oxidizer in it. I know, that's weird. And the methane pump has way more methane in it. I know, that's so strange, right? Weird. And they're basically an afterburning engine. But because they are they're upstream of the main rocket engine, they're called pre-burners. So you have two jet engines that are on like full blast, full afterburner, and then their exhaust gases are combining in the Raptor combustion chamber, and that's your main combustion from there. Yeah, the rocket engine is your reheater in this design. The rocket engine is your afterburner. But it's not an afterburner because the rocket engine's your main, the actual rocket is your main combustion. So because you have two jet engines north of your main combustion, they're called pre-burners instead of afterburners. Yeah, pretty cool, huh? That's why Raptor's so powerful. It's two jet engines feeding a rocket engine. Yeah, it's actually, dude, it's actually crazy. Now, if you know a little bit about jet engines, you know a little bit about tuning fuel tables on a car, there are a lot of things you can change here with your jet engines to make Raptor throttleable. You can change mixtures, you can make it run hot, you can make it run cold if you really want to. There's a lot of things you can change with a full flow to modulate mixture or throttle or whatever. Yeah, like I talked about a couple of them, but yeah, there's a bunch of different things that you could do. It's super cool design. Solenoid pulse width modulation sounds like a nitrous controller. Modulation like a nitrous controller could you do that with a turbo pump as well? There are some engines that can do stuff like that. Some pre-burner designs, Hellfish, do that. On an RD-180, like the Russian RD-180, they use a pre-burner to do something like that because it's an oxygen-rich stage combustion cycle. They have a fuel pre-burner to get your oxygen, your lean jet engine, right? They burn a little bit of fuel, and then they spray that into the oxidizer power head, and you have an oxidizer jet engine that shoots down into your main combustion, and then you just have a regular fuel pump. You have a fuel pump and a pre-burner, but then you have your full oxidizer power head. Your fuel doesn't have it has a standalone pre-burner. You could do that with like an RD-180 or an RD-171. That's what they do. That's how that whole engine works. So yeah, there's a bunch of different ways that you can modulate mixture on a rocket engine. You don't want to go into too much detail because every design is proprietary. And once again, it's not that I know anything about Raptor that isn't like straight public information. I try not to do that. I try to be like, well, I can't tell you. I don't do stuff like that. I don't go around asking questions. I just sit back. We sit back and we enjoy this. I know what I know from reading books about rocket science. Like, I'll show you. I've shown this on stream many times, but it is a good read. If you're interested. This will tell you everything you need to know. Modern engineering for design of liquid propellant rocket engines. Now, the interesting thing, right? This is by Dieter Heusel and David Huang. Now, the interesting thing about this is that, look, this is a book about rocket science, particularly in the applications of propulsion. Now, with that all being said, don't look at this and be like, the book about rocket science. I'm not going to be able to learn. I'm not going to be able to learn this. Rocket science is not that hard to understand. It really isn't. It's not. I'm serious. Anybody can learn it. It's very basic physics at the end of the day. You're mixing fuel and oxidizer in a combustion chamber and then blowing it up. A car engine does that. Car engines are not hard to understand. Look at me. I'm an idiot. I understand how they work. I'm a freaking moron. I'm known for it, right? The thing about rocket science is that it's hard to do. So don't look at this and be like, I'll never be able to learn this kind of crap. No way. No, you probably can. Doing it is the hard part. Anyone can learn rocket science. Easy. It's not that bad. It really isn't. Look, I have a high school education, right? I have a high school degree and I have a bachelor's in computer animation and CAD systems, right? Like, that has nothing to do with rocket science. I could figure it out. My math and engineering skills are at a high school level at best. I would say because I'm 20 years out of the gates from high school at this point, it's probably, they've atrophied a little bit, let's say. To quote Jared Isaacman. I could still understand this. It's not that bad. It really isn't. You gotta kind of want to learn it, but. What sort of testing are we expecting today? I'm expecting a GSE shakedown, Admiral. I'm not sure. That's the replay. I'm not sure if they're going to static fire, but NSF is actually pinging me, dude. So what I'm going to do is I'm going to switch gears and I'm going to give you guys the NSF feed. You don't need to go anywhere. And my computer froze. Please don't do that again. And I'm gonna go host their stream. So I'll be over there. I'll bring up the NSF stream. You guys tell me if the audio is good and we'll go from there.
I can do my speech here about
my words.
I can talk for longer if you want to. I'm planning to stay here. So
You're welcome to. Yeah, all we're going to do is get EJ and Max in for the next part of this stream, which will be the T-tanking and keeping an eye on the roadblock thing. While we're waiting for EJ to ping me to say hand over time, I'm going to thank some more people because we had Wheaty became a red team member. We had Astro Ellie. Is that Ellie? Ellie Birmingham Ellie? If it's you, you didn't need to. You're already one of those members, but you become a Capcom member anyway on your own account. Well done. Thank you very much for your support. Dina has gone, love all you do. Are we currently using rain spinner lens cover adapters that spin? What the heck? Hang on. Are you all currently using rain spinner lens cover adapters that spin at high RPM to remove dust and water off the lenses? If not, here's a donation towards trying it out. Well, thank you, Dina. I didn't know that's a thing. Self-cleaning lenses on the cameras, on the bot cameras. I don't know the first thing about the bot cameras to start with. I will pass that on. If there's such a thing, that is awesome. Because we do manually wipe them. Yeah, we have to manually wipe them. Poor Gage gets the messages saying, Gage, B2, which one of our cameras, needs a wipe because it's getting a bit dirty. So
it used to be Jack, but now Jack is going to be cleaning up cameras out on an asteroid, right?
Jack is too busy capturing materials, finite materials from asteroids now. Yeah, he's moving up in the world. Revhead has gifted 5 red team memberships. Again, and look at this, Edge has gifted 1 red team memberships. Same appreciation for all of you. Doesn't matter if it's 1 or 50. The fact that you've done it. And it's gifted as well. It's not like a benefit to yourself. You gifted somebody else in the chat, in the community. That is an amazing thing, really is. So thank you to you all for doing that. It's very much appreciated. I'm still not seeing EJ. Tell me he's ready. So, I've seen him in the communication. EJ, will you type in the back room? Because I don't want to introduce you and then go, Chris, why you introducing me? I'm not ready. He's typing. EJ is typing.
I guess
I am ready,
ready.
friend. I am ready, friend. There we go. Cool. Right. So that's enough of my Yorkshire mumbling. I did see some Lancashire people in chat. Yes. Oh, if we get a Rochdale football fan in chat, we're going to have a conversation because we're both fighting for the title of our league. Anyway, moving quickly on. Let's introduce EJ. Hello, EJ.
Hello, how do you copy?
We copy you 5x5, my fine friend. And we're also going to join by Max. Hello, Max.
Hello, everybody. It's been quite the exciting day so far. That all ramped up pretty quickly.
It has indeed. I'm going to get off because you don't want to hear my numpty voice much longer. So you got now Max and EJ with Alex as well. Ryan's going to go to sleep. Thank you, Ryan, for joining us on this one, Ryan.
Yeah, I am glad I stayed awake. I was hoping SpaceX would do something before like 1 or 2 p.m. so I could at least get a couple of hours in. And oh boy, did they did it all in 30 minutes. Like it literally started at 11:05 and it ended at like 11:37.
Crazy.
Just so you guys can have something else to talk about, the box fan vent and the methane reclaim vent, which is that stacked next to those 2 methane reclaim tanks, those started at 8:35 a.m. So you can kind of take that to figure out how that the chill down of the tank farm and everything like that. So you all have fun. I'll probably see you all on Thursday when we stream this again. And yeah, I'm gonna get some
with
sleep.
fire.
Yeah.
Yep. And you'll hear from me in 2 hours' time because we're going to do a Raptide either on Starbase Live or if this stream is still going, we'll pop into this stream. So either way, we're going to do a Raptide in 2 hours' time. Until then, take it away, EJ. Thank you.
Well, thank you very much, Chris. I feel like I'm coming in late to the action here.
You and I
Hey, you
both,
never know.
actually.
I mean, we'll stick around. We'll see. I'm ready to tank watch, guys. We haven't tank
Just
watched in a
saying.
long time now, have we? Yeah, I know, Alex. We could, dude. We could do something else. We'll see. We'll see.
Tank watching season is finally back upon us.
Oh, it feels great, man. Feels great. Okay, so Alex, so run us through here. What has happened thus far to fill me in and
Oh,
make
yeah.
just in case anybody else like hasn't just pop it in, like if they they had to come in a little bit late. I mean, Max and I are second shift. We were sleeping. So what's been going on? What have we missed?
Well, we had a lot of tank farm venting. So they closed the road, right? They cleared the pad. We had a ton of tank farm venting here from the subcooler area and pumps and whatnot. And we were sort of expecting to see any sort of kind of propellant load. We stayed there for a while until finally, about an hour ago, like it was a little bit over an hour ago, like 11:05, we started seeing frost on the liquid oxygen tank on booster 19, and then it started rising and it looked like a time lapse, but it was not a time lapse. Like it was just going so fast that you could see that level of the frost going up live. Now this is a time lapse. This is an actual time lapse, but this is essentially what we saw in sort of fast mode here, fast mo, I guess, and so yeah, we saw then frost on the methane tank. And suddenly we were like, no, they're not going for the potential static fire or anything. And they didn't, but they were really like rehearsing it. Like it looked a lot like what you would see on the day of a static fire test, like we saw back in the days of Pad 1, right? Where they loaded the liquid oxygen entirely, the liquid methane, it was just a little, right? Just enough to test the engines essentially. And then they fired up the detonation suppression system on the mount, the water deluge on the flame trench, and now we're seeing detanking here in process. There's still a lot of frost because those tanks get really cold, and it takes a long time for that frost to melt. If you remember when they caught booster 12 and even 14 and 15, it took hours for their frost to melt, and they had flown and burned the propellant, and they still were frosty for quite a few hours. So yeah. And EJ, I was saying before, because this is another thing as well of Pad 2 that we didn't have with Pad 1. When they fired that deluge that we saw on the flame trench, they have now pumps to recapture that water and put it back on the deluge tank farm, which means they can run that deluge multiple times in a short amount of time within the same window.
They can scavenge the water from the deluge. Is that what you're telling me?
Yeah. They have pumps at the bottom of the flame trench that can essentially suck in the water again and then put it back on the deluge tank farm. And that was one of the limitations of Pad 1, where if they fired the deluge, they were not able to test again the system, at least for a static fire attempt. They were able to fire multiple times, but the second time would be sort of like catch attempts and things like that. It will be less amount of water. It wouldn't be, the full amount of water that you would see for an actual static fire or a launch. But yeah. Now they can do all the things.
I mean, yeah, I suppose that makes sense because, unlike the kind of, the OLM from Pad 1, it's kind of like a milk. Should we call it a milk stool? I guess we could call it a milk stool, right? Like,
basically, yes.
Right? This pad is just a big bathtub in the ground, right? It's sealed up, so like any water you pump into it, it's just gonna sit there, right? Because you don't want the groundwater coming up, right?
Correct. I mean, it's an entirely dredged out and enclosed system there at the bottom. It's completely unlike Pad 1, where the engines were firing just completely against the ground and the exhaust was being dispersed in all directions. That's not the case here with this being a bi-directional flame diverter. All that exhaust is going to be contained into a small area. But because they have dug out into the ground now, if they have no way of actually pumping that water out, the water is just going to pool around the flame trench. And while that could look kind of cool once the engine's light, it's rather impractical if they want to drain the flame trench for any work or prevent corrosion on any of the I guess as parts down there as well. So yeah, being able to do that would not only help to be able to reclaim all the water, but also just to dry out the area once again. But they won't have that issue, I don't think, once they light up all 33 Raptors on board Super Heavy for the first time. So we had a bit of a jump scare there. We thought they might try and push it and maybe light one or two, or probably not all 10, but one or two. But that was a great demonstration of what we should see leading up to that first ever fire test out of here, which is really, really cool. But yeah, totally different design. It is a far departure from what we have become used to at Pad 1. So we are just getting used to it all over again, which is kind of exciting.
Yeah, dude, you know, and I'd like to add, guys, that pumps at the bottom of flame trenches are not that's not that out of the blue. Like this is a new design for SpaceX with Starship compared to the OLM, which is what Max was talking about. There are usually what's called a sump pump at the bottom of most flame trenches. In fact, I don't know, like who has been covering this for a long time. If you guys cast your mind back to the CRS-3 mission, this was a SpaceX Falcon 9 mission. I mean, first of all, if you've been watching this whole time, you keep it up with space. Good for you. That's we're long time, right? That was, I mean, at this point, it was a long time ago. I remember when it happened. But that showed, and I would call it inexperience at this point. That showed what happened if you don't clean the water out of the flame trench and go to fire a rocket. If you remember CRS-3 mission, Falcon 9 launched from Complex 40. And they didn't pump the water out of the flame trench, and it shot soot up the side of the booster during ignition.
Yep.
Right? You remember that, Max?
I sure do. I sure do.
All right. Good stuff. Yeah, and it actually is kind of a, I would say that's foreshadowing, right? Because the booster is all sooty on the way up on CRS-3. Guys, if you go look at CRS-3 launch, you do an image search, right? It looks like it's what we would know now as a reused booster, but this is way before they started doing that. But that was because they didn't clean the water out of the trench. So most trenches do have pumps, but Alex, it's super interesting that, I mean, the sump pumps that most trenches have just pump the water out. They just pump it into a retention pond. It's cool that they can scavenge it. I think that's really, really neat. I mean, I'm not sure how they're filtering that water, but,
And
whatever.
we've seen it in action. Like, we've seen it where I know Max has been taking over the Starship updates, and I know that there's been scripts that have done for him where it was like, they've done 5 deluge tests in a day or something like that. Like they sometimes have done that sort of thing, right? Where because they can recapture the water within 20 minutes or 40 minutes later, they can do another test and then another test and then another test. Like there's been days where it's been like that, and it's just so fun. And that's why we're saying, like, who knows what's gonna happen today? Like, I do think that probably they're not gonna test again. And they're gonna go on Thursday with a static fire test, but they have all of the tools right now to just say, okay, booster is detanked, there's no more propellant, right? Like maybe in an hour or so, they have already detanked completely the booster, and they're like, let's try it again. Chill down, booster loading and everything, fire the deluge. That's one of the things that they could in theory do, which also allows them in the future to do multiple launch attempts in the same day. If they have a long enough window, they will be able to do that as well. And it's one of the things of this pad that they will not be, or at least they were not able to do back in the day with Pad 1. And that's really important, because the more chances that you have to be able to retry again, to be able to launch again, that's also more attempts that you get at having a high cadence of launches.
So, I mean, Alex, that begs the question. are we gonna? Do you think they're gonna do anything else today? You know, like that. I mean, I gotta ask.
And that's one of the possibilities. Like it's what I said. I personally don't think so, but it's on their like it's on their toolbox, if you will, right? Like it's something that they will be able to do if they wanted to. And so that's why we're still live. Like who knows what they're gonna do? It's open ended, sort of like their hot staging ring. But
Oh, jeez.
We've been hanging around with Sawyer too much.
I was gonna say I didn't know Sawyer was here.
but it's true. Like one of the things that I said, I think it was on the Flame Train with two guys, where it was like, I'm open to whatever they do, right? Like if they want to try again today, cool. We're here live for that, right? Like that's the whole thing. If they
Dude,
want to keep
yeah.
testing, sure.
No, yeah,
do it again.
please,
It would be cool.
please. I mean, SpaceX, if you guys are out there, like, if you want to do more testing, I just want to let you know we're cool with it. Like,
I mean, they have just under 8 hours left for their scheduled closure. So, I mean, they could, in theory, do something. Maybe if they want to test to see how much they can recycle in one day. It's not out of the realm of possibility. But again, they have just under 8 hours left in their road closure window. So anything can happen at this point.
now, Alex, I gotta wonder. You know, we've been watching. I mean, we've been keeping up with Artemis 2, and there is an Artemis 2 press conference. You know, telling us what's going to go on. That's on Thursday at the time of this cast. It's March 10th right now. That's on the 12th, right? You know, with the wet dress rehearsal and stuff, right? With SLS. Now, keep in mind, guys, I know the Big Orange is a different vehicle. I get it. It's not super heavy, and believe me, I'm going somewhere with this. Okay, like part of their wet dress rehearsal was making sure that the vehicle could be in a stable state. Like they got it to 30 seconds and then they got it to a stable state and then they recycled the vehicle. Do you think like SpaceX could be doing something like that right now? I mean, we did see some tank venting probably about, I don't know, 5 minutes ago, right? But we're not seeing the propellants are boiling off. There's definitely methane and liquid oxygen in there. There's a lot of liquid oxygen in there, right?
Yeah.
Do you think that they're trying to put the vehicle in a stable state to recycle it? I mean, I know this does look like, they're just letting the propellants boil off, but if you were going to recycle the vehicle,
back,
yeah, do you think it would be different, or do you think they're, they're letting it drain?
The thing is that even though it's cold, it's getting warmer actually, because just for people to understand, when they load propellant on the vehicle, they load them subcooled. And if it stays too long in the vehicle, it warms up to boiling temperature. So this is a bit to going too deep into physics, but when you boil water, right? You warm it up, you boil water. In Celsius, it's 100 Celsius. I don't know in Fahrenheit. So you warm it up to 100 Celsius, right? And if you keep warming up that boiling water, it's not going to go higher than 100 Celsius until it boils off completely. And then the gas, if you keep heating it up, then it's going to go up in temperature. But as long as it's in boiling point, it's going to be at 100 Celsius. Now, translate that to liquid oxygen, for example. Liquid oxygen, because the outside temperature is whatever it is right now in Boca Chica, I don't know, it's like maybe 20 degrees or something like that, Celsius, right? But the liquid oxygen, its boiling temperature is, I think, minus 180 or something like that. I don't know exactly to like the decimal or anything like that, but it's around 180 degrees Celsius below zero.
So that's minus 297 Fahrenheit. It's minus 183. Yeah.
Okay. So the subcooling, what it does is that's the boiling temperature. That's the liquid oxygen in its normal state. If it were on the ground tanks, in the storage tanks, what they do is they pass it through a subcooler system to lower the temperature roughly to minus 200. So about 20 degrees lower. In Fahrenheit, that one I know a little bit better. It's, I think, 330 degrees negative Fahrenheit. So minus 330 Fahrenheit.
Mm-hmm.
So you're lowering the temperature, but every single time that liquid oxygen, because you have these heat sink, the exterior, right? The outside trying to warm it up, it's constantly trying to go back up to minus 180. And right now, because of the time that has passed while it's being on the booster, it's probably already at boiling temperature. It's already probably at minus 180. So that means if they want to recycle, they need to drain back. It's sort of contaminated, if you will. It's already warm up. It's sort of like if you have boiling water, right? And you don't want the boiling water. You want the colder one. You want the one that's being on the fridge, for example, right? You want the one that it's cold. What do? For example, if you had like a pot of water, boiling water, right? What
Yep.
do? You empty the water, and then you put the cold one back. And so that's what they will have to do if they wanted to recycle. So when they recycle, they empty the booster of that propellant, and then they load it back in with the subcooled propellant. And so that's very important distinction here, that it's not that if you let it sit, sure, it's going to be cold, but it's going to be at the minus 180 degrees, not the minus 200. And so if you try to load again, that 20 degrees difference, it's quite important for what they want to do. On Falcon 9, for example, it improves the density and performance, I think, by 12%. And 12% is a lot.
That's a lot with rocket science.
in
Yeah.
rockets.
Yeah. You know, it's very rare you're going to see an increase in performance in the double digits because, you know, with rocket science, you're beholden to thermodynamics and the tyranny of the
Yeah.
rocket equation, right?
Yeah, I know.
What I like to say, Alex, is it's like, you know, thermodynamics is like playing Tetris. You don't really
Yeah.
beat it. You just kind of get better at it over time. You know, like you never
I know I
win
went
though.
into the deep end with physics and whatnot, but I wanted to sort of put in perspective the problem of you know, letting these things to get to boiling temperature, because you're essentially letting warm up and become you know, the boiling liquid oxygen basically, instead of the subcooled liquid oxygen. Now, once it's in space, because this is also another thing. Once the ship, for example, is out in space, there's no subcoolers or anything. It's also designed to be able to function, I guess, with boiling temperature, liquid oxygen, and liquid methane. But on the pad, when you're trying to actually do pad activities, you want it to be subcooled, right? And so that's really important.
Okay, so Max, I know you're here. Alex is on a roll. I'm gonna let him go on a roll. So Alex, if we
Let him cook.
wanted to get that liquid oxygen out, how do we do it? How would you do
The
it?
same the same ports that fill the booster are also for drain. In fact, if you were to look at the quick disconnect port, it says F/D. That
Sounds
means
like my
fill
report
and
card.
drain.
Oh no, fill and drain.
Oh
Yeah, no, yeah, that's
Oh
good.
my
Yeah,
God.
yeah, yeah.
No. But yeah, so it's fill and drain, right? And so when you want to drain, you just run the whole thing, but in reverse. So you run the pumps in reverse and everything. Now the thing is, it doesn't run at the same speed. So we saw it going very fast, right? The filling goes in like 30 minutes, but the draining goes slower for one very important reason. When you fill the booster, the ground tanks empty out, right? And so they empty out, and there's a whole system on the pad to be able to pressurize back those tanks, because if you just empty them and there's nothing to sort of fill back, right? The emptiness, they collapse. It's sort of like sucking out with a straw, right? And trying to it doesn't work that way.
I've seen Mythbusters. I know.
Exactly.
Oh,
Yeah,
God,
they'll
yes.
pop like
Yeah,
that tank. Well, that tank did
that's
pop. It
really-
did the opposite of that, right?
Implosion.
Yeah.
So that's what will happen to those ground tanks, the propellant tanks on the ground, if you didn't have that system. So there's a whole system on the pad to be able to backfill those tanks is the procedure. But you don't have that on the booster. So if you were to drain the booster, now it's the opposite, right? Now it's the booster, the one that is getting drained. You don't have a system to be able to then fill back up as fast as they do, for example, on the pad. So that's why the draining is slower than the filling, even though the filling is like 30 minutes, right? But that's why they have all of these all of these vaporizers and everything. They have a huge system, very heavy system. Of course, the booster cannot do that. It's not like you can carry that into space or anything like that. And so the booster in that case, it takes a lot longer in order to be able to drain back so that you don't turn the booster into a crumple, basically.
Yeah, you know, we don't want to do that. I mean, that'd be funny, but it'd be funny, but
No,
I don't
we
think
don't
the
want it.
SpaceX engineers would appreciate that. You
Yeah,
know,
we
okay,
already
so,
had
yeah.
that with SN3, remember?
Yeah.
No, I try not to. I try not to.
mean, SN3 was funny, but SN4, who remembers that? Tank watching back in the day. If it was methane, they'd be igniting the flare. Oops.
Whoops.
Yikes.
Yikes, you bet concur.
We don't need any more of these.
No, we really don't.
Yeah, that happening right now would be bad. We don't want that. Okay, so, I mean, Max, you guys see on the screen like the tank farm is still very active. It's doing something. It's chooching over there. Max, do you know what that thing is doing? Like, what is it still doing?
I'm sorry, Chuchin?
It's chooching. It's got a lot of cheech coming out.
It's Jesus, EJ.
It's got a lot of cheech.
Like your vocabulary is phenomenal at times. I have to relearn it.
It's EJ.
So
Don't worry about it.
What I mean, the tank farm still has to be active to be able to drain all the propellant out of the booster still. But I wonder, because they have so much time left in the window, I wonder if they're going to try and perform some sort of recycle at some point today. We'll know obviously once the checkpoint is opened up there on the road, which is in the top right of your screen. But I don't know, to be completely honest. I still have to relearn all of Pad 2's tank farm as well so far. So, but it's because this is the first time that we've really seen it in action with a vehicle on the pad. And despite all the testing that we have seen up to this point in the past, there wasn't a vehicle on it. So there wasn't really there wasn't any good solid reference point to go off of for how it's for I guess any timeline. So
that's not new to us, right? Like,
it's all new. It's like learning Pad 1 all over again. Like, this is all brand new to us, and we haven't had this literally since Booster 4 or Booster 7 on Pad 1, right? So yeah, this is definitely unique. Like, we see it coming and going in spurts. Like, now you can see the venting calming down on the left hand side of the pumps there. But yeah, they have a lot of time left in the window. So who knows if that tanking and maybe it was a spin prime was all that they wanted to do today. But I would not rule it out if they wanted to perform some sort of recycle just to demonstrate how good the tank farm really is. And to this point, considering how fast the booster filled with prop in just over 30 minutes, I think I think it's safe to say it's going pretty good so far.
Yeah.
I still can't believe how fast that thing filled.
Dude, it's
I was getting ready
I'm
to
so
come on
scared.
here, and I was just like, "Whoa." Dude, it looks like Alex, you said it, dude. It looked like a time lapse. It's just going
Yeah.
up. Nope. No, that's in real time. Just the frost line just going up the side of the booster. It's very rare, guy. Nobody tanks this fast. SpaceX wants to do rapid reuse. And in order to do that, if you're going to do rapid reuse, the more time the booster's on the ground, that's not doing that rapid reuse thing, right? So SpaceX is pioneering tanking the vehicle in like a half hour, which is this vehicle holds the greatest amount of fuel, and the shortest fueling time. It's quicker than Falcon 9, Alex, right? Like, almost.
Yeah. And it's more than 10 times the amount of propellant.
That's
So,
wild.
yeah.
I mean, also, like, there doesn't seem to be a lot of methane at that time of what we think was a spin prime test. There didn't seem to be a whole lot of frost on the methane tank, but don't let that fool you. They have an entire Falcon 9 size transfer tube that also had to be filled in order for us to see any frost on the methane tank as well. So there wasn't a small amount of methane in there whatsoever. Don't let that fool you.
Right.
So yeah, I think all in, a version 3 stack is going to be somewhere in the realm of 5,500 to 6,000 tons fully fueled, which is absurd.
Wow.
Yeah, and mind you, they want to fill all of that within a period of probably 30-35 minutes, which is about what SpaceX does with Falcon 9, which, mind you, is like what 8-9 times smaller in terms of capacity. It's insane.
Super Heavy is taller than an entire Falcon 9 stack.
Correct.
An entire Falcon 9, like the whole thing.
Yes.
Right?
That is correct.
And just for some reference, Max, you said it was about 6,000 tons. Guys, a shuttle stack is 2,000 tons.
Yeah.
So the Starship with Super Heavy is 3 shuttle stacks worth of mass. That's, yes, any unit but the metric system. You heard it here.
Yep.
That's absolutely bananas.
And SLS, I believe, is going to be around 2,500 somewhere in that realm. I think I don't have that number off the top of my head, but I think it's somewhere around 2,500 to 3,000.
Sorry, I was being distracted by Blue Origin suddenly dumping some rocket factory pictures.
Wait, what?
Yeah.
Hey, don't
Dave
leave your
Limp,
stash
the
to
CEO.
yourself. Show us, man. Like, or tell us about it. Like, how can we see this? What are we looking for?
It's on X. Dave Limp shared pictures of their factory,
Whoa.
GS2 and GS1
Oh, mama, look
production.
at that.
Yeah.
Dude, that's
So
so
yeah, I
many
was being
GS2s.
Give me the good
distracted
stuff.
suddenly. Yeah, I'm so easily distracted by rocket hardware. There we go.
Dude,
Yeah.
no, that's fair. That
Those are-
is
Yeah, so in the background,
Dude.
there's two Glenn Stage 2 stages there. I don't know how old this picture is, but this could be like for the
Yep.
6th and 7th flight. Oh my god, I said the thing. Jesus. Anyways,
Don't acknowledge it. Just keep going.
moving on. Yeah, moving on. There's, I think, a GS1, a Glenn Stage 1 engine section at the bottom, I think, might be.
Mhm.
And then
Yeah.
there's some other engine sections as well. The second picture shows tanks as well. I like this. Thanks to Dave Limp, this is the CEO, sharing, production updates. That's good. That's what we want to see. Hardware, look at that. Compare this to like a couple of years ago where most of that was empty, right? And now it's full of hardware. Look at that.
That's a lot. That's a lot of tanks.
Yeah.
I mean, GS2s are something Blue Origin is not short of whatsoever. I think for an example, they just fired, as confirmed also by Dave Limp, GS25 or Glenn Stage 2 serial number 5. And mind you, New Glenn itself has only flown twice so far. And to our knowledge, they think the only booster that is capable or is going to be capable of flying again is Glenn Stage 1-2, or the second ever flight ready stage that they have built, which flew on Flight 2, and has since been confirmed to fly on Flight 3. So, yeah, Glenn Stage 2 hardware is not something that they are exactly short on, and I believe they have their factories or their facilities over at Rocket Park here, just outside of the Kennedy Space Center. The building where the lobby is with the Blue Moon lander mock-up, that is where GS2s are manufactured. And I think also the same is said for GS1 skirts, which holds the landing legs. Sorry, the aft module. Excuse me. I think Glenn Stage 1 is produced in the factory, maybe about a quarter mile down the road. But unfortunately, we don't have cameras in there. We hardly ever see any videos or just media published from inside there at all, unless they are ready to share something. But as far as we are aware, the Glenn Stage 1 for Flight 3 is still over in the hangar at Pad 36. Still yet to see what the status of that is or when that might roll out for a static fire ahead of flight. But hopefully Dave or Blue or Blue will share something soon. But it looks like frost levels are almost completely gone from the methane tank here, guys.
Yeah. It'll take a lot longer for the frost on the oxygen tank.
Oh yeah.
It's a lot bigger. It's still a bit like you can see a bit condensation though on the methane tank. It gets so cold and it's such a huge rocket that even the frost takes a while to just go away.
Correct.
The actual level of the liquid oxygen tank, it's probably like already below the top of the chines. The smaller chines, I mean, not the big ones.
Now, actually, you know what, Alex? That's a good thing to get into. There's like fins at the bottom, chines, fins,
Yeah,
drakes at the
Shines.
bottom.
I think shines.
They're different. They're different lengths.
Yeah.
Why are ones smaller on one side and the other? Like let's in case anybody's new to tank watching, let's bring them up to speed.
Well, the length themselves, I'm gonna say I'm actually surprised. The long ones are the ones that are not on the wind stream. But so the thing is, the booster as it is coming down, right? It's coming with the sort of the left side from what we're seeing here, down, right? Looking down. Essentially, it's gonna be not fully horizontal, but it's coming in a really high angle of attack. Essentially, it's gonna be coming in quite less vertically. Let's put it that way, right?
Not
And
flying,
so
but falling with style, right?
exactly. And so that side of the booster will be sort of catching the air, right? And so you see it's also like different clocking, as we call it. Basically, the angle between the center line where you see, for example, that pipe, that raceway going up, and the angle to the chines, it's wider on that side than on the other, where the long chines are located on the other side of the booster.
So
And
the
so
ones
that
that are in
allows
the
it to
the ones that are in the foreground here are like almost like little wings, right? Like
Yeah. And so that allows it to sort of catch the air, if you will, right? And it allows it to be able to first have more drag, which slows the booster further down before the landing burn. That's important because that means you have to slow down less, I guess, will be the way. And also it allows it to use its own body to glide further out, which means when it does the boost back burn, after stage separation, it flips, right? And then it starts the boost back burn. If you don't need to boost back as much, then that burn can be a little bit shorter. And every second, or even just a fraction of a second that it can be shorter, it means the landing burn can be longer or the ascent burn can be longer. Either way, you have more margins, for example, for your landing burn, which is very important to ensure higher landing reliability, or a longer ascent burn, which means you can push the ship further out with a higher speed and higher altitude, and that means the ship has to do less work, aka it's got more payload capacity, more
Yep.
payload performance, right? So that's one thing. I am surprised though, personally. I'm not sure. Maybe my brain is doing weird things with aerodynamics, but I would have thought originally the longer chines will have been the ones that are the ones that are in the air, essentially. The other ones will be protected from the airstream, right? Because they will be sort of behind the boost. So no, hang on. They will be protected by the booster itself, because like the shock wave will go up and around, right? And it will not touch that part of the booster. Whereas the one at the bottom, because of the angle of attack, they will actually be sort of impinging on the shock wave. So these will sort of catch the air again, and it will produce more drag. It will also get there more lift as well to be able to sort of glide out to the launch site when it does that weird high angle of attack reentry. It's super cool. We've already
So-
seen it with the older version, and it was already cool. It's gonna be even cool.
Right. So long story short, the more that super heavy booster is flying through the air, the more time it can slow down, less landing,
Yeah.
less fuel for the landing burn, more fuel for the ascent. It makes perfect sense.
Yeah.
It's
And
crazy.
so I was surprised that the longer ones are the ones that are in sort of leeward, if you will, if you want to call it that way, and the other ones are the windwards, right? Because I will have thought that they will want to have the most area, right, on the windward side. But hey, look, it's they're the engineers. I'm not. I just know physics. I don't know how to actually implement it in real life, I guess. But yeah,
I mean, I got a garage. I'm sure we could figure it out.
yeah. Let's build a rocket, EJ.
Yeah, I'm in.
Here in my
I mean,
garage, just my brand new super heavy booster.
yeah, it's fun. It's fun to roll down Highway 4. Don't, dude. I am brain rotted to no end. You are not going to throw a meme past me, okay?
That brother, that is a 10-year-old clip. That is not brain rot.
Yeah, that's a good point. I'm old.
We're
What
old.
do you want? What do you want from me, man? Okay. All right. So, Max, we're sitting here. It's, almost 1:00 out there in Brownsville. We were seeing tests about, a little over an hour ago. What did we see? I mean, I know that, you and I were watching from the peanut gallery. I mean, I was sleeping, I'm not going to lie. Bring us up to speed. What have we seen so far?
So from what we've seen to this point, we saw obviously tank farm activation earlier in the morning, and then we saw a rapid load of both liquid oxygen and liquid methane aboard Booster 19 here. They loaded the LOX tank all the way, if not almost all the way, and then they loaded the methane tank just enough to what we have seen similar to Pad 1 static fire testing of super heavy boosters as well. Here's actually a really good time lapse to show just how quickly I think this is played back at 100 times speed, but still, I think the propellant load time for version 2 boosters and in version 2 ships was around 50 minutes or so. And this all took place, mind you, in just over 30 minutes. Granted, they did not fill the methane tank all the way, but it's still, that is a lot of propellant to load in just over 30 minutes. But they loaded the booster to what we would normally see concurrent with static fire testing, and then we suddenly saw the DSS, or the detonation suppression system, miss. There we go, below the launch mount. And then we peculiarly saw the activation of the deluge system, which kind of gave us all a bit of a jump scare, like, oh my god, static fire testing, like right now, and there's the deluge. So we were all like, static fire, hello, like so fast. But there was no engine ignition from what we could see, and it's honestly difficult to tell through the mixture of gaseous or potentially gaseous propellant there in the flame trench and the deluge water as well, if there was even a spin prime test conducted. But that is our current leading theory of what took place today. But regardless, there was no engine ignition. But this looked to be a wet dress rehearsal, I guess you could also say, for a static fire test coming up. Could be as soon as the end of the week if all goes well, I guess. Cross your fingers, cross your toes, cross everything you got. So that is essentially the TLDR rundown of what we have seen so far today from this morning up until now. They are well into detanking operations right now. As you can see, frost levels on the booster are lowering and decreasing. But they still have until 8 p.m. tonight for their road closure slot. So we could be in for some sort of recycle just to see if the pad can do that so fast, or they could be done for the rest of today. So, but we are here for the long haul, and until this exact road closure is lifted and that roadblock is no more, we will have coverage continued. But as far as we can tell, they are going to be conducting a plethora of Pad 2 testing today.
There we go. This view is a lot better now with the sun behind the camera. Because this morning it was in front. It was like, it doesn't look good. But now it's cool.
This would also be an epic angle for a static fire. Just saying.
I'm not sure you'd be able to see anything.
Not with that attitude, sir.
I mean, it's not my attitude, it's physics attitude, man.
What even are physics anyway?
Yeah, don't worry about that.
Laws are never mind. I'm not gonna finish that statement. Never mind. Anyway, moving on.
Oh dear. Have you had coffee yet?
I don't drink coffee. I drink Red Bull, and yes, I have had one.
Okay, you get another one. Get another one.
Another one.
Another one.
Another one.
All right. So, actually, if we look at this shot here, is Super Heavy missing a grid fin here? Like I see two of them, right? Like okay, don't get me wrong, guys. I know it has 3, but why? Why does it have 3? Who wants this one? Alex, Max, which one? Who wants it?
Max, you want to take it?
I can try, although Alex might be much better at explaining. But essentially, SpaceX doesn't need 4 grid fins, at least so they think. So as part of the redesign from version 1 and version 2 boosters up to version 3, they have since downsized, or they didn't downsize, they removed the amount of grid fins that they want to use on Super Heavy boosters from 4 now up to 3. But these are about 50% bigger than the ones than we are used to on version 1 and version 2 boosters. Their locations are also peculiar because obviously you can see it's very asymmetrical with there only being 3. And the one side that is lacking a grid fin right now is not going to be in the direct airflow. It's going to be on the leeward side of the booster of the angle of attack when it is coming in through the atmosphere. So it wouldn't have much bite through the air and bite or control authority anyway. Once it's coming through the atmosphere. So to compensate for that, they the grid fins that are in the direct airflow are a lot bigger to have a lot more control authority, and essentially the ones that are on either side serve to serve as controlling pitch and roll, and then also the one on the the one that is not symmetrical, the one on the right hand side of your screen, good lord, will essentially serve as a rudder in that direction to make sure that the booster stays in control. So that is just part of the redesign from version 2 to version 3, and it looks interesting, I think, is the one way to put it. But again, it is a far departure from what we have become used to with version 1 and version 2, and it certainly had mixed reviews when we first saw renders because obviously how it looks. But seeing it in person, we know rockets are not meant to be aesthetic. It is always function first, function over form. But still, I think because it is the way it is, it's really beginning to grow on me. I'm not going to lie, even though it is missing a whole bunch of teeth with only having 10 Raptors currently installed at the bottom. But really, SpaceX really only needs 3 at this point for the boosters given flight profile going forward.
Yeah, and EJ, I'm sure you're probably going to enjoy what I'm going to say here.
Absolutely.
Because the reason why they can do this is because the flight of a booster is just out and back, basically, right? Like, and by that I mean to expand a little bit more on that. When you do a ship flight, right, from the point of view of the ship, yes, at the beginning it goes out, right? Maybe east, northeast, southeast, whatever direction it goes. But then when it's gonna be landing, it's got to point in such a way, like you have to do all of these sort of rotations and everything. We saw that on Flight 11, right, where they did this sort of weird hack, hitting a living cone of sorts, like on the shuttle, right? You don't need that with a booster because the booster goes out and then back in the same direction, just flip, right? Like, and it already does the flip when it does the boost back burn and everything, and then it turns engines first. You don't need all of that stuff with booster. Essentially, you don't need to like go around the launch site and glide and everything. Just do one simple direction, which means you don't need as much maneuverability left and right. You need it up and down, the pitch, basically, right? So the yaw, you can just have the rudder, the fin that is facing away from the tower. And that means that you can simplify the grid fin system. I remember this, Elon explained this a long time ago to Tim Dunn on one of the factory tours that they did. I think that was like 2021.
Yeah. That was a great video.
My God.
It might have been like 5 years ago when he talked about, being able to reduce the amount of grid fins compared to what they had at the time. And it's true that the booster flight, the path that it does, the trajectory, doesn't need as much left and right adjustments than it does, for example, for pitch. So you have the T shape there in order to be able to help you with that. The ones are 180 degrees apart, the catch fins, right? The grid fins are 180 degrees apart. Those act as your pitch, right? And it allows you to also do a little bit of roll as well. But you have two full grid fins, now being able to actuate the pitch. If you look at the configuration of the previous one, you actually got, I think, like less than a quarter or maybe like a third of a grid fin for pitch control. So four grid fins, but you only had like a third or maybe even like a quarter of each fin was able to do pitch control. So these are now full pitch control with two, so you have the equivalent of 2 grid fins pitch control, and it's larger grid fins, so you have even more control, which means it allows them to be able to do even higher angle of attack during re-entry.
So that means that
it's just bonkers.
Yeah, that's crazy. That means the odd grid fin out here is doing roll and yaw, right? Is that one combined?
More yaw, but yeah.
Okay.
But again, it doesn't need that much left and right, which is the important thing,
but
right? Compared to a ship, for example.
At some point, though, it may, depending, especially once it comes here to Florida, and if Starship is ever approved to fly on polar trajectories here on the Space Coast, because oh god, he went, but there's an Alex
Put
butt.
the glasses on, Alex. Let's go.
Actually, bring it. Come on.
The thing is, you can compensate that by rolling. So the reason why I said that the booster just goes out and back, even with Falcon 9, for example, when you see, for example, a polar launch trajectory, and there's even a really good a time lapse that SpaceX posted. I think it was from a transporter mission, and it's polar launch, right? The booster, it goes out and then comes back, but it's on the same line. It doesn't go left or it doesn't go after it goes downrange. It doesn't go that much left and right. It's the second stage that does the curve around Florida,
That's
which means
true.
when it boosts back, and Super Heavy will do even less in that case because the ship does more of the work in this case than on Falcon 9's second stage. So that means when it does a polar launch, it's still gonna be even less of a sort of west and east sort of movement, if you will. In that case, that's
So you're
why
talking
I
about-
was already but.
It still has to do some, but that will also come into a great use. Say if we run into a high amount of wind shear here in Florida, and there's a lot of left to right wind motion up top, that the booster has to correct for coming back to either pad A or pad 37. So like you were saying, it isn't in the grand scheme of things, it does not have to do that much, but it will have to do some, just based on the nature of whatever flight path it has to take, but also to compensate for things like wind direction or some variation in engine performance, whatever during flight. So,
Yeah.
but it doesn't, in the grand scheme of things, it shouldn't have to do that much.
You're talking, Alex, you're talking about like cross range capability, right? The booster doesn't have much cross range, but Starship during ascent is going to have cross range. It does.
No, it does, but in the forward and backward direction through the gliding that I was talking about before.
So
when
that's
when it goes
downrange.
out, yeah, but
Downrange capability.
not
Okay, I got
cross
you.
range. Yeah, okay,
Yeah.
I know what you meant. Yeah,
Okay, all right, cool.
Downrange, uprange, cross range, left and right. Okay, so that's
AB
what I
start.
meant. That it does it is able to glide in. But think about this. It is true that, for example, in the case of the booster, it still needs to roll, right?
Mhm.
But if you remember, for example, Booster 15, remember that crazy catch of Booster 15 on Flight 8?
That was awesome.
Was already
Yeah,
a year ago.
I was there. I saw it. I was there.
It was coming in with a bad roll angle, and at the last minute, it rolled in the right direction.
It's nuts,
And when
dude.
you look, for example, at Falcon 9, even those do the same as well. I saw a recent landing burn where it was off on its and Falcon 9 doesn't even need to be off on the roll, but it always lands on the same orientation. I think it's because of guidance or something like that they do that. And once it lit the engine, it fired up the RCS thrusters, it tweaked the grid fins, and it rolled in the right direction that it normally does for a landing. It's like, okay, that was cool, because I thought that Falcon 9 always did, because in the past they were always doing the same orientation, right? But in that particular landing burn, I learned very late, this is Falcon 9 500th and something launch, and that landing in particular had that roll after the landing burn had started, which is rather unusual for Falcon 9. So even that can do it. So it's really crazy the way that they do the landing for the booster and the ship. Of course, it's super crazy, because you have to think, the ship, when it lands, when it's coming into Starbase, it's going, like, the belly of the ship will be essentially visible in this way. If it were to do the belly flop in this tower, it will be coming in from pretty much to the left, essentially, in this view. There we go. From the south view that we see here, it will be left and right? So in order to be able to be belly out, because it's caught sort of back, going back into the tower, right?
It's like approach on a runway.
Yeah, basically. So what it needs to do is do this sort of arch around Starbase and being able to eventually position itself looking south for the belly flop to work, and then sort of back up to the tower. It's crazy, and we saw that on Flight 11. I really want to see them do that again.
I mean, it almost reminds me of like a heading alignment maneuver from the shuttle. The shuttle would basically stall at like 30,000 feet over your landing site and then just basically turn around to just bleed off altitude and then come in for a landing. You know, eventually, you know, while it's basically falling from the sky, right? You know, you'd turn obviously to get lined up with the runway. Now this is a little bit different. It's like a backwards heading alignment, Alex, because it's got to fly. It's got to like fly not over the tower, but it's got to fly around the tower and then circle back and land. But it has to do it facing backwards. Starship, when it comes into land, the nose is going to be facing out to sea, and it does that flip, and then it's going to have to come in backwards towards the catch arms. That's you know what?
Yeah,
You know what?
pad two
I
booster catches are going to be nuts to watch,
Yep.
at least at first.
Just decided I really need that in my life. I don't know about you, Chad. Yeah, I just decided that right now.
Inject it straight into my veins.
Please. Yep.
The funny thing is that you see that crane that's laid down there.
Yep.
Mm-hmm.
That crane, it was up yesterday. They laid it down for this testing, of course. That crane has been helping, or at least it's supposed to be helping, with getting a roof for Tower 2. So the funny thing is that part of that roof, it seems to be for protection, just like those. You see that cladding on the tower there, right? That's for protection against landing burns, because when the booster comes in, because it's coming in at a high angle, it roasts the tower, right? It's more for landings than for launches, by the way. Like launches, because the rocket is basically going straight up, it does a bit of a pad avoidance maneuver, and a little bit of the tower does get roasted. But all of that going up like a third of the tower, that's not for launch. That's for the landing, because that's how in sort of the angle that the booster comes in. But why would you need to do that on the top of the tower, though?
Ship catch.
Yeah, so
that's a good point.
that's the thing. Yeah, because the ship flip is going to happen like several tower lengths higher up, right? But when it's doing the belly flop and it sort of flips, it's still going down. And then the Raptor exhaust, it's like what, 150 meters long, right? So it has a chance of perhaps roasting the top of the tower.
Hey guys, it looks like the roadblock. There's a lot fewer vehicles there at the roadblock now, so it looks like they may be getting staged to reopen it somewhat soon.
Mm-hmm. Mm-hmm.
Which means that testing for today would be confirmed concluded, but there are still vehicles there, and there is still some frost on the vehicle, so we could still be a bit of time away from that. Oh my gosh, it's windy there, isn't it?
What car is that next to the Cybertruck?
The Camaro, yeah.
Oh, I like it.
Ooh, Alex likes an American muscle car. Let's go.
Right.
Come on, I like cars too.
Do you?
Yeah.
Do you actually? I did not know
played
that.
racing video games for a long time in my life. Yes.
What
What's
the
your favorite
heck?
car?
Where? What?
Yeah. Yeah.
Okay,
All right.
that's Alex just gained like 100 points of coolness today. That's so awesome.
Nice. You see, here at NSF, we like all forms of mechanized transportation. I mean,
Yes.
trains,
Trains
rockets,
are cool.
boats.
Rockets, planes.
If it's got an
Planes.
engine, we like it.
Yep, and if it goes fast, we like it. Yep, that's the rule. I mean, that's kind of a unifying thing for space nerds. You know, we like things that go fast. It's really
Hey,
really
even the boss likes horses, right?
That doesn't count.
yeah. They don't have
That
enough
doesn't
horsepower
count.
for my taste. Just saying.
Yeah.
Not enough horsepower.
Nope, not enough horsepower. It doesn't even have one. Seriously, a horse does not have 1 horsepower. I'm not even kidding. Go look it up. Look it up.
Explain your theory, EJ.
It has to do with basically how they were figuring out a unit of
That's-
measurement to measure power.
That Cybertruck is telling a secret to the other car.
Oh,
It's like,
hey,
Cybertruck.
Hey,
Never seen
hey,
one of
I'm
those.
telling you. It's like telling him secrets. It just looks like that. Sorry. But it was funny.
So guys, yeah, just in case you're just tuning in, it looks like the roadblock might be close enough. You may have missed the show, but
Opening up, EJ. Opening up.
they may be closing down the roadblock to open it up. Yes, that is words. Those are words. Those are words. Anyway,
Those is words.
Those is words. I'm good at this. I swear. I am a professional commentator. No, anyway, it looks like we may be done for the day, but I mean, we'll see. We'll see. That that truck the Cybertruck and the other truck next to it need to move. If they go, that's a pretty good indicator. But we don't know. We don't know for sure. But just in case you missed anything, Alex, what happened today? What did we see?
Well, basically, except for a static fire, they exercised the entirety of the pad to tank farm systems, the deluge system. So first, close the road, clear the pad, tank farms pulled up. Then we went into propellant load operations, and 30 minutes later, they activated the deluge. Like, it was that fast. As soon as we started seeing frost on the vehicle, like I counted like maybe 32 minutes between seeing frost on booster 19 and the deluge firing. So we don't know. It's really complicated, right? Because there's the detonation suppression system and also the water deluge itself activating. We don't know. They may have even done a spin prime and we couldn't know, because first it's a lot of water underneath the engines, and also it's just 10 engines rather than the 33. The 33, maybe it will have been more visible. Like, it will have been a lot more, right? When they do a spin prime, they flow the propellants through the engines without firing the engine, and so you will see this sort of big cloud of white smoke coming down from the booster. But again, if down there what you have is just water from the deluge, then you wouldn't see it. But it's definitely a lot harder when there's only 10 engines. So they went down there essentially pretty much to the T0 of a test, simulating what they will do, for example, during a static fire test, without actually firing the engines. And it was super cool. It impressed us all because, first of all, load operations really fast on pad 2. Second, we thought that they were about to static fire the thing. When we saw that deluge firing, it was like, wow, hang on, are they gonna fire the engines? They didn't, but oh my gosh, we were close, right? And so yeah, now we're seeing this detanking. There's still a lot of frost to melt off from the booster, of course, because they loaded what, like 3,000 tons of liquid oxygen and another 200-300 tons of methane, probably.
Something like that, yeah.
Yeah. So there was a lot. It was very cold. The actual level of the liquid oxygen is probably now sort of at the top deck level, sort of right at the bottom of the booster probably. But the frost takes a while to be able to melt off completely. But yeah, that's where we are right now. We were watching the road closure, right, EJ? The cars, they were sort of going around.
Yep.
That Cybertruck telling a secret to the other truck as well.
Yeah. Some super secret squirrel stuff.
Yeah.
Super secret scroll stuff.
Yes, moose and squirrel. Sorry. Yeah, so it seems to be winding down here, but we'll see. We'll see what happens. But we we're keeping up with the coverage, but so actually, you know what? I'll get through the support here, and then Alex, I have another question for you if you don't mind. All right, so
yeah, sure.
We had Marco with a $7 super chat. This was from a little bit ago. This was right when I popped in. Marco, I'm sorry it took me a second to get to it. I was kind of on a roll here with learning about the booster from Alex. I always try to pick his brain so you guys can hear it too. Sorry, Alex. All right, so when do we get an NSF cam inside the booster tank? I mean, if they wanted us to.
Yeah, cough, SpaceX.
Yes,
Are you listening?
Elon,
Cough, cough.
if you're out there, dude, hit us up. Hit us up. We'd do it. I don't know. I mean, I don't know if they want to show that, but we're here. I'm pretty sure Das would relish the challenge of getting a LOX tank cam to work. Pretty sure he'd be like, oh yeah, I can do that. And then retire to his shed for a week and then come back and be like, yep, got a LOX cam. That's what he does. So,
That sounds like the most DOS thing ever. And
oh yeah.
Yeah, that's pretty much exactly how it would happen if it ever did.
It would be like, where are you? You'd be like, no, I'm busy. It's like, okay, all right, sweet. So, okay. So, Alex, we saw the deluge system fire, right? That's just
Yeah.
below the pad. Now, we had the Pad 1 had that booster bidet where it kind of shoots up the business end of the booster, so to speak,
Yeah.
right? I mean, it isn't for cleaning. It's, that was kind of you got the DSS and then the deluge and then the sound suppression. This pad has something not exactly similar, but you have your water systems that go downward here, and then you have water systems that go up. The sound suppressor goes up, but we didn't see that today, right? We didn't see that thing fire. We just saw the deluge, right?
Yeah, we saw the deluge for the flame trench, right? There's multiple parts of the deluge. One is the flame trench, right? And then the top deck of the launch mount has its own deluge. I will not expect that deluge to be fired at any time during ground testing though, because that one is only for when the rocket lifts off and it starts roasting the top of the launch mount. That is when that water deluge should be. There we go. Yeah, the one on the top
Oh.
is essentially like a beef up version of the OLM of the one on pad 1. Remember the plate?
Yep.
What you said,
Yep.
the booster bidet and
The
everything.
booster bidet, man.
Yeah. So instead of being on the ground, it's on the top deck and it's shooting out the water so that when the rocket lifts off and starts roasting, instead of roasting, it's actually hitting the water. And so that water is protecting the top deck of the OLM, which is really important because on pad 1, it got
Yep.
roasted every single time. So now it's very important for reusability for that launch mount to not get roasted, and so that's why it fires. And in fact, if you look back at that testing when they did the full flame trench and top deck deluge system test, you can see there's a delay. There's the fire the one for the flame trench, and like 10 seconds later the one on the top deck fires. Why? Because the deluge on the flame trench fires up maybe like 10 minus 10 seconds, right? And then a few seconds pass, then the engines ignite, maybe like T minus 3 seconds or so. We'll probably get to know the timings better once SpaceX releases like a countdown or something like that ahead of Flight 12. But say it's roughly just like on pad 1 where it was like T minus 10 seconds, T minus 3 seconds, right? Deluge activates, then T minus 3 seconds, the engines ignite, T0, everything releases, right? The rocket starts lifting off, then the deluge on the top deck activates and protects the top of the launch mount against the forces of the Raptors, and that's very important. You see the same, for example, at LC-39A, where at engine ignition, there's no rainbirds. Actually, the rainbirds activate after the launch happens, and I think that happens also at Slick 4 East at Vandenberg. When it doesn't happen for whatever reason, it's at Slick 40. The rainbirds actually do activate before the rocket lifts off. I guess it's just the way that
Yep.
different pads are sort of designed and things like that. But that's essentially what happens in other launch pads, where you don't activate the top deck deluge until the rocket actually lifts off, which is a bit smart, to be honest, because if you have a hold or on a board or things like that during engine ignition, well, you still have more water, right? Don't waste any of that.
But also, one of the more unique parts of Pad 2's redesign as well is the relocation of the BQD, or BQDs in this case, because they went from 1 to 2 from Pad 1. If you look at their location compared to where they were for boosters for version 1 and version 2, where the booster will perform its pad avoidance maneuver or early gravity turn, there's nothing there anymore. Where that is where the old BQD or booster quick disconnect used to be. So that will no longer be getting roasted on liftoff, at least right away during the pitch over, which is always good, because if they want to turn around the pad quickly, that's one less thing to worry about in terms of being able to get any hardware operational again within X amount of time, because it was always a weeks, if not months, period to get Pad 1 refurbed and ready for the next flight before it was ready. So those being there, the BQDs being where they should be directly out of the way of the booster of the, I guess, the booster pitch over maneuver. Good grief, I can't talk. I'm too excited. So yeah, Pad 2 is it's a clean slate, and we cannot wait to see how it performs. But I think we're all still chomping at the bit to see how the exhaust is going to look out of the flame trench for a static fire, though, at least.
Yeah, I know I am. I
Uh-huh.
I want to
Uh-huh.
see this. I want to see this. There's a good
And there we
question.
go. That's
Oh
a
yeah.
replay of the test
Oh
that
yeah,
they did.
dude, look at that. Yeah,
See, it runs for a few seconds,
and then the
and
top
then the
goes
top.
on.
Exactly.
And
See?
at the point the top turns on, that's T0, right? That's
Yeah.
separation.
Yeah.
Hmm.
So you can imagine the rocket lifting off now.
Yeah, right when the geysers start going up, when the water starts going up, that's when the booster would lift off. So actually, there was a good question in chat from 76i. I'm gonna pop it up here. Would they use the top deck deluge to protect the pad during landings and catches?
probably.
Ooh, yeah, probably.
Yeah, probably.
I
With
mean,
static fire in the
I
room?
mean, we saw the exact same thing on with Pad 1 and booster catches over there. They would activate the deluge again, albeit at a much lower flow rate because you're only having to protect against three raptors and not 33. But probably to some extent, yeah.
Cool. That was a good question.
Chung.
Man, dude, my favorite
Now
part
the
about that
truck
footage
beeping
is the
up.
guy. Yeah, the guy in the roller.
That's
The guy in
amazing.
the compactor. He's like, huh. Nope. All right. Yep. We got to put her into reverse here and get
Put
away
in
from that.
reverse, Terry.
There's a tidal wave
I'm outta
coming at
here.
me. Let's just back up. You know, I'm just gonna stop what I'm doing here and just back this thing up. I'm sorry. That's my favorite.
Beep.
Probably just sat there and looked at it and went, wait, what? Oh, okay.
Like
The
that one
driver
meme
probably
from
being like, I'm out of here.
it's like SpongeBob. Backing up, backing up, backing up.
I mean, yeah, I'd throw her into reverse if I saw a tidal wave coming at me. I'd be like, okay, you know, I'm just gonna back it up now. Oh boy. All right, what else do we got? Dark silver. Can it launch in the rain? I mean, yeah, probably. Yeah, probably. Yeah, good stuff. So, okay, we're talking. You know what? I think we're still talking about the water
Look at
system,
that.
dude. That is the guys. Okay, I'm just gonna say it. I know this gets said a lot,
That's
but like,
crazy.
these cameras do not do this justice. How big that geyser actually is.
No,
Like,
no,
you know,
not at all.
Now keep in mind, Highway 4 is right next to this pad, and it is a public road. Not right now, it's not. The road is closed still, but it is a public road. You can get up to this thing and see it up close. And I think until you do that, it's kind of hard to picture the scale here. Those geysers are easily 10 stories up in the air. Like picture a 10-story building or 10-floor building in your mind, like an apartment block or something. It's easily that height. It is hard to grasp the scale of Starbase, but it is cool.
I would love to see a graphic of sorts with the size of the deluge as a whole going off compared to the size of a Falcon 1 for some reason. I feel like that would just tickle all the right parts of the brain.
Yep. Mm-hmm. Oh boy! So if you haven't been keeping up with us here, there's a shot of the roadblock. The roadblock is still in place there, but we did see what we believe to be some type of a deluge test and possibly a spin prime. We don't know for sure. It looked maybe like it, but yeah, it seems like testing may or may not be winding down just a little bit here, but I don't know. They might go for it again. We're gonna sit here and we're gonna stay live until those cars at the roadblock move.
It's crazy how much more SpaceX has learned and how much more improved Pad 2 is. At the very first test, already fully loaded a booster like if it were to fire, and did the deluge testing and everything. Like, oh my god! I remember all the times that we were here, looking at Pad 1 testing, right, with Booster 4. Remember Booster 4?
Yep. Yeah.
I try not to, honestly.
Hydraulic power unit.
Yeah.
29
And then
engines.
Booster 7. Yeah.
Cryo, spin. Sorry. I can't. Dude, anytime somebody says Booster 7, I just think of the Adrian song. Cryo, spin prime, static class, spin prime, cryo test. It's like,
Boom.
Okay. Oh, dear. Hey, was anybody around for that? That was really funny. Or I could just be laughing alone in the room. in a room by myself. Like that's fine. It's funny to me. Okay. It was good. All right, cool. All right, thanks for the validation, Eric. I appreciate it. So it looks like the booster is detanking. Max, we see those frost lines going down, right? That means that the
Yep.
propellant is boiling off, correct?
Correct. Either boiling off or they are literally pumping it out of the booster to reclaim it and put it back into the tank farm for a future use. But yeah, frost is decreasing on the booster a lot so far. And based on the level on the amount of cars that we see at the roadblock right now, tank farm vapor picking up a lot. We may not be too far away from the road reopening, just given how far the frost has fallen and how little propellant may be on board the vehicle still, if any, because that frost can hang around for a long time, even after the propellant has been offloaded from the vehicle. But yeah, tank farm is very venty, very venty. That's kind of now it's winding back down again. Interesting. I wonder if that was like a purge or something from maybe prop is offloaded from the vehicle entirely now. I'm not sure. But yeah, we are just waiting to see how much lower that frost line is going to get. We assume all the way, and then we are obviously waiting also on the cars they're leaving or opening up the roadblock there to obviously sign that Highway 4 is open, and then testing would be completed for the day. So interesting to see, but I think we should also note that a new road closure popped up for this Thursday from 8 a.m. to 8 p.m. local time in Starbase. So either more tanking and more spin prime testing, or that could be the first static fire test of Booster 19. We're not sure yet. We'll have to wait and see how both the vehicle and the ground systems behave today to warrant that. But based on everything we've seen today, prop load happened without any pause. We didn't notice any sort of like bugs or hiccups or leaks. And then they went right into whatever test they did with the DSS deluge and possibly a spin prime as well. So, yeah, dude, it's been a very eventful day so far.
Now, okay, we're not sure exactly what's going to happen, officially. It's representing NSF actual, like we're not sure. Max, what do you think? What do you think? Spin prime or full static fire on Thursday?
Yeah, correct. Like full disclaimer, we have no idea. Like we are going off of all the tools and images that everyone else can see. We don't know for sure, but something tells me we could be on for a potential like 1 or 2 engine static fire on Thursday. I could be completely wrong on that, and it could be a second spin prime, or assuming today was a spin prime, but there's a non-zero chance that Thursday could be a static fire. I'll say that.
Okay, so we're getting a little bit into the weeds here with contingencies. So, this booster, I call it the Snaggletooth booster because it only has 10 engines on it. Out of the full 33.
Snaggletooth.
It's a little bit of a Snaggletooth booster. Looks like a hockey player after they got into a fight. So there's only 10 engines on it. If they do a static fire, are we firing all 10? We fire in 3. What do you think?
Ooh.
Yeah, it's interesting, right? Because I firmly believe that those engines, the engine placement isn't random. I really don't think that. A lot of people have been asking me that. I think they're in those spots for a reason to test. If I had to guess, it would be to test booster plumbing, right? So do we see all 10 of them fire?
I mean, we very well could. I'm not going to lie. My gut tells me we're not going to see more than 3. But the fact that they have engines on all 3 rings of the engine section, meaning that they have some of the innermost 3, they have some of the middle ring of 10, and then they have some from the outer ring of 20. So they have some engines at least on all 3 rings. So they very well could fire all 10 just to test the structural integrity of the thrust puck so far. I don't know. But my gut tells me that they'll want to start off more cautious and firing maybe 1 to 2, maybe 3 engines tops at once. Similar to what we saw with Booster 7 a long time ago, where they fired where they fired one engine at a time for a long time, and then two, and then three, and then more than that. So likely we're going to see maybe 2 or 3 at the most, but they could just say F it and fire all 10 just based on how happy they may or may not be with what they saw today. I'm not sure. It's very interesting nonetheless. But I think 2 or 3 tops. But mind you, there has to be more than one test so far because it only has 10 of all 3 engines that it is going to have for flight. So they're going to have to fire multiple times either way. It's a question of how many times they're going to fire in this current configuration. They might start out with 1 and then 2 or 3 and then fire all 10. I don't know.
You know, I think that incremental testing would probably be more the case here. But then again, I thought we'd be incremental testing than today. It's like, oh, tanked it, 30 minutes tanking, boom, all right, done.
Yeah, for real.
Like, wait,
I don't think any of us were expecting a DSS or deluge activation today, let alone a spin prime test, which may or may not have happened. We can't honestly tell, like, for sure. Just because of how clouded out the view was from under the launch mount. But a lot more happened today than I guess we thought was possible. So that being said, based on what we've seen versus what we expected, we very well could be on for some sort of static fire by the end of the week. That could age poorly, and that could be terribly wrong. But based on what we've seen today, there's a non-zero chance. Do you think they'll fire all 10 the first time, EJ? What do you think? I'm curious.
In my super expert armchair Kerbal player with 10,000 hours opinion, I would go incremental. I would probably just do 1, then do 3, probably 3 centers, and then work your way out. Like, with that kind of stuff, especially with Raptor 3, like, do we... Okay, all right, I'm going to nerd out for a second here. You know, have we ever, Chad, I'm actually going to put this one out to you, and I'll let the hive mind of the internet kind of help me with this. Do we have much testing about Raptor engines clustered together? Because, you know, it's
Raptor 3? No.
Yeah, Raptor 3, yeah.
No.
I mean, we know the test stands. We have McGregor Live. If you guys want to, you know, we have streams of SpaceX's test stands, right? When they test the engines, you hear about it on that stream with the distinctive, you know, like, have we seen clustered engines together? I don't think so. When you cluster rocket engines together, I mean, like I said, it's not like Kerbal or Simple Rockets which is Juno, right? You know, you can't just add another booster. It's fine. No, in real life, you really have to worry about temperature getting too high with a bunch of engines sitting next to each other. I mean, an immediate example of this would be the Saturn V during the Apollo program.
I was just going to go there.
Right? Max, what did they do?
They had a cluster of all 5 together at one of the test stands at, I think it was Stennis. Was it Stennis or Marshall? I think it was Stennis, right?
So the first Saturn V was tested at Marshall.
Okay.
And every other Saturn V was tested at Stennis. The reason why they did that, very much because they were going fast like SpaceX does, is because they didn't have Michoud and Stennis were not ready. So the first Saturn V was fabricated in a shed at Marshall Space Flight Center. I'm not even kidding, guys. It was in a shed. They like windbreak style. I mean, it wasn't a windbreak style. It was a climate control building, but still, yeah, they couldn't even put it all together. They had to, you know, they made all the pieces and then they had like trouble putting the thing together, which is super cool. That was, I mean, for, you know, if anybody's interested in historic Apollo tank watching, right? So they had the clusters of engines, right, on the 4670 test stand at Marshall, and then the B1 and B2 test stand at Stennis, right? You know, have we seen anything like that with SpaceX? I'm not sure.
Not with Raptor. We know that they have fired old Falcon 9 boosters on the, oh God, what was it? Not the milk stool stand, but oh God, what's it called? The stand that they don't use anymore at McGregor.
The tripod.
The tripod, thank you. They used to fire old Falcon 9 boosters over there, and then I say old. They used to test Falcon 9 boosters there, and they have also fired flight proven Falcon 9 boosters as well, or Falcon 9 engines, I should say, together in clusters of 9. So it's not unlike them to do it, but they have not done that with any sort of Starship testing yet. They have not built a jig or like a pseudo bottom like super heavy aft section where they can mount 33 Raptors on like a test stand at McGregor and fire them all at once. They have not tried that yet. As cool as that would be, I don't think the locals around McGregor would be happy with that. As unhappy as they may or may not be already, given the testing cadence already. But yeah, I think. So we haven't seen that so far, and this is actually the first time that Raptor 3s have been mounted to a flight vehicle at all. We have only seen singular Raptor 3 engines on test stands, both with the sea level variant and then also the vacuum optimized variant. So having more than one on a vehicle, let alone a flight vehicle, this is the first time that we have seen that. So which is why. It might make the most sense to take a more cautious approach and fire one at a time, right? Oh, here's a great clip. Yes.
Oh, the tripod.
Yes.
Blast from the past, man.
There should be audio with this, maybe. I don't know. I could be wrong.
Even if there isn't, we can just bask in its glory.
Yeah, dude, look at that.
Yeah, they used to just put a whole Falcon 9 up there and just say, all right, go. So that, a little bit of a history lesson here. That tripod was left over from another aerospace company that folded in the 90s, in early 2000s, called Beale Aerospace. Beale Aerospace was a commercial flight endeavor just like SpaceX, and they were using McGregor for their testing, and they did unfortunately go under, and SpaceX bought that test stand like wholesale, like cheap, very, very, very inexpensive. And that's why they ended up testing there, because it was a good price for the test stands. Because they weren't exactly in high demand in like 2007. You know what I mean?
Yeah, right. It was a much different world back then. But they used to test Merlins there. They have tested Falcon 9 boosters there and engine clusters, and they also then moved on to testing Raptors there as well, which is where like some of our favorite clips ever have come from. And remember the first time we saw a demonstration of the electric TVC or thrust vector control on Raptor 2 was staggering, because the footage looks sped up based on how fast it was able to gimbal, but that's just real time. Yeah, but they don't use it anymore, unfortunately. They have since moved to using their own bespoke vertical and horizontal stands. I think they're all vertical actually now, though. I could be wrong. I should know this. I cover this in the Starship Update every single week with our minute there. I know, tragedy. I'm a disgrace.
All right.
I'm a disgrace. But yeah, they haven't used the milk stool or the milk stool. I keep calling it a milk stool. Milk stool.
You all
Good
right?
grief. No.
There's not smoke coming out of your ears, is there?
Bame's non having a strong callabon.
Yeah. Okay. All right.
But no, the tripod is not used anymore from what we can see.
So, yeah, they did end up demolishing it. So that's the thing, guys. Like, Max, you asked, like, to bring this all kind of full circle. You asked, did we, are we going to see multiple engines? I don't know. I would probably start incrementally. Like, the other thing I was going to say about the Saturn V, guys, is that even with clustered engine test stands at Marshall on the 4670 test stand, and then the B1 and the B2 test stand at Stennis testing all Saturn Vs before they flew, they still had heating problems with 5F1s all clustered together. They ended up wrapping the engines in asbestos. They just put asbestos blankets all over the Saturn V engines. If you look at footage, some like remastered footage of Saturn V's launching, the engines look like the Stay Puft Marshmallow Man, because they're wrapped in asbestos. That's the only way they could keep them from burning themselves from the inside out. And because SpaceX doesn't have a lot of data on how well Raptor 3s, that is, work in clusters, I'm sure some information carried over from Raptor 2, right? But because they don't have a lot of information regarding like thermodynamic, thermal analysis, not thermodynamics, thermal analysis on the outside of the engines operating in a cluster, I think they'd start with 1, then move to 3, then maybe 5, and go from there. But yeah, getting engines operating together is not just like, oh, just add another engine. All right, it's not that simple, right? I mean, rocket science really is. But yeah, so good stuff. Good conversations, chat. This is good questions. So Alex went to get a bite to eat, so he's eating. He posted the Homer Simpson "I'm so hungry" in the back channel. So it's time to go to the bullpen. And who do we have for the relief pitcher? We have Sawyer, Sawdog Rosenstein. Sawyer, what's up, man?
Now pitching number 18, Sawyer Rosenstein. Number 18. I'm
Number
good. How
18.
are you, EJ?
I'm good, man. I'm good. Brrr, brrr, Evil Empire. Sorry.
Yeah, sorry. That was the old Bob Shepard impression from the
No.
old Yankee days. But
No,
anyway.
it was good. You know what? I'm a Red Sox fan. I appreciate it, man. I appreciate
Yeah.
it.
Gotta honor the broadcasters as we broadcast here this crazy testing day that we've been seeing. My goodness.
Yeah, it is. Yeah, it was a little bit of a show there, huh? For a second. What'd you think of that, Sawyer?
I was surprised. I was doing something. I'm like, oh, cool. They're starting to fuel it up. The next thing I know, I look back. I'm like, it's halfway full, and then all of a sudden, it's doing the testing. That was beyond surprising how quickly that went, and that normally they'll sit around and kind of just hold the tank there and see what's going on. Nope, not even waiting, holding, testing it, just right into the test of the DSS and the deluge system. That was wild.
Yeah, I mean, it happened real fast, right? And we were talking about this a little bit before, but Max, this really shows that SpaceX ain't playing around with that full rapid and reuse stuff, right? Like this was quick, even compared to Pad 1, which was faster than anything that I've seen, right? We've watched
Correct.
all kind of rockets tanked out. This thing went real quick.
I think we're all used to the fact that it took SpaceX a long time to make sure that Pad 1 was where they wanted it to be to even support a launch at all. But Pad 2 was built with the lessons learned from Pad 1, both in terms of being able to be refurbed a lot faster and also to be able to support multiple launches in much closer succession because of its new design and not being able to be as roasted as badly. And not to mention the actual fitment of the booster with the hold down clamps and then also the BQD or BQDs in this case compared to Pad 1. They're operating on a lot faster timeline than I thought they were going to. This does not seem... This is going to sound kind of bad, but it's not intended to be so. With how fast they're being able to move, this doesn't seem cautious. So either they're throwing caution to the wind, or the pad is just this well engineered, and they are ticking off all the boxes that they want to the first time, which is both surprising and it's not, because it's surprising because it's a brand new vehicle, it's a brand new launch pad. This is the first time that we are seeing both sides of that equation being tested together at the same time, but also not surprising because both this booster and the pad were built from lessons learned from 11 previous Starship full stack flights. So, but safe to say that we were not expecting the testing that we saw earlier this morning, or I should say in the early afternoon there. No, it was still morning. Between being able to load prop as fast as they did, the DSS deluge, and all of that. Maybe a spin prime in there as well, but we couldn't see or verify it. So, yeah, dude, it's been quite a day so far.
And it's interesting with that speed and kind of throwing caution to the wind, because this is something I can almost guarantee we'll be talking about Friday, is the OIG report that came out today about its analysis into the lunar landers for the Artemis program, which includes SpaceX's Starship with the HLS variant. So yeah, EJ, you'll have some fun stuff to read for Space News over on your Twitch later. But
yeah, we'll probably do a deep dive into that. Sawyer, I'm not even gonna I'm not trying to presume, but it probably says it's too big and complicated to get done in time. That's my guess. But who knows?
It seems like it was kind of done before the whole reorganization of the plan, with Artemis 3 now being next year in Leo. But, I mean, they have to get a human-rated Starship into orbit for NASA to be able to test rendezvous and docking operating with by next year. They are on that time crunch now. And to be able to do that, you need to have a vehicle that can safely deliver an uncrewed version into orbit. Right now, they don't have that. So I feel like they need to get that speed up if they have any shot of doing that at all. So this is kind of a must-do situation anyway.
Yeah, I mean, SpaceX is really under the gun. I mean, so is Blue, for what it's worth. Like, with Jared Isaacman wanting to push those deadlines up for twin landings in 2028. I mean, guys, I know it's the beginning of 2026 right now. It's March 10th when we did this cast, right? Like, if you're watching on the VOD, hi VOD viewers, you guys rule. Thanks for watching this far into the VOD, appreciate it. It's the beginning of 2026. 2028 might seem like a long way away. That's not a long time in space flight, right, Max? That's not a long time.
That's basically tomorrow, essentially, for all intents and purposes. I mean, like, you blink, like, it seems like you just blinked, and last week was 2020. It's not. It's been spoiler alert. It's been 6 years since everything kicked off. Then, so in 2 more years to get to 2028, that's like next week in the space flight terms. That's not a lot of time at all.
Crazy. We got Matt's Mike Alpha Tango Sierra gifting 10 red teams in chat. Thank you, red team memberships. It's the kind of stuff that keeps us going here. Matt's, thank you. We love you, buddy. Appreciate it. Oh boy. So, in case you're just joining us, guys, we did see a little bit of testing earlier in the day. It's about, almost 1:45 out there in Brownsville right now in the afternoon. At 11 a.m., around 11 local time, we started to see some action with the booster, with booster 19 on the pad. Now, we didn't see any static fires, but we're not even sure if we saw a spin prime. All we know is they tanked this booster. They filled up the LOX tank almost completely, probably about 80 to 90% full, and then maybe 10% full on the methane tank. Now, they could have been just testing, like, all right, just fill it out and drain it. So first of all, they were testing with real propellant. So that was real methane and real liquid oxygen, which, obviously you want to check the plumbing systems on the pad to make sure it can actually fill the thing up. That's probably important, right? But they seem to have put the booster into a static fire configuration. Every time we've seen static fires in the past, Max, right? Like, it's a little bit of methane and a lot of liquid oxygen, right? And then the pad suppression system, not the sound suppressor, the pad deluge did turn on, and then we haven't seen much since. So the roadblock still is in place, right? But we're just waiting it out to see if there's any more action. You guys can see on the screen the booster is still a little bit frosty, but the propellants are slowly boiling off. But the tank farm is still very much active. So, I mean, we're gonna stay until the roadblock goes away. But we did see some action today, just for the people that haven't seen it. And we do have another road closure, Max. Right? When is that?
It came up. So literally, this new road closure was posted like right after the, I guess, quote unquote T0 that we saw after the test today. That is this Thursday from 8 a.m. to 8 p.m. local time in Starbase. So that could be just more tanking tests. That could be another spin prime, assuming there was one today, or there's a non-zero chance that could also be the first ever static fire of a version 3 super heavy booster. We're not sure. We don't really have any way to tell which one is going to be, one way or the other. But there's a non-zero chance that it could be a static fire attempt. Also safe to say, from that angle that we were just on, the frost, I think it's safe to say that there's no more propellant left in the vehicle, given how thin that frost has become. But it is obviously still very, very cold inside. But that is melting away rather fast now. So maybe, I think just based on what we've seen so far and based on timelines we've become used to, we can maybe expect the road to be open in maybe the next 40 or so minutes.
But
give or take.
It's worth noting they have the closure until 8 p.m. So they still have another 6 hours and 20 minutes left. And you saw how quickly they were able to tank that thing. As Alex was pointing out, it takes so much longer to detank a starship than it does to tank a starship. So we're not saying that they're done for the day. It is possible they could do it all a second time. Seems like they have the propellants to be able to do it. They have, obviously, the time to do it. So who knows? They might try and utilize as much of the window as possible. So you're just gonna have to stick around and watch with us because we're waiting to see what they do too.
Yeah, you know, there might be more action today. That we'll see. That's why we're here. Yeah, man. Dude, I'm like, I don't know about you guys. This entire stream, I've been trying to get my like tank watching helmet back on and get back in the game, so to speak. Here, I'm like, I gotta remember how to do this. It's been so long, right? I mean, when was the last time we tank watched? Ship. You know what? The ship that will not be mentioned. Is that the last time we did it?
Oh my God.
Oh my gosh.
But yeah, Max, you remember that? We were there together for that one.
We sure were.
Yeah.
But we haven't seen a booster at the pad since early October of last year, which was right before Flight 11. So this has been a long time coming. It is very refreshing to see. We are glad to see the tank farm working with a full flight vehicle again. It isn't a test tank. It isn't. It is not non-flight hardware. This is literally the booster that they are going to use for Starship Flight 12, being Booster 19. So actual flight hardware on the pad. We haven't had that in 5 or 6 months. So it's welcome back.
Wasn't that venting?
Venting noises. That sounds like, oh, you know what? There was just a vent on top of the booster there. Yep. That
There
looks
it
like
is,
depress.
Right by the hot stage ring.
Yep, that looks like depress.
That's a lot of. Wow, that's depressing. Oh,
Jesus Christ.
sorry.
Wasn't me
This is
this
your
time.
fault. This is
Wasn't me
your
this time.
Yeah, but it's your fault. You perpetrated this.
Also, the cowbell vents there right below the common dome. So yeah, that both LOX and methane vents are going. So that is that looks to be a full depress of Booster 19 being underway, which could signify that they are done testing for today, and the road could be opening. I shouldn't say. Oh my God, I should not say should be, but could be opening up in the somewhat near future, maybe 30 or 40 minutes or so, maybe less. But yeah, that looks like the booster is full on depressing at this point.
We don't know. You'll have to stick around, folks.
Oh,
I'm just trying to scare the people away. We like people.
I'm not
hanging
trying to
out with
scare
us.
anyone. I'm just making observations, Sawyer. I promise.
I'm lonely. I like having all of you in chat with me. This is nice. Anyway,
I mean,
sorry.
you know, so no, it's good, man. Don't worry about it. Sawyer, you might like that's the thing, dude. You know, we love hanging out with you guys, but it's possible. I mean, because like, okay, the one monkey wrench in this whole thing, like you said, Sawyer, is that they still have some time. They still have some time. They have 6 hours and 6 hours and 18 minutes now left in the road closure. They could be bringing this booster back to a stable state to test tanking again. It's possible. It's not like there's not enough fuel in the tank farm to do something like that. It's totally a thing. So you might not be wrong. We'll see. I mean, usually depress means, you know, we're done, but they could be testing booster recycle right here. I mean, that's something that you have to test. You're gonna have launches that you're gonna set to go, and then I won't say the S word, but and then they don't. So testing recycle, testing tanking, like this is all data right now that they're going to need to help understand, how Starship is super heavy in this case, how it's behaving, right? And to come up with contingencies. It's like sorry, you like flying flight sim. It's like every plane has a pre-flight manual, right? Like there's pre-flight checks. There's a whole manual on how to fly an aircraft, right? You got to go through a lot of training to learn how to read the manual correctly, right? But there is a manual for it. How do you know what the manual is? Has SpaceX written the manual for booster block 3 and ship block 3? No, you got to figure it out. So we might see some action again, Sawyer, right? Like you have to go through all the checklists, but how do the checklists get made? Right?
I mean, yeah, unfortunately, a lot of them get made in blood, but yes.
Oh, jeez.
But you learn as you go. That's kind of what it is. And we've seen that, obviously. See Flight 7, Flight 8, Ship 36, Booster 18. Anyway, you get the point. So, They got to figure it out. They got to. This is the first time also this pad has ever had the propellant running into a vehicle. It's the first time a Block 3 vehicle has received said propellant. And it looked pretty smooth. It's one of those things where, again, like we pointed out, if you have the time, might as well. Just like, again, Artemis 2. They had the time, so they did the recycle test once they were fully tanked, took it down to right before the terminal count, recycled back. Why not? It gets more data, more better.
Yep. This is, I mean, guys, the reason why I bring this up, and I know what people are going to ask, right? Like, they've flown starships before, right? Like, don't you think they would have figured out the manual from there? Yeah, that'll carry over in some way, shape, or form, but you got to remember, this is a new pad, new booster, new ship quick disconnect. Everything is new. There's not much with this pad that's, save for like the chopsticks and the tower, right? That it has in common with pad 1. Max, right? Like this is a totally new system.
Completely and totally, both from a vehicle and a pad standpoint. Launch mount's way different. The BQDs are different. The deluge is different. The flame trench is different. The vehicles are different, both booster and ship. The ship quick disconnect is different and cleaner. Chopsticks are shorter, a more updated mechanism to use them, so it's faster. Yeah, literally, it's brand new from quite literally the ground up. And also the tank farm as well, with those massive and very, very, very powerful pumps to pump propellant into the vehicle. So yeah, but that being said, because it's all brand new, it's untested. It's untested to this point. Well, not anymore. That they had their first test today. So they do have data. They have flowed propellant into the vehicle, and we are looking forward to seeing if SpaceX does end up posting anything about the test today to confirm what happened and what might be next. But yeah, Pad 2 finally has its first test with a vehicle on the books.
I mean, yeah, even the tanking, it was so fast. You guys, at around 11 local time, they basically like moved a insane amount of commodities into this vehicle in like 20 minutes, maybe. Like it was just like
I think from the booster being completely empty and the first signs that we saw prop load underway to being at what we presume to be static fire levels was 32 minutes.
Yep.
Which is absurd.
I just did a quick short for looking at it and timed it out. Yeah, 32 minutes.
That's insane. That's absolutely insane.
And that's what I mean. That tanking procedure is very different than super heavy block 2 on pad 1. This is a totally different ball game.
And mind you,
that thing up and sent it like real fast.
And mind you, I think that was somewhere in the realm of maybe 3,500 tons of propellant in total between the methane and the LOX. From what we could see, this looked very, very similar to what they do on Pad 1 for static fire testing and making the booster as heavy as possible while also reducing the risk of having as little propellant on board the vehicle as possible. And the way they did that, why they do that in the first place to make the booster as heavy as possible is to make it easier on the hold down clamps when all 33 engines are firing at once. They are not designed to hold the booster in place for a long period of time under full thrust or really much thrust at all. So I think it makes it a lot easier on them when the vehicle is just heavier. And so obviously to do that, they load the LOX tank up all the way, but because of that, they to limit the amount of combustibility that might be possible in a worst case scenario, they load as little methane on board the vehicle as possible. And that is always why we see a very small sliver of frost on the tank. But that being said, the methane transfer tube alone on the version 3 booster is about the size of a freaking Falcon 9 rocket. So that is a lot of propellant that they have to fill just in the transfer tube alone before we see any frost buildup on the actual main methane tank itself. So I think all in, we saw somewhere in the realm of 3,000 to 3,500 tons of fuel on board the vehicle today. And all of that being loaded in about 32 minutes. That's absurd.
Mm-hmm. Yep. So I actually got a question from Teddy West right in the chat. Sawyer, I'm gonna pop this one over to you. Teddy's asking, on the previous flights, did they have a post-flight farm conditioning, or was the tank farm still active? Why is the farm still active? Did they need that for offloading the ship?
if I remember rightly, there was still always some kind of tank farm activity afterwards. Because just like the booster, when you think about it, you also have those colder propellants running through it. And in fact, that was one of the indicators that they were getting ready to load the methane and the liquid oxygen into the vehicle. Was we started to see some of those lines in the tank farm get frosty. So it's not a surprise that there's still some of that kind of, vapors and venting from when they got everything super cool there. If they go again, you want to obviously keep it super cool. So it's possible they could go again with it. If not, this is totally not unusual to still see the tank farm active and chugging away at this point.
There's actually some people asked some really good questions in chat, so I'm going to keep that rolling if you guys don't mind. So Stevenson's Rocket here also. I like trains. Great name, Stevenson's. So Max, I'll throw this to you. Could Thursday's closure be for the booster to go to the dentist and get some extra teeth?
Well, no, because that is not a transport closure or transport window. So it is a distinct test window from 8 a.m. to 8 p.m. So there's going to be more testing at the pad taking place of sorts. The nature of which we're not entirely sure of. We can really only speculate. But that will only come once SpaceX is satisfied with the current round of testing that they have done so far, before they will have it rolled back to Megabyte 1 and have the rest of the Raptor 3s installed, before coming back out for a full static fire test with all 33 Raptor engines. So no, that is going to be for more pad testing. The rollback, assuming all goes well, could be maybe sometime next week. We'll have to wait and see when closures actually pop up.
Yeah, is it bad that in my head when I saw the engine configuration, my first thought was, this is the Jack Hughes of boosters
Dude.
right now?
Yes.
Yep. I said it a little bit earlier. I'm like, it looks like a hockey player.
Yeah, Jack Hughes, for those who don't know, he was on the U.S. Olympic team, also plays for the New Jersey Devils. Lost a couple of his teeth, so yeah, it's very fitting.
I mean, Sawyer, I'm not about to tell Jack Hughes what he should do, but I think he should get a gold tooth for the tooth that got knocked out. I'm just saying.
So there should
Sorry
be
to keep
one
rubbing you.
golden painted Raptor. Is that what you're saying?
Yes. Yes.
I like it.
Yeah. Yes, that's a good idea. We should do that too.
And that should be Raptor number 67.
Get
No.
out of here. Just get out of here.
No.
Carson, can I
passed
demote
that
him
brain
off the
rot.
show?
Also, it is going to take the gold medal for the most powerful rocket ever launched. It's going to take the medal from itself, which has the silver, which has the version 2, currently the more powerful, and then also version 1 had previously held the title. So right now, the 3 most powerful rockets that'll ever been launched will be Starship V3, Starship V2, and Starship V1.
A lot of starships. It's almost 3 starships. Okay, I got more questions here. This is from Chris W. What do you got for us, Chris? All right, here is the thing. If they're quickly filling a booster, how quickly can they fill up a stack now? You know what, Chris? I don't know. I'm going to guess fast. Boys, what do you think?
I think it's going to be in the realm of like between 30 and 40 minutes for both booster and ship, because they will be able to fill both or all 4 tanks, both LOX and methane, on both the ship and the booster simultaneously. So I think if all goes well, I think it's going to be somewhere in the realm of 30 or 40 minutes, which is, mind you, about as long as it takes to fill a Falcon 9 rocket, which is like an 1/8 or 9th of the size in terms of capacity. It's insane.
Yeah, my guess would be maybe, at least for the first launch, it'd be slightly longer, like 45 to 50 minutes, which is still
send it.
mind-boggling when you think of how much propellant that is, that we're still talking under an hour for all of this anyway. It's unbelievably fast, because you're also adding in the ship and the booster. That's a lot of propellant, man.
Yeah, crazy. All right, so we got another question here. This is a good one too. So this is Country Cook. What do you got for us? Cooking up something good, I hope. All right, so now I want Cracker Barrel, man. All right, is there any concern with a static fire attempt without 33 engines? Maybe unexpected vibrations if it's not properly balanced. So, fellas, I don't mean to be I'm going to answer the question, but see, I think personally, Cooks, I think that is on purpose. I think you might be onto something. I think those engines are placed in a very specific configuration to do like edge testing on like how the booster's going to take certain engines firing and certain engines not firing. Specifically, I think it has to do with the plumbing on the booster, like how propellants are going to get moved around in this thing when you're firing 10 engines or firing 5 or firing 3. I think they're there for I think they're in that, you know, kind of hockey player, you know, looks like you got a tooth knocked out configuration for a very, very good reason. And I think that might have something to do with it. Sawyer, what do you think? Do you think there's a method to the 10 engine madness that's on there?
It's SpaceX. There's always a method. And of course, like SpaceX, they're not going to tell us what that method is. If they do a static fire, you were talking about that earlier. My thought is they would maybe do a single engine static fire first, just test the system, test everything through. And it's also worth noting, unlike Pad 1, with the way this is oriented, you cannot get a dance floor out there. So it's not like you can add engines out at the pad. You would have to roll it back to load up all 33 engines again. So I'm sure there's a reason, but I don't know if we would see all the random 10 ones that they have up there actually fire.
You know what, fellas? The more I'm thinking about it, the less likely a single engine fire seems. And my rationale behind that is they already do that in McGregor. Granted, that's not mounted to a vehicle. That's just a singular engine on the test stand. But
see, that's what I mean. They got plenty of testing data, Max, on one engine firing. So,
yeah, right.
I mean, you know, maybe skip the single and then just go right to a 3 engine static.
Yeah. You know, maybe one for each ring. Like one of the inner 3, one of the outer or middle 10, and then one of the outer 20. I don't know.
I was going to say, because they only have E1 and E3 installed on that inner ring. They don't have E2 in there. So it wouldn't be able to test the center 3, so to speak.
Correct. Yeah.
Yeah, no, it's fun. It's fun to theory craft, guys. Like, to be 100% honest with you, like officially, like, you know, this is just me, Sawyer, and Max talking. Like officially, we're not 100% sure if they even did a spin prime today. But you know, it's fun to kind of sit here and think about the incremental testing. I don't know about you guys. I love doing that. I love putting myself in their shoes. Like, okay, what do you want to test now? What would you test? How would you do this? Well, how would you do that? Right? And that really, so Country Cooks asked this question. That's really why I wanted to put it up there, because this is one of those questions where you put yourself in their shoes. What do? Your booster plumbing is completely different. If the V3 boosters plumbing is completely different than V2, to the point where you probably can't, like, if this was any other rocket, I wouldn't even call this, like, if Starship is the name of V2, this would be like, you know, Super Ship or something. Like, this bears like no commonality except like maybe you know, it's made out of stainless steel with the previous super heavies. So, you know, that, you know, putting yourself, like, we're seeing a new testing regime kind of unfold in front of our eyes here. So kind of to think about like what they're trying to do and what they would be looking to, you know, test, you know, it's a fun thought exercise, right? Because this booster is completely different. You're basically starting from scratch in the testing regime, you know?
Yeah, correct.
By the way, it looked like earlier that one of the sheriffs was going to pull out, but it also looks like another sheriff pulled in.
Yeah, it looks like a couple of Cameron County Sheriff's officers like replaced a couple of the SpaceX security that was there. But that's kind of peculiar. It might mean nothing. That could literally just be a personnel swap, or it could mean that the road's staying closed for a lot longer. I don't know. I genuinely don't know. That's just an observation.
Yeah, it'd be weird to do a swap at 2 p.m. I don't know if that's a usual kind of rotation time for when SpaceX has their employees come and go.
Right.
Or Cameron County.
So, actually, so I'm double streaming this over on Twitch. You know, I'm not trying to plug my stream, just giving you people context, like giving everybody context. I got a question from over in Twitch chat that, you know, Spoiled Fruit over there asks, you know, could they just hang the booster off of the chopsticks and install engines when it's to the side of the pad? Like, you know, they don't have a dance floor for this that they roll under, you know, under like what we've seen before. Like they had a service gantry that went under the first pad's launch mount. Like, I suppose, you know, what's stopping them from, you know, lifting the super heavy off and just installing boosters right there at the pad? Max, do you think they do that? Yeah, yeah.
FOD. I mean,
Mhm.
it's not a clean environment, and with how much more open the engine section is on version 3 boosters, you're just asking for stuff to get in there, and cause issues. So I think that SpaceX wants it to be in a much cleaner environment. They're not in the version 1 or SN days anymore. Like Starship cannot be classified as an experiment anymore. SpaceX has their own clean areas to install and remove engines now. So yeah, I think FOD would FOD or foreign object debris would be. Oh, is the
They're
road
leaving.
opening?
There's cars
Lights are
lined up.
off. Sheriffs
I
are
should say
moving.
Cybertruck's lined up for sure.
Guys, the sheriff shifted his car into reverse.
This
Breaking
just
news
in
stinger.
breaking news.
Breaking
stinger.
news. I'm sorry.
I swear to God, Carson, don't do it. Don't do it. Do not do the stinger. Do not do the stinger.
Also, can I just
Oh, he did the stinger.
Also, could I just point out, by the way, if they did do it while hanging off the chopsticks, isn't that kind of an OSHA risk of like, yeah, this thing's just dangling midair. Let's stick some engines on it rather than on a
Yeah, I
secure
wouldn't do that.
stand in.
Yeah.
in the
That's
bay.
also a very valid point as well. Yes.
Yeah, I wouldn't do that. Yeah, that you know, I thought I'd ask the question, and now the more and more, like, once again, putting yourself in their shoes. Yeah, I wouldn't do that. Yeah, that's probably not a good idea. And guys, it seems like the road is open.
And that does essentially confirm that testing is complete for today. Because once the road is reopened, they cannot close it again, as far as I'm aware. I could be. Is that right? Or am I wrong on that?
If they open the road, why would they close it again? You know, you have it closed down.
Yeah.
and
Okay.
the closure's gone, by the way, from the website.
Oh, good.
Here you can see.
Okay. So they are done. That is it for today. They are done.
Yeah, they still have the one on listed for tomorrow, it looks like. Listed as a primary now as opposed to a backup. And then we have the one on the 12th as well that we just got the notice of earlier. So
Wait,
interesting.
they put another one in tomorrow, Sawyer.
I'm looking at this now. Beach access status, because they had a backup dates of the 10th and
Yeah.
11th, with the primary originally being the 9th. Obviously today is the 10th, and then there's the one tomorrow. So this is new.
Huh.
This is brand new.
Oh.
We saw the one for it pop up right after they did the testing, saying the 12th. This says the 11th. That's tomorrow.
Dude, we might see some action tomorrow. I'm here for
Yeah,
it. I want
baby.
more tank watching. I don't know about you guys.
More Texas tank watching. Also, yeah, where's the one from the 12th now?
Wait, what the heck?
What the heck?
What the
SpaceX
heck?
going to space? Did you miss this, guys? This is SpaceX.
Oh wait.
being SpaceX again.
Carson, scroll down. Scroll down. Apparently, it's below that.
I think we've established that the 12th is further down.
There
Turns
is
out the 12th is
and-
after the 11th. Go figure.
12th and 13th as a backup.
Wait, what? Since when, Sawyer?
I know. Shocking.
Huh.
So, but that's two primary dates then. So there's the beach access closure on the 11th, and then the full-on... Is that a full-on road closure then for the 12th with the backup of the 13th, if I'm reading that right?
Correct.
Huh.
Yep. Har.
Interesting.
All right.
Har.
Well, I
More
think
testing.
I think we're going to be spending more time with you guys chat tomorrow and the day after, I think.
And the
Yeah,
next day,
buddy.
And the next day. And the next
And the next day. And the next day.
And the next day. And the next day.
You finish
then-
those errands?
Yeah.
And then Friday we have the flame trench too. So we would have testing, flame trench.
Oh boy. This is
Welcome back. Starbase testing. Let's go.
This is
Heck
gonna be a
yeah.
fun week, man. Oh dear.
Well, I'm sure there's still a lot that we're going to be having to talk about with this over the next couple days, and even just from the testing today. And I know that we're going to have the whole idea of people are probably wondering, wait, what about the Raptor side for today? Well, we still have that Raptor side coming up. Don't you worry. As soon as we finish things here, we will have that Raptor side for you over on Starbase Live, which, in case you didn't know, we have Starbase Live, our 24/7 live cameras over at Starbase, where you can see all the action going on all the time. So keep an eye out for that. Basically, whenever. We also have cameras over at McGregor Live if you want to see them doing that engine testing. like, well, not tripod test anymore, but any of the other Raptor testing they do over there. And then, of course, we have Space Coast Live, which is our 24/7 watching all the activity there, including everything we're able to see with the Starship pads, and when we see those sections of the pads of the towers rolling by, heading over to 37 for Starship over there.
Okay, so I think it's time to put a bow on this one, this round of Texas tank watching. But like Sawyer was saying, plenty of action, and we got plenty of more Texas tank watching streams for you this week. You know, pending these road closures, I guess sticking. We'll see. So there was a lot of people to thank. I'm just we were just the closing pitchers here, Sawyer. Like what we were saying, like there was the morning crew that jumped in. We had Alex, we had Ryan Weber, we had CB, we had Carson, all the Starbase Live operators. Gage had his camera out there. Chris B, yeah, CB.
I was actually trying to get something to eat, and they opened the pad right as I finish.
Huh?
That's so unfair, SpaceX.
What did you have to eat?
I just had a warm mug of hot cocoa, basically.
That was your lunch?
Alex, that's a liquid.
Well, with muffins and things like that, I sort of let them soak in a little bit of the cocoa, and it's really tasty.
All right.
Marshmallows or no marshmallows in the cocoa?
No, I don't.
Why? It's the best part.
That's not
all
a
right.
thing in Spain. I'm sorry. That's an American thing.
Well, that's a shame. Anyway,
It should be a thing in Spain, just saying.
okay, so and obviously we're gonna close out the crew here. Sawyer, thanks for jumping in. Do appreciate it. Popping in at the last second.
Yeah, absolutely. Give Alex a chance to get a bite to eat and get to talk about, Texas tank watching again. I love it. Glad to be here. Thanks for having me back on.
Absolutely, Max. Do very much appreciate you coming in here and hosting and commentating on the stream with me. It's a good time.
Pleasure as always, EJ. Yeah, that was a fun morning. Pleasant surprise, I think we can all say based on what we saw. But based on just the closures that we have seen and the evidence in front of us, there is a lot more to come. So stay tuned, and we should hopefully be back with you tomorrow or the day after.
Yep. Alex, you're here now, so I'm gonna thank you, despite you having marshmallowless hot coffee or hot chocolate. I'm still gonna thank you. Thank you for being here.
Look, it was the fastest that I could make it. Like
Yeah, that's fair.
without making a lot of other food. Anyways, thanks for having me as always. It's been fun. It was a very surprising and very gratifying.
Yeah, it's fun. It is fun to tank watch again. It's very fun. I really enjoy it. Guys, I am EJ. I stream over on Twitch. I've been your host with the most, your master of ceremonies for the last, actually about 3. Man, was that 3 hours? That was 3 hours. How? Oh,
Yeah,
dear.
and the stream started 5 hours ago.
Whoa. That's crazy. Anyway, I do stream over on Twitch. We will be discussing more space news and tank watching over there. Twitch.tv/EJ_SA. Anyway, guys, our time for tank watching today has concluded. So we will see you guys in the next one. Thank you very much for watching. Carson, on the pulling the buttons and levers, roll us out, buddy.
And here we go.
There's the W. Here's ignition.
Doubling up.
Did it just do a Kerbal? Back to the moon and beyond.
Put that in the big bag, Gino.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect flow.
Propulsion continues to be nominal.
We did have an observation.
Equalize.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center. Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No.
Oh my God.
Yikes. You bet. We don't need any more of these.
And I'm back. What's going on, everybody? How about that? Dude, I'll admit I'm kind of all over the place now because I thought I was going to be there for the day. I honestly thought that. I thought we were going to sit back and we're going to see a long night of testing, and then SpaceX did it and they were like, okay, bye. And I'm like, all right. So now I'm all screwed up. Yeah. That pad isn't spanking new now. Yeah, right. Tank watching is back, baby. Yep. Good stuff. Good stuff. So, yeah, I didn't really have anything else planned for the day, interestingly enough. To catch up on space news from yesterday. Yeah, that might be the right thing to do. Work on the car? I mean, Factorito. Let's do space news first. Yeah, I played a lot of Factorio yesterday. I played a lot of that game. That we played a lot of that. That OIG report is going to take some time, so I think we'll plan for probably space news. But I mean, we could work on the car if you want. But like that's the thing. If we do space news at 5, that's not a lot of time. Hey Carson, what's up, man? 8-month resub. Good producing today, dude. You were on it with that CRS3 footage, man. I forgot to say it. You should have showed it. I was like, dang, dude. Yeah. Well, if Factorio isn't your thing, I'll tell you what. We can talk. We'll talk more about it during space news. But if you guys haven't seen the Defense Advanced Research Projects Agency, or DARPA for short, rolled out with a new concept vehicle called the X-76, which is a hybrid jet. It's a hybrid jet tilt rotor thing. I think we should make this. I think we should make this in KSP tomorrow for Wings Wednesday. I have something that's very similar to this, but it's not exactly the same. But I did work on a vehicle that looks almost exactly like this, which is very interesting to me. Hey, Lafaloop, what's up? Completed, got 100-month resub. Thanks, man. Have you gotten tickets to the oncoming Rush Tour? I actually haven't, no. I haven't. I should when they come by here. Give me 1 second. Okay. Yeah, it's got a freaking V-tail. It does look like video game concept art, doesn't it? It's yeah, so like the blades like fold back and stuff. Like it's pretty crazy. I think that's super freaking cool, actually. So DARPA hacked your KSP saves. Dude, the only big difference between this design, like that design, and DARPA's design, my design and DARPA's design, is that mine's an auto gyro and theirs doesn't auto gyro. That's the only difference. It's the same exact concept, which is bananas to me. Yeah. What I'll probably do is take my auto gyro, take the K92, and just retool it with those engines. I actually have a sick idea about how to get this to work really, really well with the Goliath engines. Man, now I want to work on that. If we get into that, dude, it's give me 1 second. I think I'm gonna save it for tomorrow, but okay. Here's what we're gonna do. Here's what we're gonna do. I got some food. I actually have a meat, or not a meatball, a steak and cheese sub that I have over there. It's actually sitting on my oil heater to keep it warm. Don't worry, the oil heater doesn't get enough to light it on fire. It's just keeping it warm. I think I'm gonna eat that. I'll put on a video for you guys, and I think we'll come back in a half hour and we'll do some space news. What if it's static fires tomorrow? Oh yeah, that's a good point. Yeah, they're not, it's not electric Aqualex. DARPA actually showed pictures of, their test rig. They showed pictures of their test rig. They sent it down the rails at Holloman. It's a jet engine. It's a turbofan turbo shaft hybrid, which is super cool. My guess is that there's a clutch on the N1 turbine, and the clutch goes to the rotor blades. That's my guess, through a reduction gearbox. We can't make that exactly in Kerbal, but I have an idea on how we can do it. Not electric overall, electric powertrain, think Edison. So you're talking about a hybrid turbofan turbo shaft, or a hybrid turbofan gas generator. Or gas turbine, not gas generator. That'd be pretty sick. I hear N1 and all I thought was big explosion. No. Skip all the gearboxes. I mean, yeah, no batteries. With no battery design, yeah. I mean, it's not a bad idea. I mean, it's just all the wires and stuff might be a little heavy, but I'm not sure it'd be any heavier than a gearbox. It really depends on what kind of electric motor you're using. You know, you'd need one beefy freaking electric motor. I mean, honestly, it'd probably be going through a reduction gearbox too. Unless there's some kind of industrial electric motor application that's light enough for aerospace that can move 3 big honking blades like that, you know? Yeah, this one, guys, the one that DARPA has, the X-76, is a that's drive shafts. The engine's actually back here. It's way in the back. I gotta find that footage of the test sled. It's wild, dudes. It is really weird. This thing looks totally strange. If you could switch the title to help Mr. Drummer. I'll just change the title to no. Sorry, only understanding a bit. Do you need a windrunner? What do you mean? DARPA posted the damn tests. I looked at the stupid thing. Where's that freaking footage, man? Hey, Kuro, what's up, dude? Did you fix the car yesterday? I got the panel painted, and we have to weld it in. We'll probably do that tomorrow. Tomorrow morning before the tank watching happens. I'm trying to find that X-76 footage. Did you watch paint dry? Oh, yeah. Where the heck is it? I can't find it. We saw it yesterday. It was on yesterday's stream. But, I don't know. Anyway, dudes, what I will do is we'll talk more about it. Yeah, we'll go live for Space News. Hat sign former Packer Romeo Dobbs. Okay. Oh, wait, hold up. I think I found it. It's just a picture of it, but here, that's good enough. Look. So they have a test demonstrator. It's out on the rails at Holloman. So at Holloman Air Force Base in the U.S., guys, in New Mexico, it's out in the middle of White Sands test range. There is nothing, and I mean nothing out there, and it's totally flat. So they have tracks out there that are like 20 kilometers long. They're ridiculous. You could, here, I'll show you. You can see them. And this isn't like anything that isn't well known. They use it to test I don't know, anything that needs to go fast in a straight line. See, this is White Sands, and Holloman is right here. See those lines? Those lines that's not a highway. Those are the rail tracks. They're train tracks, basically. I mean, they're train tracks, and it's just a railroad line. I don't know. If you need something to go fast, it's just a railroad line that quite actually just goes on for miles. Right? That was a long distance that we just covered. Here, I'll show you. Yeah, I did remember that right. It's 16 kilometers long, so it's 10 miles on the dot. That's an extremely long track. And what they do is, I don't know, anything that needs to go fast in a straight line, boom, there you go. They use it to test missiles. They use it to test all kinds of stuff, and they used it to test this. That's the mechanism for the prototype mechanism for the X-76. So you have what looks like, to me, you have it looks like a jet engine, but it also looks like a gas turbine. It's kind of halfway in between. And then you have your reduction, and then you have your rotor mechanism. So this part has to work like a propeller engine, and this part has to work like the jet. Now, how is this different than like a regular turboprop? So a turboprop is a jet engine, a propeller that's powered by a jet engine. That's basically what this is, but this thing can switch to making thrust. Turboprops cannot make thrust. The thrust comes from the propeller spinning. This, mute the music. You found it, Animal? Yeah, here. Look at this thing. This looks, dude, I was watching this yesterday, and it looks like a damn Kerbal contraption. So I was like, we got it. Gotta watch it. So it's at TRL 5, which means that's gonna happen. Technology readiness level. There is the high-speed test track. We can't. Guys, the YouTube stream isn't live, so we could probably get away with it. Another interesting thing to note, guys, is that there, if you look, there's stators. It cut, right? There's stators that are holding the front of that prop together, which is very interesting. I'm not sure you're going to be able to do that with the actual thing, but there is a stator that's at the end of the drive shaft picks up on. It's holding it in place. I'm wondering how they're going to do that with, you know, it's probably there because it's a test, but look at that. So it's a propeller, right? Wait a minute. What the hell is this? It's got a jet engine down there. There's a jet down there, and then this is two separate motors. No, there's a jet engine down here, and there's a turbo shaft right there. I didn't see that yesterday. The X-76 is 3 engines. See the stator that's holding that thing in place? Oh, I see how they do that. Look, so it has a swash plate because it needs to turn up and act like a helicopter. They're actuating when the blades are in the folded position. Your swash plate is working like your retraction mechanism. Dude, that's actually super freaking cool. That's really, really neat. That's some real trick stuff. Actuating the swash plate in the retracted when the blades are retracted. So the swash plate makes the prop feather, right? And it also can cycle the propellers so it can work like a helicopter, right? But look, when the blades are in the folded position, here, hold up. When the blades are in the folded position, swash plate actuation is your retraction mechanism. That's some trick. That's some DARPA stuff. That's super cool. Look, bro. It's using your collective actuators for retraction. That's really freaking cool, actually. That's really, really cool. No, that doesn't sound sketch. That's actually really smart. That simplifies the whole mechanism. Brother, let's freaking go, dude. That's super cool. Kind of works like an umbrella. It works exactly like an umbrella, dude. Yes. Yeah. But when the blades are actually out and when they're not kind of like this, when they're out like that, that swash plate uses to modulate blade pitch. Like a helicopter. Smart, dude. That's a really good idea. Like that's some brilliant mechanical engineering. I'll say this right now. That's really freaking cool. Yeah, that's why this thing is being greenlit for flight, because somebody figured out how to use a swash plate as your blade retraction mechanism. That's really goddamn smart. So you guys were saying that this thing has 3 engines, right? Where's the DARPA stuff? All right, DARPA.mil. Wait. Look at this. Okay. What do we got? Eliminating one of the battlefield's most difficult choices. Yeah, so low speed, the blades pop out and the engines tilt, right? And it'll work like a V22. Only, guys, I'll be 100% honest with you. This has way less moving parts than a V22. Way less moving parts. Read what I wrote. Looking at the art, the gearbox shown on the test stand takes up the entire length of what looks like wingtip engines. Are we sure this isn't rear engine electric power? Sprint's experimental aircraft revealed as the X-76 is now being built by Bell Textron Incorporated following a successful critical design review. Big deal. The designation places it within historic lineage of X-planes that have... Okay, yeah, cool. Sprint is a program joint effort between DARPA and U.S. Special Operations Command to advance technologies that could break the long-standing military trade-off between high speed of fixed-wing aircraft and agile runway-independent operations of VTOL, vertical takeoff and landing. The design, construction, and flight of the X-76 will drive, innovate... All right, cool. Sprint began its second phase, Phase 2, in May 2025, following the down select to Bell. With the successful completion of the critical design review, the program will shift to focus manufacturing, integration, and assembly, and ground testing of the X-76 demonstrator. The demonstrator will mature technologies needed for a transformational combination of the following capabilities: cruise speeds in excess of 400 knots, hover in austere environments, operate from unprepared surfaces.
Discovery, go at throttle up.
Is that what... That's what that says. It's the same thing. Where did you guys get that this thing has 3 engines? I'm confused. You would still want a synchronizer. I agree. Look at the picture. Wait, what the f... Okay, you remember when I said this is like my K92? It's not like the K92 at all. This is... Yeah, the intakes. There's the jet engine back there. That's why their sled... That's why the sled has a different differential jet engine. See the jet engine down there? That's not part of this mechanism. That link sucks, Baron. Yeah, I don't know. How long did this travel? This track looks like Mythbusters. The one that the Mythbusters used is in California, Zizep. This is Holloman. This one's 16 kilometers long. Look, you can see the curvature of the freaking Earth, dude. It's nuts. These tracks are out in the New Mexico desert. It's not far from where Das and I did the Spaceport America Cup. That's actually over the mountain range to the west. Yeah, Jaeger, this track, it's railroad tracks. It's just straight railroad tracks that go for 10 miles straight, or about 16 kilometers. They use it to test stuff. I'll show you. They use it to test things that go fast. Here's a good example. Wait for it. Don't blink. Did you see it? It's like the bullet train. Oh, that's going way faster than a bullet train, dude. That's going way faster. Is that the Roadrunner? Meep, meep. It was a Supra. Yep. So the reason why you can't really see the missile and why it's on fire is because it is encountering re-entry heating. It's re-entry. That's what's happening. It's re-entry, but on the ground because it's going so fast. See the sparks and everything? That's the flash first tryouts. Nice. Does this work? Yeah. Yeah, so those tracks are used for missile testing and stuff, which is super cool. Yeah. It does. Yeah, it has the motor in the back, a singular motor in the back. Oh, is it bad if I don't like it as much because of that? Is that bad? Do you think it has a tail door? No. No, I think that this vehicle is designed to serve the same functions as what a UH-60 does. A UH-60 does not have a tail door. I mean, it looks to be about Black Hawk size from what I'm seeing here. Needs twin ion engines, not a single. Yeah, right? Right? There's it in the wind tunnel. No. Did NASA use this type of test end to test re-entry heating of capsules? Yeah, yes and no, Akimi. On this scale, you could just use an arc jet. An arc jet is basically a re-entry wind tunnel. Yeah, Yarg. My only guess is that center engine can... Your center engine is either driving those two. Your single engine is either driving both of those through a centralized drive shaft and gearbox here, or it's got 3 engines in it. These are Bell concepts. Look up top. Now I'm even more confused. No, Krayla, the jet engine doesn't create nearly as much torque or moment as the propeller blade, dude. Can it attach a tank under the tail? Man, I certainly hope so. That would be really nice. What I'm reading is that if it's a single engine, there are no intakes on the rotor pods to house an engine. Yeah, but it's interesting because these clearly show an exhaust port there. And on their test sled, no, not that one. On the test sled, Yarg, there's clearly a turbo shaft. Like, see, there's clearly a turbo shaft there. That's a propeller engine. And that is what's driving that propeller. Now, the real question is, does the actual one have that? Like, that's definitely a gas turbine. Turbo shaft start. Turboprop launch. Yeah, Zelencho, I'm kind of thinking the real one will have that too. Interesting. No. Eat your food already. All right. Oh man, I had a really cool idea for this thing, but yeah, it's not really gonna work with their engine, with how they have their engines configured. I'm thinking the third engine is needed for the propeller jet change. Yeah. Would the rear engine provide thrust vectoring? That, yeah, maybe. I don't know. Any other pictures? Huh. I think the third engine is for top speed and plane mode. Were you thinking of a ducted fan? I was thinking that this is a jet engine. I was thinking that there's a jet engine in there that can switch, but yeah, I guess not. Yeah, it looks like there are uncrewed variants of it too. It's like that UH-60, the drone UH-60 that the U.S. Army announced a little while back. Did you guys remember that? It's a Black Hawk that has no seats, no nothing. It's flown like a drone. Like you could pilot it remotely, and where all the people and all the controls and all the gauges and everything, there's just a cargo bay, and it just opens up and you can deliver trucks or supplies or whatever. No intakes on the wingtip nacelles, no exhaust on the output. Yeah. I'm 90% sure that it's electric. I think you want it to be electric, and I think there's no way to prove it. Yeah, O-Force, it supposedly can V-22 itself. You know, you'll tilt rotor and land. I don't like the 3-engine configuration, guys. I don't like that. I've decided, yeah, there's clearly an engine and there's intakes on either side of it, so I don't like that. The engine in that intake may have been a placeholder since the electric motor doesn't exist yet. Kraken, it would not get past CDR if that was the case. It would not get past CDR. Or whoever did get it past CDR is not that's not a good way to manage a project, dude. I could build this in Kerbal Ram a lot. I think I'm going to. If not today, tomorrow. Wait a minute. Oh. Look, fellas, 2024. Huh. The CDR for the vehicle passed yesterday. This test is from 2 years ago, though. So maybe. What? Baron, this is what they were competing against? Is that a plane with 2 F-35B engines stuck in it? Actually, that's a really good idea. 2 or 4? I don't know. Blended wing. Oh, what? No. No. No, 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 no. What are you doing? No, no, not 3. Why 3? That makes no sense. Stop it. Why do they gotta complicate it all the time? Stop it. That's an aerodynamics demonstrator. I know. I'm kidding, dude. I know. I know what it is. Actually, so the Dornier, I don't know if you guys are familiar with the Dornier DO-31. The Dornier DO-31 is a plane that was made by a German aircraft company called Dornier in the 60s. It's 2 Harrier engines on the wings. Those are 2 Pegasus engines. So you have 2 Harrier engines, right? And it could VTOL. But they didn't. I don't know why they did this. And this is like slightly cursed. I think they ran into a negative mass margin. The 2 Pegasus engines weren't enough to lift this thing up in the air. So there's 4 smaller turbojets in the wings. That's what these big nacelles are. They're 4 downward facing jets. Because Dornier, pronounced Dornier. No, I'm saying it the way I want to say it. Yeah, the 2 Pegasus engines, I like that part, but I do not like the up and down jets in the wings. I hate that a lot, actually. Yeah, that's cursed. Why? Stop it. What are you doing? That's why would you do that? Are you drunk? At that point, just add 2 more Pegasus engines on the wings, dang it. Halfway down this page, it describes the engine layout. Earlier this year, the team completed the first of 3 major tests scheduled to validate the feasibility of the FIW technology. The ground effect test conducted using a 4.6-foot, 1.4-meter wingspan model with 3 lift fans showed that suck-down effects created by the lift fans and hover were negligible and that the landing gear is set to the appropriate height to minimize adverse pitching moments during from ground operations. Okay. Can the Harrier even take off vertically with a full load? I thought I could only take off with like 50% fuel. Ski ramps, Katra, yes. That's the old link. Wrong link. That's the old link. I just clicked the... Oh, it didn't paste the right thing, Yarg. Hold on. Okay, here we go. This was the last render of it before it got canned. Oh, that's actually kind of sick, dude. That actually goes kind of hard. Kind of dig it. Before we read this, Yargles, look at this thing. That actually kind of goes pretty hard. I hate the center lift fan, though. Please go away. I don't know what that means, caretaker, and at this point, I'm too afraid to ask. Anyway, all right, let's read this. What does it say? The goal is to create an aircraft that can take off. Yeah, okay. It VTOLs, but it could fly like an airplane. All right. The basic problem with rotorcraft like the V-22 is that the large rotors providing lift and propulsion are an inherent limiting factor. At high speeds, the rotors generate significant drag, which worsens as the blades spin faster. That means the Osprey can only reach a top speed of about 270 knots. Okay. Ideally, the best solution is to get rid of the rotors when the aircraft transitions into high-speed horizontal flight. The X-76 does this by stopping the rotors and folding them back against the nacelle body where the engine converts to a full turbojet configuration. That sounds simple, but it requires eliminating the complex gearbox of the Osprey and replacing it with a new configuration that incorporates two distinct thermodynamic cycles, one for static lift and one for high subsonic cruising. While hovering or during vertical takeoff, the X-76 operates like a conventional tilt rotor. In this mode, the high-performance turbine core engine drives a shaft connected to the rotors. As the aircraft accelerates forward and the wings begin generating lift, when a critical speed of about 150 to 200 knots is reached, the clutch rotor disengages from the rotor and the rotors feather as they fold. As this happens, the engine's power is redirected through a conventional jet nozzle at the rear of the nacelle. Without the drag of the rotors, the X-76 could reach speeds of over 450 knots. The prototype is projected to carry a payload of about 1,000 pounds and have a target range of about 1,000 nautical miles. So there is an engine. There is engines in there, in the nacelles. There is engines there. But then again, that's not... This is from newatlas.com, so who knows? If there's engines in the nacelles, what the hell is this thing? More engines, I guess. Oh, yeah? Yeah, that sounds right. Isn't 400 kilograms not that much? It's supposed to be... So, ASHAC, it's supposed to be replacing a light helicopter, like a UH-60 or a UH-1. Oh, yeah. Or if you like Warsaw Pact stuff, like an Mi-17 or something like that. It's not supposed to be crazy. It's supposed to be just a small, like think UH-60. It's supposed to be replacing a Black Hawk. The engines in the cells only need to be powered enough for a certain transition speed. How much could an Osprey carry? I don't know off the top of my head. I'll look. An Osprey can do a fair bit more, just due to the nature of the design. You need two engines, so I bet you it can do more. And not a lot of people know the V-22s have the same engine that's in a C-130. That's a highly hot-rodded C-130 turboprop. Yeah, I don't know if a lot of people know that. Also, the V-22 has an asymmetric configuration. The APU is in the nacelle. Yeah. There's an APU and then a fuel tank on each nacelle. It's asymmetric in its config. Pretty cool, huh? Capacity for 24 troops, 20,000 pounds. It can move a Growler? Oh, look at that little thing. Look at all these little things. So busy now. The interim fast attack vehicle is used by Marine Force Recon. Is that a G-Wagon? That's a G-Wagon. Okay. What's the name of the new thing that the Army has? What the heck is the name of that thing? Yeah, it's the Colorado. It's a Colorado. It's a Chevy Colorado, but with nothing on it. Here, hold on. ISV. Yeah, it's a light truck that Chevy makes, but there's this freaking mil-spec version of it that they make. It's probably down here on the wiki somewhere. The mil-spec version has no bells and whistles on it. It's just... Yeah, there it is. Yep. It is... Yeah. It's a Chevy Colorado with no bells and whistles. It doesn't even... Yeah. Not even a cab. Look up. I found it. Dill hole. Relax. I know about Endural's Fury, yeah. Andril's. I always say Endural. It's not Endural. It's Andril. $155K a pop with spares and training. You know what would be a good idea? Take that and make it into a post van. No, I'm not even kidding. I know what people are going to say. 150 G's for a post van? Yes, it's cheaper than that NGPD piece of junk that they have now. A Warthog for Postal Service? You know, Hokey, you shaking your head, but flat fender Jeep CJ2As, mil surplus CJ2As were some of the first post vans. Post World War II. Yeah, the Postal Service used surplus mil spec. They used all the Jeeps. So it's not the stupidest idea. Like, here. So they took Willis Jeeps, right? And because they were already making a ton of them, and they put a post van, the back of the post van on these things, and made it into a postal carrying vehicle. It's not a bad idea when you think about it. It'd be pretty much good everywhere. I love you, bro, but here's the patent for the design. Ooh. I mean, if the military's going to buy a lot of them, Hokey, the price is going to come down. Not the stupidest idea. Oh, that's smart, dude. That's really smart. Yeah, the actuatable swash plate, and then it has blade clamps at the end. They have blade clamps. This patent is for the exemplary clamp system. Cool. Too many moving parts. See, that's what I mean, dude. If that X76 has 3 engines, then I would say that's why. That's too many pieces. It's too many parts to the puzzle. It really is. If it had 2 that were synchronized like the V22, I'd be cool with it. Heck, if it even had 1 that's powering both of those engines, then I'd be cool with that too. It has 2 drive shafts going out in the wing. That would actually make things very simple. But it doesn't. It seems to have 3 engines, which I'm... All right. I mean, that center engine could be an APU, guys. It's possible. On the X76, if it's combusting on the wing tips... Yeah, Stovall. People aren't estimating it's the progress we've made in electric motors. Auxiliary power unit, tropical fish. So a lot of, let's take like a 747. You know, a 747 has 4 engines, but it doesn't. It has 5. There is an engine in the very, very tail, but that engine doesn't create any thrust. That engine is hooked up to an alternator, and it generates power for the airplane when your main engines aren't on. Every airplane does have batteries, right? Like a 747 has batteries on board too, so it can operate off battery power with no power generation. Like if your car still has a key and you turn the key to accessory mode, the engine isn't on, but all the systems are powered. Planes can do that. But they also have a way to generate power without turning the main engines on, and that's what an APU does. Yeah. Like if you look at the back of a 747, there's a huge exhaust coming out the very, very tail of the airplane. There's a jet engine back there that generates power. So like when a 747 is at the gate, right? Or any plane that has an APU, when it's at the gate, you don't want the engines running to generate power, right? Because somebody will get sucked in. So, somebody will go put the luggage in there, it'll get sucked through the engine. You don't want that. So they turn the APU, that APU on. If you've ever flown on an airplane and you've boarded, right? And you notice that the plane is either taxiing or while you're pushing back from the gate, all the power systems shut off for a second. And then everything comes back on. And if you're on the plane's Wi-Fi, it screws up and you can't connect on your damn phone for the rest of the flight because it's screwed up because it's using Viasat. You know what I'm talking about? That's the handover. It's the switch off of APU power to main power. That happens when they start the motors. Some other planes don't have auxiliary power units at all. They just plug it in. Yeah, just plug it in. Plug it into the grid and it'll charge. Yes, VO, I like that. That's pretty cool. Or there are Tropical, we're kind of getting into the weeds here, but somebody mentioned a start cart, and I'm not gonna not show you what a start cart is or what it does. So certain engines. So this is from Haberbrats, which is Haberbrats is a SR-71 history account. Really good. They're on X and on Instagram. So the AG-330, this thing was used to start the it's used to start an SR-71 because the SR-71 could not have didn't want to put a starter motor on it because it's too heavy. So they had a cart that they towed out, and where it says AG-330, there's an output shaft, right? So, and that you connect it on a removable drive shaft, like on a tractor almost, and you could start the J58s that way. The start cart has 2 big blocks in it, 2 big block car engines from the 60s. So that's an older start cart. That's an older AG-330. You could tell because it has blue valve covers. Those aren't Chevy engines. That's a Buick Wildcat engine. The two Buick Wildcat engines proved to be not powerful enough. So in the 70s, they switched to two Chevy big blocks, 454 cubic inches, which is a, what is that, a 7.3 liter, two of them. And they output into a common drive shaft and a gearbox that goes up into the engines. That's how they started SR-71 motors. Yeah, it's two big block Chevys. Yep. Now, the funny thing is that the SR-71 engines can restart in flight, but it's not with a starter motor, and it's not using bleed air. Who knows how they restart the engines? The J-58, because the SR-71's a turbo ramjet. At high speed, it shuts the jet off, and the ramjet does its thing. Who knows how they started the engines back up when it transitioned out of subsonic? Or into subsonic? Do they use airflow? I mean, to spool the turbine, you still got to turn the combustor on somehow, Ponzister. T-tab. Triethyl aluminum and triethyl borane. The same thing that Falcon 9's engines start with. Yep. T-tab. Now, the engine's going to spool from the incoming air, but you need it to really spool up to start it, right? They had triethyl aluminum and triethyl borane cartridges they're radially mounted to each other, and they impinge inside of the combustors on the J-58s. Yep, T-tab. JP7 wouldn't start any other way. That's right. Nope, no ram air turbine. Good guess, though. Yeah, pretty cool, huh? Yeah, the T-tab cartridges are much lighter than a starter mechanism. That's why they did that way. So if you remove the starter mechanism, you have the T-tab to start it, but you don't want to do that on the ground when someone's standing next to it, right? So, start cart. Pretty cool, huh? Oh, really important about APUs, they provide bleed air to start the engines. Jet engines won't start without air. You know this, but a lot of your community may not. Yeah. Yeah, how they start engines. Yeah, a starter would be bleed air, where you just, it would be like if you had a, compressed air, and you had a computer fan, and you would, and it starts spinning it pinwheels it. Yeah, that's how most jet engines start, right? Yeah, that's cool. Good addition. Didn't they use small explosive charges to start old prop planes? Shotgun shells. Shotgun shells could. That was the starter mechanism for for tractors back in the day. Here's the full X76 patent with power deployment. Oh, we're doing a little deep dive on airplanes. If you're wondering what the hell's going on in here, this is not transferring the links correctly. Okay. Yeah, shotgun shells. Shotgun shell produces a jet of hot gas. Yeah. It's a shotgun shell, and that'll start it. All right, let's look at the patent. So Textron. A variable sweep wing for a tilt rotor aircraft includes a fuselage coupled to the fuselage like a pylon link. All right, where's what? Aqualex, you seeing this, buddy? What the hell? Yeah, synchro. It's using a synchronizer drive shaft with a single engine. That seems unnecessarily complicated. Oh yeah, there's the Marshall Field Tractor start. So, no, Hunster, that's actually about as simple as it can get. So, with the V22, the engines were out here. The whole engine tilts with a V22. Now, think about, V22s are known for high wear. Hunster, did you ever, swing wings and all, Navy, stowable wings. Well, actually, Never mind. What I'm saying doesn't make sense in that context. Holy shnikes, dude. It's using ring and pinion gear, and it can sweep the freaking wings? Yeah, Hunster, now I'm like, wait, what? Dude, there's ring and pinions, like a differential almost, minus the spider gears that are built into the pivot points. Why? Oh, wow. Okay. Dude, what? Dude. Yeah, that's what I'm thinking, man. That's so much stuff that can go wrong. The drive shaft mechanism is really good. That's really nice. I actually, you know, the way this looks, it seems like one engine is driving the entire mechanism, both rotors, and that one engine turns into a turbojet and shoots out the back. I like that. I actually think that's a really good idea. And yes, I could probably make this in Kerbal with the drive shafts and everything. Yeah. Yeah, we could probably do that. Yeah, no, it wouldn't. This is not stowable. No, it's not. Unless it did a V22 and the entire mechanism turns on top of the fuselage. What the frick, man? That's crazy. Yeah, no, I'm wrong. That's not for stowing that. Absolutely not. What's 32 in this? It's using a damn screw jack to change the wing angle of attack. To sweep the wings, it's using a damn screw jack. That's smart. Great torque. What the actual frick is going on here? Dude, Element, I'm not sure I can do that. I'm not sure we can make that in KSP. At least not at this, not at the small scale that the vehicle actually is. Dude, it's a freaking pinion gear. That's a pinion and a ring gear.
Discovery, go at
Hey,
throttle
Maslam, what's up, dude? 126 months. Sweep is needed for high subsonic. Yeah. It would let them adjust for shifts in the center of mass. That being said, I do not believe that many gearboxes and hinges would be lighter and simpler than an electric powertrain. Yeah, who knows? What's 32 in this? See, what? I'm wondering what 32 is. Okay. The main gearbox 26 may be a reduction gear that changes the direction of torque and its position within the fuselage. Proximate variable sweep wing, such that the main gearbox may be referred to as a mid-wing gearbox. Aircraft has a thrust engine 32, such as a turbofan engine, located proximate in an aft position of the fuselage. Likewise, Proporter Assembly 20B is rotated responsive to torque and rotational energy provided by the lift engine. 24 via main gearbox. It has two engines. There's two engines in this design. Yeah, there's two of them. Yeah, one engine is your turbo shaft. That's in front of the wings to drive the rotor mechanism. One engine. And then one engine is out back for thrust. Yeah, see, there's a engine back here. There's a turbo fan back there for thrust, and then there's a gas turbine right here, a turbo shaft like a helicopter engine. Huh. It's kind of a tilt. Yeah, it is a tilt rotor. This is DARPA's X-76, dude. Yeah, so there's two engines. There's one in the front, one basically right on the wing, and then there's one in the back that generates thrust, which is... It's a choice. That's probably what that intake is right there. That intake is most likely for your helicopter engine. These intakes are for the thrust engine. The F4s had something they used in case of immediate need to take off. Start cartridges. Inject the jet with high-pressure gas in the engine to speed it up. Speed for ignition, kind of like the shotgun shell thing. Yeah, see last. Yeah, okay. As for electric powertrains, yeah. Oh, yeah, those things. Yeah, those are cool. What's with the weird-looking back of the nacelles? I don't know. I don't know what that's about, dude. I'm confused as to why they put intakes on the back of this design. Because, see, Kraken, look at this picture. The other concept render, there's no intake back there. It's just a tail cone. Huh. That image also has the blade stored facing inwards. That won't work. Yeah, it would have to be that way, right? Not that way. Yeah, nobody gave the concept artist the memo. It looks cool, though. That looks like an oil cooler exhaust. None of the renders have intakes on the wingtips. You can get away with an oil cooler. Interesting. Two engine design like that, I'd have trouble making that in KSP. Yeah, I'd have trouble making that. Even the stowable blades, guys, I'm not sure. We'd have to build a sled of our own to see how in Kerbal to see how that would work. Now, I could make the drive shaft mechanism. We've done stuff like that. I'm not sure if I could make the drive mechanism with swept wings and make it work mechanically the same. I'm not 100% that we could do something like that. Serial Assets is a deep dive segment. Quick Harrier overview. This video is called Why the F-35 is for Toddlers and the Harrier is for Psychopaths. We start with a 10-mile railroad. Well, we got the SPH runway. That should be long enough. Can you do in-flight refueling and docking in KSP? Yes, but getting two planes to fly near each other in a single-player game, Katra, is a little bit difficult because of the limitations of the game engine. Whenever I see that design, I remember the 945. Yeah. That pile of junk. Yeah. Mm-hmm. You know what? Guys, if booster testing doesn't happen tomorrow, or if it's already happened, guess what we're doing? We're playing KSP. We're playing KSP tomorrow. I want to experiment with this. Yeah, I want to experiment with this design. Patent for swing wings just protects the design. It doesn't mean that they're building it. Yeah. Yeah, Kuju, I was not going to build mine. For Kerbal tomorrow, I'm not going to build mine with swing wings. Yeah, I was not going to do that. What I'm wondering is how the aerodynamics of the wing reacts when propeller blades are radial to oncoming flow. Or, well, not radial, perpendicular to to laminar flow. You can play with the design in Fallout. We'll start with KSP. I don't know if I can make that in Fallout, dude. Or Fallout. In Flyout. I'm not sure I can make that. Can you get that advanced in Fallout? I know you can get advanced with your wing design, but I'm not sure about anything else. Interesting. All right, dudes. So here's what we're going to do. I will I was going to take a break an hour ago and because I want to eat my food sitting over there on the heater. Here. Let's see if we can. Yeah, there we go. Here, let me just make sure. That's a tier 3 118-month resub. Okay, we'll put on the orbital mechanics video. And then we'll start the space and rocket review. Okay, Kiani, 125-month resub. Thank you. I think the only really important thing is the swash plate transition. Mechanically, I'm not sure I'd be able to make that in Kerbal either. But then again, people have made swash plates in KSP. They made swash plates in KSP because I sat here and tried to make one in KSP with no robotic parts and it didn't work. And then somebody figured it out. Raid did. Raid 16. And then Shotch had one too, if I'm remembering right. Either way, I will be back. I assume you've seen the YouTube video of the demonstrator. Yeah, nervous. Yeah, dude. Yeah. I saw the sled with the propeller actuating the swash plate to stow the blades is genius. That's really smart. That's really cool. Actually, it's really good stuff. Could the blades fold into a slot? They do. They fold into a slot with a clamp. That's what the patent said, Katra. So they do to an extent. Yeah. Chatting with my buddy on Sunday who worked on that sled. Cool, man. All right, Nervous, I'm going to grab a quick bite to eat. We could talk more about that in a moment. Check out the orbital mechanics video. And I will be back for space news.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
Applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the Sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the 3 Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a three-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by three orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The five orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the six orbital elements. The six orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are two causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about 0.5 degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch measured eastward from due north is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as ohms are required to place the orbiter in its final orbit. The ohms 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of 2 burns and is used to accomplish an orbit transfer between 2 circular orbits in the same orbital plane. The most energy-efficient transfer between 2 orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits, which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the space shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
And just remember, this will be on the quiz at the end of the week. So if you didn't take notes, it's nothing I can do to help. That was me talking the whole time. Yeah, you will understand the fundamentals of spaceflight. Never mind Peter hacks. He's a dang, he didn't narrate it. He's a hack. It's right in his name. I hate this substitute teacher. Anyway. Titanate my notes. Yeah, that's fair. Yeah. Dude, I ate food and went for a walk outside because you can actually like go outside and not freeze your butt off. Yeah, that was neat. What is this outside? Don't worry about it. Don't worry about it. Let's see. So, let's configure YouTube for acquisition of signal. And
Discovery, go at throttle up.
we'll get to it. I have a lot of links, and we might be getting a special guest in here. You guys want a special guest? Oh, oh my God, 114 months. Oh, hello, Sawyer. Why don't you just ruin the surprise? Did you touch grass? I actually could see my grass, Katra, so that was useful. Being able to, see the grass. I have not seen grass in months. I never said I was coming on. You ruined it. Just get in here. Hello?
Hello.
Hello?
Hello.
All right. Hey, this is Kissel. When are you going to come and fix my sink?
I've called you to ask about your car's extended warranty.
I don't have warranties. My cars are all old. One of them is missing the back.
I heard you need that part.
I mean, I don't know. I brought it up on stream. If you want to look, that's you be the judge. Do you think the car is missing some pieces? Or
No, it's fine. I think it's totally drivable like that. Who needs wheels?
Yeah. It had an early hover conversion done in the early 21st century. All right, so guys, I got Sawyer with me, and we're Sawyer Rosenstein's a commentator over at NASA Spaceflight, and we're going to dive into this OIG report to start space news. But I do need to go live on YouTube first. Sawyer hosts Flame Trench on Fridays with me and Max. Max Evans, a photographer over at NASA Spaceflight, and he's also a very good commentator over there. He enjoys long walks on the beach and really enjoys a clean pair of slacks.
I've seen his slacks. I think that's debatable.
Yeah, all right, that's fair. Okay, Sawyer, just I'll key us back in here for when we go live on the tubes, and yeah, you'll just chill if you could just chill for a moment.
Yeah, no, that's fine. I mean, obviously we'll go in depth to this on the Flame Trench, but this just came out today.
Yep.
So I gave a quick glance through. EJ has not read it yet, so this is more of a first impression stream, and then Friday will be I've had time to actually think about this and come up with thoughts on it.
Yeah, there's an Office of Investigator General report on the HLS, on NASA's management of the Human Landing System program. It's great. You guys will like it. It's pretty good.
Yeah,
all right.
Well, that's a strong word.
Okay. Going live on YouTube in 5, 4, 3. You didn't say 2 or 1. Well, you don't say 2 or 1. Why not? You just don't. Okay? Welcome to the Space and Rocket Review. I am EJ. Joined? No. Sawyer's here. All right? Hi.
We are not adjoined at any body parts. We are about 1,000 miles away from each other, but it is good to be here.
1,600 kilometers.
Don't forget. But who's counting?
Yeah, whatever. It's all Greek to me. All right,
no, I think that's European, but anyway.
Is Greece not in Europe?
Let's keep going. Hi, YouTube.
Hey, what's going on, YouTube and Twitch? You guys have been here. So we're doing a little bit of a different space and rocket review today. How we're going to start it. I do have a lot of links that I do want to end up sharing. There's a lot of different stuff to talk about between, you know, Ship 19, Booster 19 catching, testing. EJ's doing real good. Sorry, I'm in a little bit of a coma. Yeah, we got a lot. There's a lot of different stuff that we're going to talk about, but I wanted to start with this, which is pretty funny. So this was released today, and Sawyer has had a chance to peruse it. I chose to not peruse it and peruse a sandwich instead, just a second ago.
So yeah, I kind of skimmed through it, so this will be a good time to read in depth in it with you. But from what I did see, there are some fun, harsh words in there, and worries about things falling over and elevators not working and other stuffs. And also, being able to rescue the crew if something happens, which they can't.
Oh,
anyway,
yeah, that's good. Couple of things. I was up too late playing Factorio. You do not need to call me out like that. I really don't appreciate it. Please don't do it again.
Blame SpaceX. You said you were going to keep going until SpaceX launched, and then they delayed an hour. So blame SpaceX.
Yeah, it's Elon's fault.
Yep.
Also, was it a good sandwich? I had a gigantic Jersey Mike's steak and cheese with onions and peppers and bacon.
Oh.
It was probably about, I don't know, 11 by like 7, like 18 inches. It's a big, the large is a gigantic sandwich. I ate the whole thing. I ate it on the hood of the car, on the Coronet, because it was warm in the garage. So I opened the garage door and sat there and watched trees for a second. But was it good? It was exquisite. And it was warm too. I put it on my heater, the office heater. Yep, it was nice and warm. It's great. Oh, anyway, all right, let's so I was just sitting there going, what the all right.
I've been watching you for 114 months. I'm just sitting here watching.
All right, that's fair. All right. I'm just gonna make sure that Discord's turned up all the way. All right, cool. All right, let's do this. So we're gonna start with the Office of Inspector
Inspector Gadget.
The Office of Inspector General from NASA. NASA's management of the Human Landing System contract. So if you don't know what OIG is, or Office of Inspector General, it's basically it is the IG what's the right way to say it? Sort of like they go around and they basically make sure that people are doing what they're saying that they're doing.
It's basically meant to be a neutral party that can look through things from a broad perspective, incorporating government opinions, agency opinions, and contractor opinions, and combine it all together as a, hey, here's some recommendations of what you can do better, and here's what you're doing right.
Yeah. It's basically not redundant in the bad way, a redundant level of review to make sure that programs are getting done correctly. This one is on HLS. HLS is the Human Landing System contracts. So, March 10th, 2026. So let's jump into it. Results in brief. All right. Why we performed this audit. NASA's Artemis campaign aims to return astronauts to the moon for the first time since Apollo 17 and establish the framework for a sustainable lunar presence. The HLS, or Human Landing System, which will enable crew to descend to the lunar surface, temporarily live and work there, and ascend back to lunar orbit, is a key component to that endeavor. To this end, NASA awarded firm fixed-price contracts to SpaceX and Blue Origin for the rapid development and demonstration of each company's unique human landing system. Since the HLS program's inception in 2019, NASA has obligated $6.9 billion for HLS development and estimates it will spend $18.3 billion through fiscal year 2030. Wow. NASA is utilizing a tailored program management approach, giving HLS providers significant latitude to implement their own project management practices while allowing for a reduced number of agency-required reviews and data submissions. However, to gain visibility into the provider's development work and ensure they are meeting safety and operational requirements, The HLS program is employing an insight oversight model. Given NASA's significant financial investment in the high stakes of returning astronauts to the moon's surface, it is essential the agency maintains sufficient awareness into the risks associated with these new technologies and the authority to require system operational changes to ensure safety of the crew. In this audit, we evaluated the extent of, 1, the extent of which HLS providers are meeting cost, schedule, and performance goals, and 2, the HLS program's implementation of insight oversight model, and 3, the program's identification and mitigation of risks to astronaut safety. To complete this work, we interviewed HLS program officials, including program management, contracting officers, contracting officer representatives, safety officials, systems engineering personnel, among others, as well as officials from SpaceX and Blue Sorry. We also examined SpaceX and Blue Origin contract files, data from NASA's financial systems, agency review milestones, and provider deliverables, risk assessment, and technical requirements. That? Okay, technically that's not a run-on sentence, but also piss off.
It just needs a good semicolon, that's all.
Yeah, right? Yeah, exactly. Right. Additionally, we reviewed and analyzed HLS program's provider schedule. Okay, what we found. I got Sawyer with me. Yes?
Yep. And just a heads up, before we go into the full details of it, you're probably going to want to read page 32 because it says this was all done before NASA just went and totally upended the entire plan that they had.
Page 32. Is that 32 on the PDF or 32 on the page number?
32 on the PDF. Or the page number, yeah. The addendum. On the PDF, it's 38.
Addendum, February 2026, updates the Artemis campaign approach. Subsequent to the completion of our audit work, NASA announced changes to the Artemis campaign approach in late February 2026. Specifically, the agency's new goals, including standardizing the Space Launch System vehicle configuration, adding an additional Artemis mission in 2027, and undertaking at least one lunar surface landing every year thereafter. To this end, the Artemis 3 mission is now projected to serve as a flight test to low Earth orbit to test systems and operational capabilities in preparation for an Artemis 4 landing in 2028. The new Artemis 3 mission plans include Orion rendezvousing and docking with one or both SpaceX and Blue Origin landers, in space testing of the docked vehicles, integrated checkout of life support communications and propulsion systems, and potential testing of next-generation spacesuits. The agency plans to further define the Artemis 3 low Earth orbit flight test after completing detailed reviews between NASA and Artemis partners. Given the timing of this announcement and the additional decisions that still need to be made, we did not evaluate the cost, schedule, or technical impact this shift will have on the HLS program or lander providers. Okay.
So it's just important that we read that beforehand. So knowing that going into this, they still assumed that Artemis 3 was going to be the first lunar landing.
Yeah, okay. All right, let's see what they found before Jared decided to change the program here. Well,
there's some doozy words in there for SpaceX.
Okay, let's see what we got. NASA's acquisition approach for the lunar landers has been effective in controlling contract costs, with SpaceX and Blue Origin contracts having only increased by 6% and less than 1% respectively. This was due in part to NASA negotiating mutually beneficial contract changes at no cost to the government. However, both SpaceX and Blue Origin have experienced schedule delays and face technical and integration challenges that have the potential to further impact lander costs and delivery schedules. In particular, SpaceX's lander will not be ready for a June 2027 lunar landing. To accelerate lander development to meet a 2028 lunar landing date, NASA is assessing proposals from both SpaceX and Blue Origin, but it is too early to determine the technical feasibility, financial implications, and schedule impacts of these proposals. Hey, Hydrogen, how you doing? Hey, what's up? If you have to debate with somebody that can't understand basic physics, use this. SLS launches are more consistent than your arguments. Rip.
Got him.
Rip. Oh, man. Okay. The HLS program's use of insight and collaborations has shown to be an effective management approach to gain visibility and participatory involvement into lander development and data. However, both insight and collaborations are not without its financial cost to the agency. The HLS program has insight into more than 1,100 focus areas between SpaceX and Blue Origin, with increased insight into engine development, cryogenic fluid management, and crew training. As providers continue to develop and approach critical milestones, increases in insight will likely require additional NASA resources to conduct analysis, reviews, and tests. NASA is also collaborating with SpaceX and Blue Origin by providing requested expertise and knowledge in technical areas such as engineering or safety through the increasing use of NASA personnel and support contractors. While we've found the work beneficial to HLS development, it comes at no cost to providers and is dependent on NASA resources. Furthermore, while the provider's use of government task agreements, or GTAs,
Yep, we had GTA 6 before GTA 6.
Yep. To access specialized NASA facilities and services has proven to be successful. We found the HLS program does not have a formal process outlining how to manage government task agreements submitted at contract proposal that have since been canceled or unfulfilled. Or no new GTAs requested after contract award, which are the financial responsibility of the providers. This lack of guidance led to confusion and a pause in GTA work in early 2025. As a result, the HLS program went through a reconciliation process authorizing NASA to decrement $1.5 million from SpaceX's contract in 2026. The agency determined a decrement to Blue Origin's contract was not warranted. Really?
I guess based on the amount.
So SpaceX gets punished for not meeting a deadline to the tune of $1.5 million?
Guess? That's weird.
That's great. Yeah, maybe we should, do that with everyone that's late with something in the space program.
By the way, I feel like we should probably talk about what a GTA is, a government task agreement.
Yeah, what is it?
Basically, from my understanding, it's basically that you can... NASA or SpaceX and Blue Origin can ask NASA for their help. So either experts, facilities, services, etc., to help allow them to progress. So basically, the fact we had WB-57 footage for all of these Starship test flights, that was a GTA request. The use of the Neutral Buoyancy Lab, that is a GTA request. Blue wanting to use Marshall Space Flight Center, that's a GTA request. So anything where NASA can use their facilities or expertise to help the commercial companies, that's these GTAs we're talking about.
Okay. All right.
Again, that's my understanding from the little bit that I've skimmed.
Okay. Oh, Hydrogen. Hello, EJ. How are you doing? Do you mind saying hello to the stranger off stream? Hello, stranger off stream. Okay. Interesting. All right.
Hello, stranger on stream.
Hey, well, you're not a stranger.
I would hope not.
Yeah, I was gonna say,
especially to you.
I was gonna say we've been friends for a pretty long time, dude.
Yeah, I think it's going on 12 years now.
That's weird.
That's really weird. I was in college when we met.
Yeah. Okay, so let's keep going. We noted NASA's proactively taking measures to mitigate and prevent hazards associated with the landers, such as requiring lunar ascent tests as part of the provider's uncrewed demonstration missions. However, despite these efforts, and considering the lunar landers carry the highest probability of crew loss, gaps still exist in the agency's risk reduction methodology. For instance, while HLS program officials believe the program is following agency's test like you fly guidance, we found key missed opportunities to apply these principles to SpaceX and Blue Origin's uncrewed demonstration missions. Additionally, NASA and SpaceX disagree on whether the provider is meeting the intent of the agency's manual control requirement. Incorporating the manual control capability is a key element of HLS human rating certification and part of an essential crew survival strategy. Key decisions on Blue Origin's manual control design have yet to be made.
Yeah, basically I think they're talking about like the fact, remember Apollo 11 when Neil saw the giant craters below and had to and had to take manual control of it.
Yep.
It doesn't seem like that's an option really with SpaceX's proposal. They want everything totally automated.
Huh.
That's the implication it sounds like of the disagreement of the astronauts shouldn't need to take much manual control over this.
I mean, okay, that is a vibe. Like, if you wanted to do that, I would want them to test that multiple times before putting people on that.
Yeah, you'd think so.
yeah, I would want them to test that a lot. Yeah, how do you even land Starship manually? Yeah, exactly. How's that gonna work, dude?
I mean, it does explicitly say that they are scared of the risk of this giant monstrosity tipping over. Holy hokey.
Yeah, he does that.
But yeah, that is a big concern apparently, is that Starship will just fall over. So you would think you would want manual control to prevent it from the moments that all of us have had on Kerbal, the oh no.
No. Yeah.
Yep.
Yeah, you don't want to no. You want a bingo right in the center.
You get it.
Yeah. Oh my God, dude, we almost got him to say it today, Fluffy. Almost. He didn't say it.
And it wasn't in the correct cadence. Yeah.
Yeah, it was. Yeah, exactly. It was. Oh my God, not oh my God.
I think switch it to gosh.
Yeah. I did. I said oh. I think I did. I don't know.
Oh.
All right. To improve management of government-spent funds and enhance crew safety and survival during the Artemis missions, we recommend NASA officials, 1, ensure an approach for managing GTAs that have been canceled, unfulfilled, or modified, or realigned is... Oh, that's a weird sentence. Okay, 1, ensure an approach for managing GTAs that have been canceled, unfulfilled, modified, or realigned is formal in HLS program policy. Man, that sentence makes my brain hurt.
Strong.
Ensure an approach for decrementing costs for GTAs submitted after contract proposal, including a timeline for recovery, is formalized in the HLS program policy. 3, update the use of the government resources clause in both SpaceX and Blue Origin contracts to reflect GTA policy changes. Consult with the commercial crew program to review post-variance acceptance risk assessment findings related to its manual control waiver for lessons that can be applied prior to HLS certification. And 5, update crew survival analysis, including decision packages to include strategies for extended crew survival. This sounds like NASA wants to be able to, or at least the Investigator General wants NASA to have a little bit more oversight in their lander programs.
I think it kind of needs it at this point with the little bit of information that we've seen trickle out there. It sounds like they really don't have a lot of the information that's needed to make these safety assessments. And you can kind of get that vibe just by reading the table of contents.
Yeah, right. What do we got? NASA is controlling HLS contract costs, but lander development challenges have delayed planned Artemis mission dates. I mean, that's what happens when you flat fund things, when you control contract costs, because the lander's fixed price. It's a firm fixed price thing. Developing on a firm fixed price is just as dumb as developing on cost plus with no deadline. Yeah, if you have a deadline, cost plus is favorable. And I know everybody hears cost plus and freaks out. No, not necessarily true. I would say that developing on firm fixed price under a deadline is a really bad idea. Because there's a lot of unknowns with what you're doing with spaceflight, but controlling the cost is going to mean delays, guys. I can already tell you. Anyway, NASA is effectively collaborating with HLS providers, although constraints exist. I'd be interested to see that. So I'm guessing selecting crew survival as an option would be considered unacceptable? Question? Yeah.
I mean, it says it right there. NASA ruled out crew rescue capabilities for early crewed Artemis missions. Yeah. That whole section of just the table of contents had my jaw on the ground, and that's when I'm like, okay, EJ, I'm joining you for this. I'm joining you. This is ridiculous.
There's no way.
Oh, there's way.
I need to see that part. That's the part that jumps out at me. Hold on. You've got to... What?
I was reading through it. You got to read through the whole kind of section of that, though, to understand what they're getting at. So that section starts with the document page 23, and the part you're looking at was pages 28, 29, and 30 of the doc itself, of the PDF, sorry, of this form.
Okay.
So that
NASA incorporates astronaut safeguards into landers, but operational and resource constraint limit risk mitigation and crew survival efforts. Okay. Of the numerous systems required to choreograph the Artemis missions, HLS carries the highest probability of crew lost. Yeah. Yeah, and Orion...
And the sky is blue.
And yeah, and Orion can't get near them either, because, well, that might change in the future, so... To avoid a catastrophic event, NASA is proactively taking measures to mitigate and prevent hazards associated with the landers. Despite these efforts, gaps exist in NASA's risk reduction methodology, including in its testing, posture, and crew survival approach. Furthermore, there are emergency scenarios that NASA will be unable to mitigate during early crewed Artemis missions. Ultimately, should a catastrophic event occur, NASA currently doesn't have the capability to rescue a stranded crew from space or the lunar surface.
Yeah. Yeah, that's reassuring. So yeah, you may just get stuck on the moon, that's all. Or if you're able to make it out and stuck in orbit around the moon and can't get back to Orion, yeah. Then we get that Nixon speech that we never wanted.
Yeah. Hey, Snarfers, what's up, man? Yeah, I got Sawyer with me. We're looking through this, for the first part of Space News, we're going to be looking through this OIG report on the lunar landers, the Artemis lunar landers. It's, there's some, there's some things in here that I kind of
Would
agree.
you look at that?
Would you look at it? Here. Brimo, you were going to say, wasn't that true during Apollo as well? Well, they always had another Saturn V teed up with another lander in case, and the lander could land automatically.
And they do address that, actually, in this. They do bring up the whole, hey, here's Apollo's kind of redundant, and here's why right now that isn't an option with the current formation of the Artemis program. Sorry, I'm spoiling. Spoilers, that's when we get to, page 28.
Okay.
But keep going.
All right. The HLS program providers are tracking and mitigating top risks, including those related to landing or lander system constraints, missed ascent from the lunar surface, and a failed return docking with Orion or Gateway. We don't need to worry about that second part, though. I don't know that for sure, but, NASA utilizes a strategy to control these threats as its primary method for minimizing hazards and risks. The intent is to prevent their occurrence or reduce them to an acceptable level. Typical approaches for protecting against hazards include eliminating the hazards through the lander's design, minimizing the likelihood or severity of the hazard. Yeah, that's probably a good idea. Incorporating safety devices, and implementing special procedures. NASA also relies on human rating requirements to design, evaluate, and provide assurance that a crewed system can safely conduct these required missions. Human-rated systems, such as the landers, must accommodate astronaut needs, utilize human capabilities, control hazards with sufficient certainty, and provide, to the maximum extent practical, for the safer recovery of crew from hazardous situations. Additionally, human rating incorporates design features and capabilities that accommodate human interaction with the system to enhance overall safety and mission success. This approach ensures missions operate at an acceptable level of risk to the humans involved. Risk posture that agreed upon limits of risk organization is willing to accept to achieve its objectives is the key factor for making decisions through the mission's life cycle. Using these tools, NASA is working with the providers to address key risks related to the Artemis landers, meaning they'd have a backup. Yeah, I'm going to guess that this probably says Apollo's high flight cadence was probably redundancy to the program there, but we'll see. So what's the verdict so far? HLS is going to never work. Trey, I haven't wrapped my mind around it completely. I'll get back to you. Lander engineering design constraints. All landers have engineering design constraints related to the size and characteristics of the potential hazards they can overcome during a lunar landing. NASA selected the lunar South Pole for the Artemis missions due to the unprecedented opportunity for scientific discovery. Landing at this location, however, poses many challenges and introduces constraints not experienced during the Apollo missions. It's hilly. The South Pole has a lot of hills, guys. There's a lot. It is like trying to land an airplane in the Rocky Mountains.
Yeah, we're talking giant craters and I believe like 20-degree inclines on some of those crater walls. Yeah.
Yeah. Yep. Okay, so
that would not meet ADA requirements. I would not be able to ramp up that.
Yay, 1/6 gravity. You never know.
Oh, good point. Anyway, continue. Don't give me ideas now.
I mean, hey, we got to build that off-road rig for you. All right.
True.
Yep. Okay, so landing at this location, however, poses many challenges and introduces constraints not experienced during the Apollo missions, all of which occurred near the moon's equator. Nope. Taurus Littrow is a good ways inclined.
I think the whole point is that they were mostly on the midlands, the flatlands.
They're in the basalt. They all landed in the basaltic lowlands, which is relatively flat.
Yeah.
That's the right way to say it. But, whatever.
I think that's what they meant, but still.
It's bad copy, Sawyer. All right?
Yeah, someone definitely didn't proofread this.
Yeah. So Nervous, you're saying shadows are rough on the moon too, making it hard for the vehicle driving on the surface. Yeah, I mean that's why there's ice there, Nervous, right? Down in the Shackleton crater is because it's in perpetual darkness. Because it's on the South Pole of the moon that's spinning around the Earth, one revolution per orbit, right? And there's just perpetual darkness in those craters.
But I mean, I guess that's why there's LiDAR and other type of technologies that don't require visual sight to track the lunar surface, which is great until you then create a ginormous plume when you have a 14-story, Starship lander about to come down.
Mm-hmm. Yep. For example, a multitude of geological features, including rugged and uneven terrain strewn with rocks in excess of 65 feet in diameter, so that's about 18, 19 meters, and deep craters dominate the landscape, unlike the large plains visited by the Apollo missions. Now, that's right, yeah. Shackleton Crater, a prevalent feature of the lunar South Pole, is more than 2 times deeper than the Grand Canyon. Whoa!
Jesus.
Didn't know that. Understanding this environment is crucial for ensuring the safety of the crew and enabling mission success. It's 2 times deeper than the Grand Canyon?
I had no idea. I knew it was deep, but not that deep.
Dude, the Grand Canyon, yeah. Wow.
Now I want to fly somewhere that deep in Flight Simulator. But anyway.
Yeah, right. Actually, one time in Flight Sim, we took a bunch of small airplanes and flew up the Grand Canyon.
Oh.
It's like the Death Star trench run, man. Yeah.
That sounds epic.
A bunch of people come with me. We should do that again. That was fun.
Yes. Someone made a good question. How deep is the Grand Canyon? Just for comparison, that is it's about 6,000 feet at its deepest, which is about 1,850 meters.
Wow. So that's 12. The Shackleton Crater is 12,000 feet?
Yeah, 3,600 meters.
How? How is that a thing?
Well, it turns out there are these other rocks that float in space and crash into things, and when you don't have an atmosphere, they go deep.
Big boom, indeed.
Actually, me like big boom.
Yeah, right. Actually, the lunar lower basaltic regions where the Apollo missions landed are leftovers from something really big that hit the moon. And the reason why they're basaltic low regions and why they're a different color, guys, is because whatever hit it so freaking hard, it actually heated up the entire moon. And that's why there's lava tubes on the moon, because there was so much heat generated from the kinetic impact of whatever hit it, right? It made lava on the surface, and all that lava cooled over time. And that's why there's different parts of the moon that are different colors. Like one's a darker gray and one's a lighter gray. The darker gray is where it got slapped by something really, really big. Bob, you hit it, you son of a biscuit.
It was the slap chop. That's what it was. You're gonna love my craters.
Watch this. You're gonna love my struts.
I
started streaming when that meme was like new.
I remember. And he was arrested. Anyway.
Yeah. Okay, landers may encounter hazards such as boulders or mounds that are too large or depressions that are too deep for the landing legs and stability design. For example, steep slopes of up to 20 degrees on the lunar South Pole present navigation and landing challenges. Given Starship's height of 171 feet, about the equivalent of a 14-story tall commercial building, there is a risk that its momentum will continue after landing, causing it to tip over. Blue Moon, standing at 53 feet tall. Dang, that's actually pretty big.
Yeah, it seems so much shorter when you look at the comparison graphics, but it's only because Starship is a monster.
Yeah. Also faces landing risks, including exceeding the lander's tilt tolerance for safe and effective execution of critical crew functions. Surpassing the tilt tolerance for either lander, which NASA established as not to exceed 8 degrees to support all post-landing crew activities, meaning takeoff, could impact the operation of the equipment, such as the hatch used by the crew to enter and exit the vehicle. By comparison, the Apollo LEM stood 23 feet tall. See Figure 5 for a relative comparison of lunar landing heights.
If you scroll down to the next page, they usually keep it right on the next page, hopefully.
Yeah. I actually wanted to show that. So it's interesting. They cited Apollo 15. Apollo 15 landed on a slope. And it actually, they bottomed out the lander, you guys remember like back in the day when Falcon 9s were just figuring out how to land those things, and we'd see them tipped over on the drone ship, and the drone ship would come back in, and we'd see it on like fleet cam, and it looks like someone took the rocket engines and put them in a blender. That, but with the descent module engine. But the Apollo lander was 2-stage, so you didn't need to worry about it. But they did screw up the LMDE because they landed on a hill.
Yeah, 11-degree slope.
Yep.
And keep in mind, that's 11 degrees. We're talking about, as I mentioned, there's slopes of up to 20. So double that tilt.
Jeez, I never realized how big Blue Moon Mark II is. That's a huge freaking lander.
Yeah, well, again, all you see compared to is the big boy on the right. So it looks small, but...
No, that's a big one.
Yeah, compare that to the LEM, which they didn't even put the LEM level with the Blue Origin lander.
Yeah, it's like up a hill.
It's even taller. Yeah, it's even taller.
Notice, yeah, Bob, that's a good point. All the legs are similar in size. They're all similar in size. That's funny. The source of basalt was from the magma. We're in a volcano, surrounded by liquid hot magma.
Oh.
Hey, Love Eagle. Yeah, right? Soy and I are discussing the OIG. This is an OIG report about the landers. Long story short, they might be a little too tall to land at the South Pole. Yeah.
Yeah, I mean, it's great when a report flat out says in plain language, yeah, this thing is so big that the momentum could carry it after it lands and just tip it over. But that's okay. At least they have a plan to be able to rescue the crew if that were to happen. Oh, wait.
Ooh, baby. See, guys, this is part of the reason why I said NASA needs to do their own in-house lander. Co-manifested, just do exactly what you did with Saturn V with a better performing upper stage from SLS and a lander and Orion. Just do that. Just do that, because trying to do something else is not what we know. We know how to do this. We know how to do that. We did that 6 times. Those over there are relatively unproven. And I love Starship, and I like Blue Moon Mark II as much as the next person. But, yeah, let's see. What else do they have to say? It's a little late.
Makes a good point. Aqualux makes a good point, though.
What's up?
They're saying is they want to see where the COM is on all three. Just because something's twice as tall doesn't mean it's twice as likely to tip. And I think what the OIG report is getting at is, yeah, so do we.
One man,
Right,
only one of these
we
options.
want to know.
What's up?
Yeah, I was like, yeah, OIG wants to know too. Hey, SpaceX,
Right.
maybe if you had been on your timeline here to get stuff done, we'd have seen it.
One man, what are you saying? Only one of these options on the screen has the capability for permanent presence. Yeah, I see what you're saying. I would actually argue that you'd need all three, if you really want my honest opinion. Or at least Blue Moon Mark II and this. You need something to just move people down to the surface. So Starship brings the base components, and Starship builds the damn city, right? And then you send people down there, and they go up the elevator into the damn Starship, get the pieces out, bring them back down, and start building out your moon base. But honestly, this is what I'd really want. I mean, a LEM is what is perfect. Like, I refuse to believe the nonsense that people say, like, oh, the Apollo program wasn't sustainable. Well, yeah, that's great. You could sit here and say in retrospect it wasn't sustainable and it was expensive. But if you compare that to every other lunar program we've done, it's pretty damn sustainable for me. You know why? It landed multiple times. That's kind of weird. You know?
And when you add in the capabilities we have today to mass manufacture parts for rockets, just see SpaceX second stages, see that we now already have GS2 5 that static fired the other day, or 6, whichever it was.
It was 5, I'm pretty sure.
Yeah.
Yeah.
So,
yeah,
case in point there.
I would argue that, like, the Apollo program was pretty damn sustainable, and you could do everything that the Artemis program does with it easily, like way easily. You could, if you're the descent module, right? You could just build base components onto your descent module. You don't need a descent module and send them on Skylab style Saturn V's out to the moon. Without having the descent module, without having to lug around the CSM, doing uncrewed landings with just the descent module and a pressurized segment on top of it. Whoever thinks that's not sustainable needs to go away. Like, go away, because it absolutely is. Trying to make a LEM with modern safety standards would have it over twice the mass and possibility height. Well, safety standards don't care about your physics, so I would hope cooler heads prevail, Fox. But anyway.
It's finding that balance.
Andrew says, if the lander tips over and there's no rescue plan, that equals permanent presence on the moon. Mission successful.
I should not be laughing this hard at that. I'm sorry. Oh, we're getting to that part, though.
Okay. Starship is not like traditional landers of the past.
And the sky is still blue.
Yeah. Well, it's black in this picture.
Fine, I'll sign off. Bye.
Given its height, one unique attribute is its use of an elevator to carry crew, equipment, and samples to and from the lunar surface. Starship's elevator sits just below the crew compartment and is approximately 115 feet above the ground. Man, that's going to be a hell of a view. When you open that door out at the elevator and look around, that's going to be a really nice view. A height taller than the Statue of Liberty from heel to the top of her head. Wait, what?
Jeez. Holy perspective.
Oh my goodness.
But the Statue of Liberty has an elevator in it. It's fine.
Yeah.
I mean, you're not lifting it off and landing it, but still, it's fine.
Currently, there's no other method for the crew to enter the vehicle from the lunar surface in the event of an elevator failure. Yeah.
You just press the button and just keep buzzing it and calling, and eventually someone comes and opens the door.
Yeah. It's like DoorDash. Boop. The HLS program requires at least single failure tolerance to catastrophic events, meaning the ability of a system to sustain a single failure and not have it affect the design goal. SpaceX is focused on building a robust standard elevator design with redundant mechanisms. However, The HLS program is tracking the elevator as a top risk and is actively working with SpaceX to develop alternate methods of vehicle ingress should the elevator become stuck or fail while the crew is on the lunar surface. Hey, I got an idea, fellas. A rope ladder would probably be good. Yeah, that's probably a good idea. Just a rope ladder will definitely do the job. That's probably a lot. That's probably not a lot of extra mass considering what Starship can do.
Yeah, that's. I mean, that's kind of crazy that the whole thing is we have an elevator to get up and down, but no way to get the crew back in if the elevator stops working, which anybody who's ever been in an elevator ever knows is a strong possibility.
Yeah. Hey, but that means Starship is ADA compliant, though, dude.
I mean, yeah, I like that.
That's
But also, if you would then have to keep in mind, part of this is also the spacesuits that they're going to be wearing, which we don't know which ones it's going to be yet. Is it going to be the AX EMU, or is it going to be where NASA's now going to take over and work on their design, which the whole thing you were talking about on Friday's Flame Trench? I mean, all of that comes into play too. A spacesuit that's able to either have, run a rope through it, where if that was the case, you can, pulley yourself all the way up 115 feet in 1/6 gravity.
Okay, the HLS program is tracking the elevator as a top risk and is actively working with SpaceX to develop alternative means of ingress. Comparatively, Blue Moon, like the Apollo lander modules, uses stairs that are approximately 6 feet above the ground as the primary access method for the vehicle. See Figure 6 for access methods. Oh, yeah. I mean...
Yep, ladder versus elevator versus ladder.
Yeah, the elevator... I mean,
Isn't that like 2 years old anyway, that photo? At least 2 or 3 years old?
Yeah, it's from a long time ago, dude. That's in the that's at Hawthorne. That's in the Boring Company prototype tunnel. Here, I'll show you guys. Check this out. I actually know where that elevator is.
Oh, it's actually on Google Earth.
Oh yeah, you can find it. Huh. Yeah, there it is. Right there. See? See? That's your Starship diameter, by the way, comparatively to like a car. You could fit a car in the freaking elevator.
It takes up, what, 1, 2, 3, 4, 5, 6 parking spaces there?
Yep, that's 9 meter. That's a 9 meter diameter. Oh, dude, nice truck. Anyway.
EJ's gonna EJ.
Yeah, I mean, it's dude, it's single cab long box. It looks like let me take a look, see if we can see the front. Yeah, it's an old F-100. There's another old F-100. Oh, God. That's bullcrap. California just has these vehicles that just don't rust. Meanwhile, we have to deal with these rust boxes. You know what? That's not fair, okay? That's not fair.
Remember, all of those now get to be replaced with Cybertrucks for those SpaceX employees and the Boring Company employees and all of the other employees.
I respect
Exactly.
Cybertruck. I think it actually is pretty cool. If you really want my honest opinion, I think it's actually a pretty neat piece of architecture, especially the 48 volt system. Do I want one? No. Give me my 97 F-250 and we won't have a problem. I am also sick of having to replace sheet metal. Yes. For the second time, my car is missing a lot of parts because most of those parts rotted away. Okay. Good. Are you covering Firefly Flight 7 today? Nah, we don't cover crappy launch vehicles, S-Master. Sorry.
Ooh. Oh, are they trying again tonight?
Yeah. I'll probably have that on. We have permission to restream it, so I got that. I got that going for me, which is nice. I do, rarest. Yeah, we got some works. California trucks are unforgettable. Yeah. Would they not be able to have a hand winch on the elevator? I'd do that, David. Just a manual crank, just in case, right? Like that's not like you got to remember. Starship's baseline is 100 tons to the lunar surface. I mean, you're gonna have to refuel it anyway. That gives you ridiculous down mass. So you're not necessarily constrained by weight. So that also means that like SpaceX could have a bunch of redundant systems on their elevator, and it's really not a big deal. It's not like the LEM where the ascent module, you could, if you punched it hard enough, you'd be able to poke through it like freaking tinfoil, right? I mean, the LEM is made from riveted thin sheet aluminum because they had no mass margin left over, right? Starship doesn't have that problem. That's why there's an elevator on it. And not a freaking not a freaking ladder.
But imagine if you have to use that crank, which I have been stuck on a bus at the Kennedy Space Center.
Oh, no.
We were going out to remotes and the hydraulics broke, so they had to manually crank it down. Imagine doing that, though, with in a suit, which can get hot from all of the work that you've already been doing on the surface, and then having to do it in gloves that are 16 layers thick. Doesn't sound fun. And also it's pressurized. So now you're fighting against the pressurization of the suit as well to do it. That sounds awful.
I still like my rope ladder solution, to be honest with you. I think, a rope ladder would be good to just actually, so like what I'm thinking now is like a passive system, right? So the elevator pops out and then you have a rope ladder just that works with the winch system. So when the elevator's down, think like rollout solar array, but when the elevator goes down, the ladder unfurls, right?
Ooh.
So if you're on the surface, the ladder's already deployed. So if the elevator goes wrong, ladder's already good to go. Elevator works, the ladder's part of the winching system, it just rolls right back up. There you go.
Kind of like this. We need to send this to the OIG stat.
Yeah. Elon, give me a call, bro. Have a counterweight so the elevator is mass positive comparatively to the counterweight. If there's a problem, then the elevator will ascend. That's actually a pretty simple solution too, one man. That's not bad.
But does that cause an issue if you're on an extended slant? If you land on an 8-degree
Yeah, if this lands on a tilt, my idea would work, but most ideas are out the door. I would not want to climb on a rope ladder. Well,
I mean, I hate doing it on Earth. Why would I want to do it on another world?
You could just jump. You'll get up there. Just jump high enough. Might as well jump.
Well, maybe not me, but
brother, we could get you to jump there. That ain't no problem.
No, just like the ballerinas or in like cheerleaders where they throw them up in the air. Just do that with me.
Yeah, that's what I mean. We get you to jump. Like that's that. 1/6 the gravity. I'll just pick you up and throw you up there. Yep, there you go. And you'd be like, okay, this is great. All right, I'm having fun.
Although I think Van Halen beat you to that idea. Just saying.
Yeah, David Lee Roth.
Yeah, might as well jump.
Jump.
Go ahead and jump.
Said it before, jetpack in the EVA. I would not want to outgas a jetpack into an airlock, one man. I don't think that's a good idea
Discovery,
at all.
go at throttle up.
Hey, No Wrath. Tier 2 36 month. And then Rosebud with a $4.99 super chat. Rope? Keep it simple. That is simple. All right, name one thing you're going to need a stupid freaking rope for. All right, get your damn rope. Charles Bronson had a rope. All right.
So, about the astronauts not being able to actually manually save themselves if something happens during the lander.
Yeah. Vehicle manual control. The ability of the crew to bypass automation to control the lander's flight path is a fundamental element of crew survival and mission success. NASA's human rating certification requires vehicles provide the capability for crew to take manual control during all phases of the flow. Yeah, that's human rating. Yeah, that makes sense. Yeah, now let me read that again for emphasis here. Something type A mishap, okay? NASA's human rating certification requires vehicles provide the capability for crew to take manual control during all phases of flight. Anyway, especially during
They may or may not. Sorry, they may or may not exactly reference what you're talking about in this document. Spoilers.
Yep. Especially during critical phases such as descent and landing on the lunar surface. If there are issues with the automated guidance system, such as failures or unexpected performance, manual control enables the protection of the crew and mission. Notably, of the Apollo program's 7 planned crewed lunar landings, astronauts engaged the backup manual control method during every single mission.
Wow, I didn't realize it was all of them.
I think they just wanted to say that they landed on the moon with manual. I mean, Neil probably did it because he had to.
Okay, fair enough.
Right?
I don't blame him.
You think about guys like John Young and Charlie Duke, they're probably like, nah, I'm not, I ain't letting no computer land me on the surface. Screw that. Give me control of this thing. Yeah, guys, the thing's broken again. You know?
Yeah.
All right. More recently, I actually didn't know that they were all manual control. I really didn't know. Anyway,
Same.
More recently, the crew of Boeing's Starliner flight test demonstrated... What?
No, Starliner.
Oh, yeah.
I have to laugh every time I hear the word Starliner.
The crew of Boeing's Starliner flight test demonstrated the importance of spacecraft manual control in June of 2024, when manual control was the only way to maintain the position and attitude of the vehicle on its approach to the ISS after multiple thruster failures. Ultimately... What is that?
Contravening?
Contravening. Okay. Contravening the manual control requirement could adversely impact the crew's ability to intervene, potentially leading to the loss of the crew or mission. Out of order? Even in the future, nothing works. Put a lander inside the lander to land on the moon from the elevator. I like the way you think, Max. This disagreement between NASA and SpaceX on whether the provider's current proposed approach for landing meets the intent of the agency's manual control requirement. Despite the provider's stated an acknowledged commitment to meeting this requirement, NASA's tracking of SpaceX's manual control risk indicates a worsened trend. If NASA and SpaceX do not reach a concrete solution prior to the critical design review, it may lock in automation as the only available landing method or result in significant late design changes and increased schedule risk. In our judgment, this further increases the potential that SpaceX could request a waiver to the manual control requirement to meet schedule.
Oh my god. Whoa. So there's something we didn't know about SpaceX's plans, that they want no manual control option.
Yeah, we
didn't know that before.
Yeah. Now, okay. All right. I am having a visceral response to that in the form of, that's not great. But also at the same time, vertically landing things on celestial bodies is kind of their thing. So also, like Sawyer, I said it to you once, I'll say it again. I don't mind if SpaceX wants to do that. I would want multiple test landings, multiple HLS landings before I put people on it. The only way that Falcon 9 got super safe, risking landing and everything, is by flight data. So if you want to do an automated landing, go ahead. But I think the OIG, like, you're going to need to do multiple landings. I think the OIG is arguing that poses a schedule risk. Because...
But spoiler alert, they also addressed that coming up a bit too.
Oh. Trey,
they had the same thought as you. We're all thinking the same thing, and OIG is going, yeah, about that.
Yeah. Trey, you're saying, then again, I wouldn't trust people to land a 14-story building without going over the 8-degree incline. I would want a relative navigation system in the loop, like what landed Perseverance. I would want either a relative navigation thing that plots a landing zone for somebody to take manual control and land, or a relative navigation system that does it itself. Yeah, LiDAR would work, Sawyer, but once again, regolith's going to get in the way.
Right. Yeah, the dust that thing's going to kick up.
Mm-hmm.
Oh man.
Yeah. NASA, under the Commercial Crew Program, granted a similar manual control waiver to SpaceX for its Dragon spacecraft, which transports crew members to the ISS. This decision was due in part to Dragon's prior flight history transporting cargo to the station. However, Starship will not have the same level of proven flight heritage in an actual operating environment for its crewed lunar missions. Incorporating this system capability is a key element of HLS's human rating certification and part of an essential crew survival strategy. Key decisions on Blue Origin's manual control design have yet to be made. Oh, that's even worse.
Well, it sounds like they don't even know what they're going to do for that yet.
Yeah, they haven't fleshed it out. Oof.
Well, they really only got the go to actually proceed with this. What was it, 2023 when they got Artemis 5? And they figured, oh, we have until Artemis 5, which is going to be this, third lunar landing.
Yep. Yeah. Ravgen, just let us cook. Hey guys, welcome back to the Boeing YouTube channel. Joe Barnard. That's pretty funny, man. Yeah. As of November 2025, neither provider had requested a waiver to the manual control requirement. Huh. Yeah, they did demonstrate manual override with DM2 though in 2020, I thought. They definitely did. I remember Bob and Doug doing it. Bob and Doug flew Dragon around for RPOD. Not the
right. I
docking
mean, they
part.
literally had an entire game on their website where you could practice doing the same thing.
Yeah.
But also, that was a demonstration mission. Now that they are onto their 12th operational ISS flight, not including all of their commercial flights they've already done, I guess they get the waiver for that.
That game was tough, Strick. I docked on the second try. So I got it on my second try because I played way too much KSP.
I had to go back to my old Space Shuttle mission 2007 days.
Center.
Yep. Exactly.
Shuttle had to do manual docking, guys. Yeah.
They're still making a version 2 of it,
Really?
as they have been for the last 10 years, but at least there's progress on it.
Nervous Twitch, what are you saying? Jared requested a manual piloting period for one or both of his missions. Oh, okay. Interesting. Play SSM 2007, Big Zig. I think about it.
That was so good.
Mm-hmm. I mean, I just made one in KSP and I use that, and then I can do whatever I want with it.
As opposed to actual like STS-130 deliver the cupola.
Yeah, that's cool too. But yeah, Joe, they did approve for the manual flight control things. Nervous is right. Yeah, interesting.
Speaking of, we were talking about the LiDAR and the plume. Yeah. I guess they looked at it too.
Okay, lunar plume surface interaction. The interaction between HLS's rocket engines, exhaust plumes, and the lunar surface can impact precision landings and negatively affect landing navigation sensor performance. As the descent continues, the interaction becomes increasingly more complex, with the plumes vigorously kicking up lunar dust, soil, and rocks. For instance, the Apollo missions experienced regolith ejections that obscured views of the landing site during final approach and touchdown. The HLS program is actively pursuing risk reduction activities related to the new lander's plume surface interactions. Current models rely on Apollo flight reconstructions. I don't know, maybe if we just did more of those, we'd understand this better. However, without direct HLS measurements, the predictions are largely uncertain. For instance, potential risks can vary with the lander's configuration, operations concept, and specific landing site. Both SpaceX and Blue Origin utilize single-stage HLS designs, meaning they share the same vehicle to descend to the moon's surface and ascend back to orbit. Further, HLS vehicles are significantly larger in size than the dual-stage lunar modules flown during the Apollo missions, likely resulting in different induced hazards. Dan, what is your guess for a safe distance between lunar landing touchdown areas to provide safe enough distance to avoid damaging from landing burns? Remind me of a bead blaster. Dude, yeah, so anything that's in the vicinity of something that's coming down, the regolith ejecta from something landing would be like media blasting something. Lunar regolith, so lunar dirt, is extremely fine. Think like talcum powder or something. So media blasting. It would be like if you were media blasting a part in an auto shop with like baking soda or something. That is what it does. So,
with like pieces of glass in it.
Yeah, it also has glass in it. Yeah, it's like if you ground up glass and mixed it in with baby powder, and it is a problem. That is something you are absolutely going to have to deal with. Yeah. Now, once again, just like GAO is saying, the lander, the Apollo LEM didn't have to deal with that. Who cares? Your ascent engine is on top. Like it's on top. The ascent module's on top. The two-stage variant, like the descent module, turns into your launch pad, so you don't need to worry about that. And I for what it's worth, guys, I still think, dude, they broke the mold with the LEM. That's one of the best things we've ever made, ever. Period. Full stop. Like, it's, Grumman made it. Grumman made that, and then they made the F-14, and then they made a mail van. Yeah. Seriously, the post vans in the United States, it's Grumman. They got the mail van contract the same time as they got the F-14 contract. I'm not even kidding.
And of course, of the two, we all know the mail van is better.
Hey, the Grumman LLV, dude. Okay, all right. Little bit of car facts. That is a Chevy S10 with a riveted aluminum chassis on it for better fuel economy. Some of those mail vans have like 600, 700,000, almost 1 million miles on them, and they're still going. So Grumman called it an LLV, the long life vehicle. They weren't kidding when they named it that.
Ironic as we now talk about LLVs, lunar landing vehicles.
Right? Can we all just agree to hate the new mail van? Yes, the NGPV is terrible. I don't know why Oshkosh would. Slight tangent here, Sawyer. You want to hear something funny? Not only is that post van ugly as hell, okay? But to the procurement contract for the next generation postal van calls for initially all of the 10,000 post vans to have like a diesel engine in it. That's fair. Diesel engine. But to meet green initiatives, what's going to happen is after 10,000 of these have been delivered, Oshkosh will start taking them back from the postal service and retrofitting them with electric vehicle components.
What?
And then producing that instead.
So is it going to be a hybrid, or they're going to put it out as diesel and then convert them all to full electric?
Convert them to full electric. I will believe that when my poop turns purple and smells like rainbow sherbet. Okay? I will believe that will happen when that happens.
Don't say that. I've taken medications that do that.
Oh, crap. That means it's going to happen. Oh. I'll believe that when me poop turns purple and smells like rainbow sherbet. Pooperl. I'm sure there's a product on Amazon to do that. Jeff is on. In 2026, it's North Slop Grumman. Hey, man. The B-20, hey, you can say whatever you want about Northrop Grumman. Their SRB program is struggling a little bit, but the B-21 Raider was under cost and ahead of schedule, and they just ordered more. So you can say whatever you want about that. They can make airplanes. They're still good at that. But think about buying those engines off government auction. Now that's a good idea.
Yeah, there you go.
Eat lots of blueberries.
Snozberries taste like snozberries.
Yeah, but blueberries are blue though. What fruit is there? Are there any purple fruits? Dragon fruit, I guess.
That's pink.
Yeah. Yeah. Max,
So
why
maybe
did
eat blueberries and dragon fruit?
grapes? Yeah.
But the insides are green.
Banana.
For scale. Anyway.
So Max, you're saying why did SpaceX even take the HLS contract knowing the risk? Well, from this OIG report, Max, it seems like they don't think it's a big deal. The diesel engines in the new mail trucks are having high turbo failures. Oh no! Anyway. Oh no!
Thanks, Jeremy Clarkson. Anyway.
Oh no! Anyway.
So about this moon rocket.
All right, what do we got? The HLS program is actively pursuing risk reduction activities related to the new lander's plume surface interactions. Current models rely on Apollo flight reconstructions. However, without direct HLS measurements, the predictions are largely uncertain. For instance, potential risks can vary with the lander's configuration, operations concept, and specific landing site. Both SpaceX and Blue Origin utilize single-stage... Okay, we already read that. All right, cool. Let's keep going. Addressing the risk associated with lunar plume surface interaction requires validation and model improvements. Towards that end, the agency is conducting ground testing to gather data. Yeah, but you're using the wrong ground. That's the problem.
Oh, they were aware of that.
Yeah. Additionally, as part of its Commercial Lunar Payload Services initiative, NASA installed the stereo cameras for lunar plume surface studies instrument on the Blue Ghost lander. Yeah, Firefly. All right. The instrument captured around 3,000 high-resolution images during Blue Ghost's descent and landing in March of 2025. These pictures will aid in the creation of models to predict lunar regolith erosion. SpaceX is also planning to add instrumentation to its uncrewed demonstration missions vehicle to build interaction models that will include raw images as well as vehicle calibration and data. What else we got?
Yay, SpaceX.
Blue Origin's uncrewed demonstration mission will further measure plume surface interactions to aid in the development of precision landing sensors. Okay, so more uncrewed landings from either one is probably what's needed at this point. You know, so seeing this, it makes Jared Isaacman's decision to switch the next Artemis mission to like an Apollo 9-esque low Earth orbit lunar lander testing rendezvous, etc., etc. It makes a lot more sense. It makes way more sense, actually. Yeah, that's and I would like to add, on a flame trench like a year ago, you said test SLS in low Earth orbit, and I called you a schmuck for it. Well, I was wrong.
Yep.
You called that right. You were right on the money there. Do you remember that?
I do remember that.
Yeah, no, you were right.
Everyone thought it was ridiculous for that. Why did you use such a powerful rocket just to go into low Earth orbit at that point? Well,
no, good
I
for
want
you.
you to bring that up Friday so I can officially get and I told you so.
No, that's fair. It's totally justified. I said you were nuts. My bad.
Yeah, but also it's also interesting now to see how many HLS vehicles we're going to see. So is the HLS vehicle that they're going to use in low Earth orbit just for testing and docking and systems? It's the same one that they're going to use for their uncrewed lunar landing test now.
I actually talked about that when Jared Isaacman first kind of proposed this architecture. Yeah. Actually, that's what I would do. You get an HLS up there. You have people test out the life support systems. You have people test out manual control, rendezvous proximity operations, stuff like that, right? I mean, RPOD will be demonstrated when people get to it. But have your crew stay up there, do a month duration on Starship, or just a month dock to the lander to get to just shake down everything, make sure everything works. You don't need fuel in the tanks to do that. Right? SpaceX doesn't need to do on-orbit refueling, right? They can just send an HLS up there, and then later they can use that HLS to test on-orbit refueling and also do their uncrewed landing demonstration. Blue could do the same thing with Nuglins. Smart. It's a really good idea, dude.
Yeah. But will they test like you fly?
Yeah, we'll see. So, next bit. NASA is not adhering to the test like you fly principles for the HLS uncrewed flight demonstrations. Uh-oh. Any information on HLS thrusters for landing? I haven't seen anything in here, Max, but I'll look. SpaceX and Blue Origin are conducting uncrewed demonstration missions of their landers. However, these tests will not be in configurations fully representative of their planned crewed vehicles. NASA performs key risk reduction activities by requiring providers to conduct ground testing and flight demonstrations. Demonstrating a vehicle in a flight-like configuration, known as test as you fly, is a key risk reduction activity that helps minimize the likelihood of mission failures by identifying and correcting hardware, software, and mission design flaws before systems development. We'll see it. We'll see, Trey. Let me read. Test Like You Fly calls for the configuration of a tested system to be as close to practical in its final operational configuration. Additionally, the evaluation should occur as near as possible to the expected operational environment, using the final processes and procedures in which the integrated system will operate. Test Like You Fly encompasses both system-to-system testing, as well as end-to-end testing of the complete operational system. As a result, tests and simulations should accurately reflect the planned mission profile. To Test Like You Fly, the HLS program examines the applicable mission and flight characteristics to determine the extent they can apply them on the ground, including through a combination of testing and analysis. When ground testing is not possible, flight testing can serve as an acceptable mitigation. Yeah. Yeah, the context of that statement is like re-entry, for instance. You can't test for re-entry on the ground. That's why SpaceX was adamant about getting a Block 2 to make it through re-entry, and why they were doing all these tile experiments on Starship during that time.
Even though you were just showing the sled that basically simulated re-entry heating.
It's more for hypersonic missiles, but, you know, I said it once, I'll say it again. Testing at that scale, I'd rather use an arc jet. That would give you a higher fidelity flight re-entry, but even you can't test the arc jet on a 14-story building worth of lander, you know?
True. And everything goes well when you do that with, say, I don't know, the Artemis 1 heat shield, where you think you do all the testing on the ground, and then you get to it and go, hey, this kind of is breaking up.
Yeah, the charring and spalling. I still have thoughts about that, but I don't want to cast bad juju on the Artemis 2 mission, because even if there is a problem, I can't do anything about it, so. All right.
So that's what this is reminding me of, just seeing that.
Mm-hmm. Let's see. Question. During the first HLS moon landing test, could they put an Optimus robot as a crew test dummy? I mean, yeah, sure.
Wouldn't put it past SpaceX.
Yeah, that'd actually be a really good idea. Put one in the spacesuit. Serious. Put one in a spacesuit. Why not?
We had Ripley on DM1.
Yeah. Right now, they use what's called an anthropomorphic test dummy. It's basically a crash test dummy. It's the same instrumented simulated meat bag that they used in car crash tests. Yeah, they because they have sensors all over them that detect what's called shock. Because you and I are basically a gigantic water balloon, and it tests shock acceleration and deceleration. Those test devices are instrumented for that. The reason why shock is like quick deceleration like a car crash, or quick acceleration like a rocket ascending up into space, right? And yeah, you can pop the water balloon. Yeah, you're a giant ball, like bag of water. If it pops, you're gonna have not a good time. Yeah, that's why they test shock acceleration and deceleration, like quick changes in decel and excel. Nah, I'm a beer balloon. Yeah. I mean, me too. Me too. Conan, the president after Optimus gets stranded on the moon. Our heroes are epic men of nuts and bolts. Epic men of nuts and bolts. They have many nuts and many bolts. It's like they're made from metal or something. I don't know. Wait, it's a robot? Yeah, that's fair. I can see that.
Oh my gosh.
There's 27-month resub. Thank you. Sorry. It's just an impression. Just having a little fun. All right. While HLS program officials believe the program is following agency guidance on Test Like You Fly, we found key missed opportunities to apply these principles to the uncrewed demonstration missions. For these missions, NASA required the providers to demonstrate precision landing on the lunar surface, transmit the lander's state of the health for 2 hours after landing, and subsequently ascend from the lunar surface. The agency, however, did not require demonstration of crew systems such as ECLIS, environmental control and life support systems, airlocks, or the elevator. Why?
That's what?
Why would someone do that?
Isn't that gonna change things? Because if you don't have the ECLIS, if you don't have the airlocks, you don't have the elevator, if you remove all that, that's mass that's being removed too.
Trey, what are you linking to me? From SpaceX's update from October 2025. While many of SpaceX's remaining HLS contract milestones are tied to flight tests, such as ship-to-ship propellant transfer demonstration, SpaceX has started fabricating a flight article Starship HLS cabin that will include functional avionics, power systems, crew systems, and mechanisms, environmental control and life support systems, cabin and crew communication systems, and a cabin thermal control system. This flight-capable cabin will enable engineers to demonstrate the high design maturity of the various systems required to support a human landing on the moon. Well,
where are they testing that?
Yeah, that's what the OIG's beef is with here, Trey. It sounds like the uncrewed landing demonstration is not going to have that you just said on it.
Yeah, they want to test that. That sounds like Earth-based tests, not, hey, we're 250,000 miles away on the lunar surface at a random angle in the southern pole of the moon, trying to be able to use all of these systems.
It's flight capable, though. They could fly it.
Could and will is, I think, the key words, though.
Yeah, that's what the OIG is making a fuss about, Trey. Basically, the OIG is saying, cool, take that and fly it, please. And SpaceX is like, well, I don't know if we should. And NASA's like, hey, what are we doing? All right. The exclusion of systems means the weight of the test vehicles will not be representative of the crewed mission vehicles. This in turn reduces the number of propellant tanker flights required to support the demonstrations. That's why they're doing it. There's your problem. So they can be expedient.
But that's the thing. If you and I sitting here can come up with this just, BSing and coming up with concepts, how come teams that are entirely devoted to figuring this out didn't think that might be a good idea?
Yeah. Dude, I don't know. I mean, like I said, this is not necessarily a critique of. Remember, it's not necessarily a critique of SpaceX or Blue Origin. This is a critique of NASA's management. So, like Trey, in the context, it doesn't necessarily say that. Okay, SpaceX. It's not that SpaceX doesn't want to test, a full-blown HLS on the moon. It's that they said that they weren't, and NASA was like, yeah, that's fine. Okay. That's what this paper is about. It's not necessarily about the methodology as to what SpaceX and Blue are doing with their systems. This paper is critiquing NASA being like, yeah, that's fine, man. Do whatever. Just go with what you feel. It's good.
Yeah. That's what it comes down to. It's SpaceX has their own opinions, which is fine. But when it's as they flat out said in the beginning, they are the oversight of all of this. It's NASA spending money to get these landers so they don't have to make them themselves. And if NASA's putting money into it, they want to say.
Yeah. Got it. So SpaceX could be doing it, but NASA management is kind of crappy.
Pretty much.
So Trey, all right, I'll cut to the chase here with this, guys. So Trey, you know when Jared Isaacman, you know what he's been saying about NASA's skills have been atrophying, right? Because they farm everything out to contractors nowadays, and not many people work for NASA. And he wants to bring that technological expertise back in house. I'll bet you Rook looked at this OIG report, because NASA gets to look at OIG reports before, like months before they come out to the public, because they have to agree or disagree with them, right? And only after they've agreed or disagreed on certain points will the OIG release the report. I'll bet you Rook saw this sometime in late December and went, what the actual frick? Or, you know, in preparation for his role after his first confirmation before it got pulled, probably saw this or something. This is what he means. Remember, this is a critique of the management. This is the people running the HLS program for NASA, not necessarily SpaceX or Blue. This report's pretty damning in that I don't think anybody running this program actually gives a frick about landing people on the moon. It certainly seems like that.
It's worth noting, the NASA response, by the way, is included later on.
Mm-hmm.
It was written by Dr. Lori Glaze. So
I'm very interested in her thoughts. Lori Glaze runs the Artemis program for NASA. Okay, this in turn reduces the number of propellant tanker flights required to support the demonstration Starship landing. Therefore, end-to-end propellant aggregation will not only be full flight tested prior to the first crewed missions. Hang on. This in turn reduces the number of propellant tanker flights required to support the demonstrations. Therefore, end-to-end propellant aggregation will not be fully flight tested prior to the first crewed missions. Likewise, in our judgment, not including an elevator on Starship's uncrewed demonstration mission eliminates the opportunity to test its ability to operate in the actual lunar environment under possible surface tilt conditions. Rarest, you're asking, do you think this is one of the reasons Rook put Steve Stitch on the HLS program? Yes, I do, actually. That makes a lot more sense in this context. Sorry, did you hear about that?
No, I didn't. Oh, yes, I think I did, actually.
Steve Stitch, he was managing the commercial crew program. They moved him.
Yeah, he was reassigned, I think, after the Boeing report and went here, right? Was that it?
Yeah, he moved him to HLS, and Joel Montalbano took his position at NASA.
Yeah.
And he's running the HLS program now. Originally I thought that was because of the Type A mishap. No, now that seems more like just a coincidence. Steve can run a program. He's done really good in the commercial crew program. Arguably one of the best NASA programs one of the best programs that NASA has. And you know what? Like Sawyer, now that I'm really thinking about it, during that whole Starliner CFT fiasco, he was very straightforward about what was going on. Like he wasn't like, oh, I don't know. Like he was like, no, this is what happened and we had to fix it and this is how we fixed it, right? So that actually makes that Rarest. That's a really good point, dude. If I was a betting man, that's what I would bet is going on.
Good. That's really a good catch.
Yeah, good. Yeah, that was good, man. Okay. Additionally, although some systems require crew member presence to fully function during a lunar mission, NASA will be unable to observe the impact of operational sequences and the lunar environment on the equipment itself prior to the first crewed Starship and Blue Moon flights. For example, NASA is forfeiting the opportunity to examine the effects of lunar dust on the ECLIS components. As experienced during the Apollo era, dust can degrade a system's performance by adhering to seals and clogging filters. NASA officially told us the decision to exclude ECLIS was a careful choice based on risk, cost, and schedule. Okay. So
why do you want to bet that? What do you want to bet that's not the exact order that they had their priorities in? I think you go backwards.
Yeah, schedule, cost, and then risk. Yeah, emphasis on schedule. Love Eagle. Still, even if it is mainly NASA management that have let these things go through, I assume it was SpaceX who initially proposed them. So both parties are kind of at fault. Lava Eagle, you've been here for a good while. I've always said that it's not entirely the contractor's fault for doing this kind of stuff. NASA not holding their feet to the fire is arguably one of the reasons why the Starliner program is in what it is in the situation that it's in, because NASA's just like, all right, Boeing had a whole proposal, and their proposal seemed sound until it wasn't, and NASA accepted it because they were like, oh, you guys know what you're doing, you're fine. No, wrong. It's not just it. NASA can say, no, that's a dumb idea. Let's not do this. But they don't. They always bend over backwards for contractors. And they've been doing that basically going back even well into the shuttle program. That's what that whole Starliner thing is all about.
And here's the other thing to keep in mind, too, is the fact that these programs are so far along now that we're seeing, like with Starliner, seeing the thruster issues, seeing all of the other issues with the doghouses, things like that. That's not something you can easily change because that is built into the system, and that should have been either caught or corrected or looked at years and years ago. Same thing with HLS. Starship is already on version 3. If there were other issues with Starship and its cabin and HLS and things like that, these are things that NASA should have gone right up to SpaceX and said, hey, these are things you should be worrying about now, not after we're already on the 3rd version of Starship.
Yeah. Woof. All right. To further define the dust environment, the HLS program is conducting 2 ground tests in fiscal year 2026. A primary obstacle to executing flight-like tests on the ground, however, is that many spaceflight attributes are impossible to recreate on Earth. Yeah, like I said,
we were just talking about that.
The wrong ground. You can test it out in the desert as many times as you want. That's not the same.
Or just leave monoprop in tanks out in the desert. That's fine.
Yeah, that worked.
Sorry, had to bring it up.
Dude, what a nightmare. For example, during the Artemis 1 flight test, Orion's heat shield experienced unexpected material loss during re-entry into Earth's atmosphere. Oh boy. Despite extensive ground testing prior to the mission, this issue did not fully reveal itself until the vehicle experienced the extreme heat of re-entry, a flight condition that cannot be adequately replicated on Earth. Curious. The lander's ability to lift off and ascend from the lunar surface is also essential for crew survival, as the ascent phase contains some of the highest risk events. Oh.
That feels like a no-duh moment, but yeah.
Once the crew completes the mission on the lunar surface, they prepare for ascent by performing required vehicle configuration and system checkouts prior to using the HLS to return to the orbiting Orion or gateway in rectilinear halo. All right, Orion. To Orion. The ascent phase begins with liftoff from the lunar surface, continues through the time spent loitering in low lunar orbit, and ends when the lander enters rectilinear halo orbit. Ascending from the surface of the moon will kick up debris that could damage the vehicle or its engines. The engines could fail to ignite, or the propellant burns needed to return to rectilinear halo orbit could malfunction. Just for reference here, guys, a rectilinear halo orbit, so the orbit that they wanted gateway in, is a very eccentric orbit with the apollune near escape velocity altitude. So, like, it's almost out of the lunar gravwell, and perilune, closest point, like, I don't know, maybe less than 100 kilometers off the surface. It is a very eccentric, higher orbit at times, and you need enough delta V to escape the moon's gravity to get to it. That's part of the reason why NASA accepted Starship's proposal, because Starship is big enough to do that and move stuff down to the lunar surface that is actually of use. That's why. So if you think like, Starship's too big, well, that was one of the driving reasons. What they didn't really take into account is that the thrusters on Gateway weren't enough to keep Starship in the right orbit. Starship is too big, for Gateway. So, oops. Although NASA did not initially require ascent tests in Although NASA did not initially require ascent tests in its contracts with the providers, to the agency's credit, these tests were added later. However, the agency still did not require the providers to demonstrate an end-to-end ascent, return, and docking with either Orion or Gateway in rectilinear halo orbit. SpaceX's ascent test will include lifting off the lunar surface and relighting of the Raptor engines. This brief engine relight is critical for demonstrating main-stage combustion to buy down risk for the crew ascent and observing the lunar plume surface interaction with the engines. Blue Origin's ascent test will include lifting off from the lunar surface as well as an ascent to either low lunar orbit or rectilinear halo. Hey, Alleviate, what's up, man? SpaceX is just doing a Raptor relight.
That's wild.
Huh.
I mean, I guess it's a good thing, but obviously, I'm glad they added the, hey, we should probably test getting off the moon. But yeah, then the whole, hey, we still have to rendezvous again with Orion. So how are we going to test that? Well, we'll fire up a Raptor. Not more than that. No, just fire a Raptor. It's fine.
Yeah.
Being exposed to the literal lunar regolith underneath it for all of that time.
Interesting. Lava Eagle, what do you got? Another funny thing is that rectilinear halo orbit is actually adding velocity in a direction perpendicular to what is needed for the cheapest ejection angle for trans-Earth injection. Yeah, I understand what you're saying, because it stays anti-normal to Earth. Yeah, it stays coplanar anti-normal in its orbit. So yeah, that's long story short. If Earth is here and the moon is here, the rectilinear halo orbit goes like this. The problem is you need to go that way to get to Earth. So yeah, that's a funny point. Yeah, I didn't really think of that.
Apparently, neither did NASA. This is the part that scares me. I did read this one in full because it, the headline piqued my interest. So this is very interesting, and I'm interested to see everyone's reactions to this.
You want to read this one?
You got it, because you've got it up on your screen. There's a delay with mine, so go for it.
Okay. NASA's crew survival analysis limited by functional restrictions and resource considerations. Okay. Crew survival analyses are tools employed by NASA to capture the survival posture of any given Artemis mission. The HLS program uses the crew survival analysis process to evaluate available survival capabilities that can effectively counter a catastrophic event, such as a fire, and provide crew members an opportunity to reach a safe state or place. See, that right there, just real quick, Carrot, that's always been my criticism of Gateway. I don't, if you want to do that, that's fine. I don't think NASA is. But the problem here is that, like with Apollo, the ascent module certainly is your only way to get back to the CSM, right? And that certainly is a risk, but it's a much bigger risk if Orion can't go any lower than rectilinear halo orbit. You have a much longer transit time coming up from the surface to get back to Gateway and then get to Orion and then get home. If there is an emergency, Orion not being able to get into low lunar and do a trans-Earth injection burn on the fly, it is really dangerous. And that's actually really happy. I'm wondering if they say that here, but anyway. If the analysis reveals there's no confirmed capabilities to safely extract astronauts from the immediate hazard, then crew survival gap exists. Yeah, we know about those, Sawyer. Survival gaps, particularly.
Yeah, thanks for reminding me.
Yeah, in ascent corridors. That's weird.
If left 2 minutes and 5 seconds of not being able to get out of something? No.
Yeah, no, it's fine. If left unaddressed, these scenarios will result in the loss of the crew. Once a crew's survival gap is identified, the HLS program may choose to accept risk or generate a decision package for elevation through the Moon to Mars program office. Decision packages are the mechanisms used to identify recommendations for new or enhanced capabilities that improve the likelihood of crew survival. They assist Moon to Mars program office leadership in making risk-informed decisions on the inclusion or exclusion of these capabilities, as well as in the acceptance of any residual risk. They could use the Starship as the gateway then. Yeah, there you go. The intent of the
But
cruise, yeah, right, yeah. The intent of the cruise survival analysis process is to influence requirements and designs early enough in the vehicle's development to have the greatest impact on crew survival. However, there are limitations due to the functional constraints and availability of resources. For example, because the analysis is typically mature later in the design cycle, the decision packages are limited to capturing resultant risks rather than preemptively driving risk reduction. As a result, the lander design may be too advanced or institute meaningful change or require significant impact to the schedule. Moreover, funds may already be depleted. Additionally, crew survival analysis are limited to considering a single catastrophic event at a time and do not address the occurrence of multiple simultaneous events.
What?
Okay. This logic assumes that when the crew is safe from the catastrophic event, all systems will perform normally to return to their safety after the initial incident. Who did this? Who did this? What is wrong with you? No.
Yeah. By the way, remember what I was saying earlier? Hey, maybe they should probably come up with these, catch these issues earlier and implement them earlier in the design process. Well, obviously they agree with that, but yeah. Hey, we had one failure, because we've never seen it where one failure, I don't know, say stirring a cryo tank, an explosion leads to a failure, followed by failure, followed by failure, followed by failure, where you have to then basically get down the power of your entire vehicle into that much of a hairdryer and camp out inside a lunar landing vehicle that was never meant to house more than 2 people.
Yeah. Another thing I
Never
could think,
happened.
yeah, no, another thing I could think of is, SRB blowby. You launch it and, it's SRB blowby isn't going to blow up the vehicle unless it's in the right conditions. Not just because you have SRB blowby doesn't mean every other system is operating correctly.
Yeah, that part is just, it irks me so much.
Yeah. Guys, like I said, this is what I mean. This is not a criticism of SpaceX or Blue. This is very much a criticism of the people running the HLS program. Rarest, I'm going to mention that on Flame Trench, dude. This explains Steve Stitch moving to HLS more than anything. That's a good move by Jared to do something like that, because whoever's running this program does not understand what's going on. Yeah, I could already tell you that whoever's running this this person is not taking their job seriously at all. Wow, that's arguably awful analysis. But anyway, the analysis also do not account for extended crew survival once the immediate threat is over, since the crew may be in a compromised situation for several days. Yeah, it's like what you were talking about, Sawyer. That's it. Yeah. Yeah, Strickland,
It gets worse.
What would you say you do here? It gets worse? Oh, jeez.
Well, no, I'm just saying that alone there means it gets much worse.
Oh, yeah, okay, yeah.
Yeah, so cool, you get out of it safely, but now what? You're stuck. Hey, remember about the ability, to launch another shuttle if something went wrong after Columbia? STS-125, STS-400?
Yep.
With Artemis, the current pace that SLS is at, that's totally doable. Not.
Yeah, this also explains the Block 1S. The standardized Block 1 configuration, Sawyer, makes a lot more sense in this context from reducing risk for the first couple of initial landings. Yeah. That makes way more sense now, actually. It's not, if you think about this from a crew safety standpoint, having SLS work reliably and being able to mass produce it is much more important than it having a better upper stage. That's something I really didn't consider. But yeah, having an STS-400 contingency for SLS is probably a good idea. Meaning, guys, that if a shuttle, so back in the day, actually, sorry, you want to explain STS-400?
Yeah, basically, so when Atlantis launched on STS-125, which was the final Hubble servicing repair mission, they also had Endeavour out at 39B. They hoped to never have to launch it, but the plan was that if something were to go wrong, they didn't have the International Space Station to be able to rendezvous with, hang there for 30 to 60 days or whatever until a vehicle could come up, gather them, and bring them home. There was no safety net that they could go to. So what they had was an entire contingency plan where if they got stuck or there was damage to the tiles that made it unsafe for them to return, Endeavour would launch. It would have a robotic arm to robotic arm connection where they would basically hook onto each other. They would use tethers to string themselves along the arms and spacewalk from one orbiter to the other, leaving the other one in space damaged and getting back in one that hopefully isn't damaged.
Mm-hmm. Yep, there's a picture of STS-400 right there. And it's one of the gnarliest pictures from the shuttle program. It goes so freaking hard.
Yep.
I love that picture, dude.
So cool. I'm also glad it didn't have to happen. But if you look at the documentation for it and how they would have to connect everything, literally they calculated the exact order of which astronauts would have to go over at which times, because then you'd have to send people back and then go back again. And how are you going to fit? I think there would just be a crew of 2 for Endeavour, so fit 9 people into the orbiter.
Jeez.
Yeah.
Driados is asking, can they launch a Dragon on Falcon Heavy for some of the contingencies? Dragon's not really rated for beyond low Earth orbit activity, guys. That's a different environment, dude.
Discovery,
Falcon Heavy not crew rated.
Yeah, Falcon Heavy is also Falcon Heavy is not human rated. Yeah. All systems 101 month resub. Thank you. Yeah, honestly, guys, like STS-400 should have been the case since the start of the damn shuttle program. Like that, yeah, and yeah, I would have always tried to have a shuttle teed up and ready to go just in case. Like that's yeah. Falcon Heavy is not rated until the USDV launches. What? Nervous? What do you mean?
Didn't think that had to be crew rated because it's a specifically designed vehicle for deorbiting. And it's not going to have people on it, it's my understanding.
The deorbit vehicle's launching on a Falcon Heavy?
Yes, it is. I thought you knew that.
Yeah. Yeah, no, that makes sense. Wait. No, Nervous. What I'm getting? No, I knew it was launching a Falcon Heavy. What I'm getting is that Falcon Heavy needs a human rating to fly the USDV. Is that what I'm hearing?
It shouldn't. Because there's no people on it.
Oh no. Oh, okay. All right. I was like, dude, no way. That'd be pretty sick, though. I mean, dude, if something like the USDV would be great for if you need to get away, if you need to get something out to the moon in a pinch. But from what Sarah Walker, I think her name is, from what she was, I think her name's Sarah Walker, I forget. From what she was saying, it sounds like the USDV was more of a one-off bespoke type thing. But honestly, if SpaceX wants to make more of those and use those as like a gateway logistics or, you know, some type of Orion low lunar resupply vehicle, I ain't gonna complain, dude. Deorbit vehicle, the USDV, Yarg. It's a highly modified Dragon with a service module attached to the back that's designed to deorbit the ISS. Dude, that thing has an insane amount of delta V by itself. It only has about 50 meters a second delta V when it's attached to the ISS for deorbiting operations. The ISS, for instance, is adding 400 tons of dry mass to your rocket equation. So if you think just say the, United States deorbit vehicle, so this modified Dragon with a service module has a mass of probably, 30 tons, right? 430 tons. If you back solve the delta V equation, right, to get you 50 meters a second with 430 ton dry mass, right? That tells me that the USDV with Orion, like not Orion, the USDVs it could get to low lunar. It could get to low lunar on a Falcon Heavy. Yeah, uncrewed, but it could do it. Yeah, that my theory, Nova One, is that the USDV is Dragon XL, but I don't know for sure. I can't prove that. But then again, what's the point of Dragon XL in the first place if Gateway doesn't exist? But then again, sorry, Sawyer, I'm theory crafting here. But then again, you could always repurpose Gateway. Gateway on a Falcon Heavy could go to low lunar. It should be fine. I mean, if you decoupled the habitation logistics outputs and went back to co-manifested missions with SLS, you could do that. Or you just have Falcon Heavy move the PPE in one shot, and then I don't know how you'd move the habitation and logistics outposts from there, but yeah, that wouldn't work. What would orbit stability be in low lunar? You would need something with propulsion, Zelensho. Low lunar is not a stable resonant orbit. The lunar has non-uniform. The moon has non-uniform gravitational pull. It has huge precession, and you can actually get decaying orbits on the moon in real life. That's what happened to most of the ascent modules from the Apollo program. They crashed on the surface of the moon somewhere after people left, after people got out of them. One of them is still around. It's in deep space somewhere. We have no idea where that is. Snoopy. True story.
Oh, yeah. The search for Apollo 10.
Yep, the Apollo 10 ascent module is the only flown ascent module with people on board that survived. It is somewhere orbiting around the sun. It's probably long gone by now.
There was a whole campaign like 10 or 20 years ago to find Snoopy. It was really interesting. If you look it up, there was a whole campaign about it. It's a cool story.
Neat. Are you telling me to set up a USDV whenever Orion launches to bring it back from the moon if the engine fails? No, but that's actually not the stupidest thing I've heard of, Levern. That's it's not a bad idea. All right.
Back to the their guesstimate on the risk of loss of crew.
Yeah, I don't know, all systems. It remains to be seen. I have a guess that this report was given out before they decided to shake things up with the HLS program, so who knows. Hey, DNA2 Mars! Becoming a member, becoming a flight controller at the Eric Johnson Space Administration. Thanks, buddy. Right on. Let's see. Given that many HLS decisions rely on meeting safety thresholds, the identification of catastrophic hazards and crew survival gaps are crucial, considering the lander is the top loss of crew contributor for the Artemis 3 and 4 lunar missions. Now Artemis 4 and 5, because, yeah, it's changed. These results are based on the risk of failures in Starship's avionics, main engines, lander propulsion, landing legs, and electrical power. Wait, what? The agency's loss of crew threshold is 1 in 40 for lunar operations and 1 in 30 for Artemis missions overall?
That is horrifying.
That's worse than the space shuttle.
The space shuttle ended up 1 in 76 in its final numbers. And that flew 135 times. And it's interesting that it's 1 in 40 for just lunar ops, but the entire missions overall is 1 in 30. So if we go with, like Rook was talking about at the original rollout, all the way up to Artemis 100, that is 3 failures potentially in that, and 2 lunar operation failures. What?
Wow. Okay.
And yet, read the next line. This is what's even scarier.
I'll allow that, Nader, even though it has a curse in it. But yeah. Current estimates for Artemis 3 and 4 show Starship in compliance with the agency's established thresholds. The top loss of crew risk contributors for the Artemis 5 mission are still under development, according to NASA officials.
So that's the Blue Lander one.
Yeah.
But that's the crazy part is that's the threshold, and SpaceX is within that. So that still means that there is a 1 in 30 chance that there will be a problem with a HLS lunar Starship mission.
Trey, you're saying, hey, that's 3 times safer than Apollo. Apollo was expected to be 1 in 10, right? Yeah.
I thought it was higher than that. I thought it was like 1 in 20.
Yeah, I think it's higher than that, but yeah. Drew, what do you say? Does NASA, Drew Nar is saying, do NASA astronauts get hazard pay? Yes. For on orbit, yes. Apollo was 1 in 25.
Oh, okay, that's close.
And that's what I mean, dudes. That's very telling. Just because we went to the moon 50 years ago doesn't mean we know how to do it now. That's something I've been saying for a long time. Okay. Further driving survival concerns is the introduction of multiple new systems during the early crewed Artemis missions, including the landers, next-generation spacesuits, Gateway, and elements of Orion. This will be the first time NASA will, 1, have Orion and the lander operate in rectilinear halo orbit, so that's out. Jared axed that plan. 2, dock the landers with Orion or Gateway. That's gone as well. They're doing that in low Earth orbit on the Artemis 3 mission. And 3, land and return humans from the moon's south pole. Yeah, they're doing that on Artemis 4 and 5.
So that one's still a risk. And also just docking the lander with Orion as well. It doesn't say necessarily in lunar orbit. It just says docking the landers with Orion.
Yep. Unknown unknowns and underestimated risk are more prevalent with early flights because of the lack of data about how an integrated system behaves in an actual flight environment. Yeah, see? Rook definitely... Jared Isaacman read this. He read this exact thing and said, this is dumb. We're not doing this. This is evidenced by comparing risk estimates to early launch vehicle failures. For example, the Space Shuttle program thought they were operating at a 1 in 100 loss of crew threshold, but years later determined the actual number was about 1 in 10 for the early flights. Similarly, during Apollo, and keep in mind the context of this statement is early in the program, like the first mission. So this is Apollo 8, Apollo 10, Apollo 11. Similarly, during Apollo, the risk of loss of crew was also 1 in 10.
There's the 1 in 10 number, I guess.
1 in 10. 1 in 10. Don't want to land and crash on the moon. One more indecent accident. Sorry.
That's my favorite part of that song.
Yeah. This makes a lot... Jared Isaacman's plans make a lot more sense now. Yeah. This really kind of puts it into perspective.
This is why I wanted to jump on with you, because I glanced over it briefly, but hearing you talk about it, it's like, aha, now things make so much more sense of why.
Yeah. Jeez. Yeah, if this had kept going the way it was going, we probably would have crash landed on the moon in 2029. You know? Like, that wouldn't have been... Okay.
So yeah, about that's the other thing. Just seeing that headline right above your head is also ominous.
Yeah.
Just saying.
Yeah, we'll check that in a second. Hey, Dark Silver Space, what's going on? Some scary numbers here, for sure. There's still a chance for a crash landing. Yeah. Anonymous.
There's always a chance.
That's what I mean. Unknown unknowns are just that. Unknown unknowns. But if it kept going this way, Hellfish, we definitely would have crashed on the moon. That would have happened. All right. Anonymous, do you think somehow Jared could stay as NASA administrator longer? NASA administrators are not necessarily beholden to presidential term. Dan Golden served through 2 different presidents. And he was a NASA administrator. That has happened. Yeah, it's definitely a thing. Jared, if whomever gets elected president in 2028 likes Jared, he'll stay. Seriously.
I feel like he has enough of that bipartisan charm to be able to make it happen.
Yeah, Sawyer, I'll say that dude seems like he's smart enough to pull that off. Let me put it that way. He's
well
savvy
said.
enough.
Without getting too deep into politics, perfectly put.
Yeah, Jared has the balls to pull that off. He could definitely do that. The guy flies around in a MiG-29 for fun. Okay, he could definitely figure that out. He's definitely smart enough.
And takes NASA employees and lawmakers along with him.
Yeah. If he wants to stay on, that's correct. Yes, he can leave whenever he wants.
Yeah, if he says, I want to go on to the next Polaris Dawn mission and pieces out, he can do that.
See, Sawyer, my personal theory is that Polaris 2, the next Polaris 3, the first, or no, it was Polaris 2. My personal theory is that the Polaris 2 mission was basically what Artemis 3 is now. That's my theory.
I agree.
I think Jared Isaacman was going to send a dragon. He was going to fly on a dragon to a starship up in space and dock with it and live on it Skylab style. I think that's what the Polaris 2 mission was. That is entirely speculative. I'm completely pulling that out of my tail. Because we know Polaris 3 was supposed to be the first Starship crewed flight. How safe do you think space flights should be? I mean, I'm not a safety advisory panel person, right? I think that you don't. Okay, you really want my honest opinion? You don't sit here and sitting here and trying to be deterministic about probability of loss of crew in the early parts of the program means your program architecture and ConOps weren't good enough. If you really want my honest to God opinion. The reason why Apollo carried such a risk is because of schedule pressure, because land on the moon before 1970. The shuttle does not have that same excuse, to be 100% real. Now, if schedule pressure is not a thing, right? You achieve, your safety is derived from operational execution, right? Operational execution and high flight rate when it comes to spacecraft. Same methodology could be applied to flying an aircraft. You never, ever let your guard down when you are flying an airplane. Ever. Period. Full stop. The second you let that skill atrophy, you crash. Something bad happens. I read the NTSB reports all the time. All the NTSB reports that come out, I read them, and then I watch videos about them too. Shout out to Juan Brown and the Blanco Lirio channel on YouTube. You want to learn about aircraft safety? We achieve the airline industry and the airplanes are so ridiculously safe because you never let your guard down. The second you let your guard down, the engine falls off during ascent. During V1, the second you let your guard down, you don't file your flight plan, you don't file your IFR flight rules, and you take off in low visibility, right? And then you try to file the flight plan with the center, and the center controller says you're an idiot. What are you doing? And then the plane crashes. All right. I've learned a lot from Juan about how you do and don't do airplane stuff, right? And a lot of that carries over into spaceflight, something I know a lot about. What's acceptable risk? You don't have to have acceptable risk if your concept of operations are good. Right? The idea is to buy down as much risk as possible. That's my problem with the Orion heat shield. Do I think that revised trajectory is going to work? Yeah, it'll probably work. Probably work is not good enough for me when people are flying on it. I don't give a frick what anybody says. Probably is not going to work. If you were getting on an airline, if you were getting on an A320 and you asked the pilot, hey, are we going to get there? And he's like, yeah, we'll probably get there. You'd be like, what? What are you talking about? Right? So how safe is safe? Safety is achieved through operational execution and consistent operational execution over a high flight rate. That's how you make spacecraft safe. You don't sit there and try to be deterministic about probability of loss of crew. Look where that got us. Sorry, I'll put my soapbox down, Sawyer. Let's read the next one.
It's all good. At least I can't get on the soapbox unless there's a ramp to it, so it's fine.
Hey, in my stream, the soapboxes are ADA compliant. You are more than welcome to soapbox if you want.
I'm good. I prefer an Apple box. Anyway, continue.
Is it bigger? I don't know.
Does size matter?
right.
Let's read the next part.
Next topic. All right. All right. Safety is achieved by not necessarily focusing on safety. If you accomplish the mission and then do it again, it will be safer and safer. Practice. Yeah. If you practice lazy, you play lazy. You practice hard, you play hard. Operational execution. Do the same damn thing every single time without deviation and nothing will go wrong. Physics is physics. You can work. You don't want to push against physics. You want to work with them, right? Size matters in rockets. I mean, yes, I would. Yeah, Yarg, yes, that is correct. Blanco Lirio is the best. Juan Brown's a G, dude. I'd love to meet that guy. He's awesome. Yeah, dude. I learned so much about just airplane stuff, and yeah, reading about like the mistakes that people make, like that flight out of Bangor, Maine, the NTSB report, they exceeded de-ice rules by 15 minutes and then tried to take off in a blizzard. Like, I'm not sure what you thought was going to happen, but what you thought was going to happen did not happen. Like, and the reason why is because they ignored FAA de-icing rules. Like, that's just, those rules are there for a reason. They're not there because some bookworm was like, yes, you have to sit there and waste your time. Like, with a derated takeoff on a contaminated runway. What are you derated? Oh yeah, 85% takeoff thrust. What are you doing? Like, what are you? Stop! Oh my god. Dude, I don't know anything about planes, and I know enough to be like, don't do that. Nope. Dude. Yeah, there you go. Get theiritis, dude. What flight was this? It was a Gulfstream that took off out of Bangor, Maine, and a little while back, Shaw. Didn't even look to see if it was built up on their wings, dude. What? Yeah, like, what are you doing, dude? Like, what?
Yeah.
Like, what are you doing? Stop it! Stop it!
Stop it. Get some help.
Stop it. Get some help. Did they crash? Yeah. Yeah, they crashed. No one survived. Yeah, great. Great. Lovely.
Speaking of potentially people not surviving, great transition. I'm good at transitions, right?
Yeah, no, you're great at this.
Jesus.
Yeah, they filed the oceanic clearance. Dude, what a kicker. The tower should have been like, no, you don't take off. Get out of here. Yeah, exactly, Yarg. All right, anyway. NASA ruled out crew rescue capabilities for early crewed Artemis missions.
Yep.
Oh my god. All right. Well, NASA is taking steps to prevent catastrophic events from occurring during the Artemis missions. At some point in the future, astronauts will likely encounter a life-threatening emergency in space. Yeah. Despite NASA having in-space rescue plans for Skylab missions in the 70s and for the space shuttle missions following the loss of Columbia and its crew in 2003, the agency has not required in-space crew rescue capabilities since the shuttle's retirement in 2011. Rook has a lot of work to do, man.
Yeah. You could see there, right, the little asterisk note that goes with it talking about, there's less risk for the International Space Station, so it's fine. But anyway.
Without a rescue capability for the Artemis missions, the crew will be lost should the HLS become disabled on the lunar surface or be able to dock with the awaiting Orion and Gateway in rectilinear halo orbit. That's what I mean about SLS, the Block 1S configuration being dude, that's a safety risk at this point. Yeah.
But you got to love how that's written in there so nonchalant of the idea of if anything happens with the Artemis missions, with HLS becoming disabled on the surface or you can't dock, the crew's dead.
Yeah.
That is horrible to just put that in there as a normal sentence of, yeah, this is acceptable. That if one of these things that we can predict might happen happens, we have no solution. That's what irks me so much with this.
Yeah. Spoiled, could they send up an empty Dragon on Falcon Heavy to act as a rescue boat? Well, we were talking about that with the USDV a second ago. That's actually a really good idea. You don't need a human rate Falcon Heavy, and if the United States deorbit vehicle is just more or less a Dragon with a service module attached to it, that buys down a great deal of risk, but that vehicle in itself introduces a ton of risk. What data do we have on Dragon coming back from the moon with its Pica heat shield? There is no data on that. No spacecraft has come back from the moon on a trans-Earth injection with a Pica-based heat shield. There have been some exoplanetary missions that have done stuff like that with Pica, but nothing coming back from the moon. And I don't give a frick if it works on Mars. I don't care if it works there. We're not talking about that. I don't care if it works for low Earth orbit. Trans-Earth injection trajectory from lunar orbit on a high-energy insertion is its own. That's a whole totally different beast. You're hitting the atmosphere going 25,000 plus miles an hour. There's no, oh, it'll probably work. There's no, oh, we'll fly a different flight trajectory. It has to work. Period. There's no getting around it. Is this because of bad management or bad engineering? These are programmatic problems. This is what I mean when I talk about programmatic decay in NASA and how this crappy mentality is how we lost Columbia and Challenger and almost lost Starliner. It's terrible. Yeah, exactly, Spoiled. In a pinch, I'd do it too. Sure, yeah. Agency officials noted several challenges to require a crew rescue capability. Crew rescue would require additional consumables as well as an ability to assemble and launch an Orion or lander in a matter of months.
Yep.
Yeah. To make a crew. Yeah, that's lovely. To make
by the way, the asterisk says consumables and commodities that support the conduct of a given mission. Examples include food, water, oxygen, propellant, power, and operational supplies. That's a 50 note.
Yeah, food and water. Yeah, those are important, I think.
And oxygen.
Yeah. Yeah, that last one's pretty good. Yeah. This explains the fire that's under Jared Isaacman's tail about not launching every 3 years and trying to launch at least 2 year, like on a 2-year basis. I mean, in the past, guys, I've said 4 years. The reason why I said SLS, like, for instance, should launch like 4 times a year is because of stuff like this. Because of this. Because I did my homework when I read about the damn shuttle program. Because a lot of you guys are younger spaceflight fans. You didn't live through Columbia. That was not fun.
Mm-hmm.
I wasn't even a big spaceflight fan. It was still not fun. That was not cool.
Same.
You do not want that to happen.
I heard about it on the radio and just spent the entire day glued to Miles O'Brien's coverage on CNN.
Yep. That's SLS not launching 4 times a year is very much a safety issue. I'm dead serious about that. To make a crew rescue attempt, the crew must also be able to shelter in a safe haven until a rescue can be executed. Otherwise, the scenario would result in the loss of crew. Yeah, that's generally what happens. Additionally, it can be prohibitively expensive to have a second Orion standing by to launch and rescue the crew, or to have a spare HLS resting on the lunar surface should the primary lander fail. See, here's the thing. Prohibitively expensive. All right, would you rather have dead astronauts? Like, oh no, my checkbook hurts. We need a paramedic for my wallet, but you don't need a paramedic for your astronauts. Like, I'll take that trade any day of the week. Like, what's wrong with you people?
That sentence just feels gross to me.
Yeah, what type of excuse nonsense is this? Like,
oh, I'm sorry. We would rescue the 4 people that are up there, but that costs money.
Yeah, it costs money. Yeah, that's the bullcrap programmatic behavior I'm talking about. If we if Challenger didn't happen because somebody decided to actually listen to when the vehicle has a problem, that leads to the higher flight cadence of the shuttle, and problems like Columbia aren't even a thing. That's not even a thing. High flight cadence can trump that. High flight cadence can trump everything. You have no idea how much that means for safety. Look at Falcon 9. That's a perfect example. Falcon 9 never fails. And even if there is a problem with it, there's so much data about it that the understanding of how the vehicle works, you could pinpoint the problem in a couple of hours and have it flying again a couple days later. Days. For instance, after Challenger, January 28th, 1986, they didn't fly again until late 1988.
And Columbia was February 03, and then they started flying again in 05.
Yep. What was it? 114?
114.
Yep. Watch that mission. Watch that mission
And
on
then
the television.
And then after that, there was, same, I watched the launch. After that, there was not a single mission that wasn't to the International Space Station because, with the exception of the Hubble, because it gave you a safe haven. So the one that they didn't, which was Hubble, they came up with STS-400. But to them, they had that safety net of if something goes wrong, you can send other resupply vehicles to give more food and supplies to the team living on the space station. You can't do that, 250,000 miles away around the moon.
Bingo. I mean, at very best, you're 3 days out. So, yeah, rockets, exactly. Falcon 9 was grounded for 4 days after stage didn't execute a deorbit burn. And that, dude, like, that's the thing. That's why I love SpaceX for the Falcon program. They don't take no crap. Nothing is insignificant. Every single bit of information gets gone through with a fine-tooth comb. Because that increases your flight cadence or flight reliability, and that increases flight cadence. If the vehicle is safer, if you know how the system is going to perform, you know it to a T, you can handle a sub 2 day launch cadence. You can handle 170 flights a year. That is what they tried to do with the shuttle, but idiotic program management stopped it. Leave supplies on the moon before you send people. Yeah, they call that prohibitively expensive. Lord Google, I'd call that being smart. Jeez. Wow. Dude, what a freaking thing this is. What a chonker this freaking thing is.
Yeah, and again, that's just the crew risk portion of it. That's not even going over the rest of it, like we were talking about earlier with, hey, they need the government task agreements to actually be able to use them. Of like, hey, can we use the WP-57 when it doesn't land with its gear up? Can we use your testing centers over at Marshall? And it sounds like there was a lot of times where they said no, and the cost was an issue, so it's dealing with that. And then, I mean, there's literally a section, cross-program integration interdependencies could further impact cost and schedule. And it goes into SpaceX's whole delays for Artemis 4, assuming that was going to be the second lunar landing, and Blue Origin's delays for Artemis 5, assuming that was going to be the third lunar landing, which now there's still the whole debacle of it could be one or the other. And it mentions in a weird way the whole Sean Duffy thing of, actually, we're going to try and move everything up.
Sean Duffy? Question?
Yeah.
What do you?
Wasn't he the interim guy, right?
Yeah, he was the interim. He trying to move stuff forward?
Wasn't he the one who was like, now we should open up debates between maybe SpaceX is going to take too long, so let's bring in.
Oh yeah.
Blue Origin to other people to try and get it done sooner. They do kind of address that, but yeah.
Jared Irwin over in the YouTube chat says, you had a hydraulic problem on GS2 that was out of family. Was able to look back at previous data to quickly find the solution. I can't imagine how easy it is with Falcon 9. Yeah, exactly. There you go. And what? They got two Noogles flights. Blue has 2 Noogles flights under their belt, and a plethora of testing, which we'll talk about more here in a second. Yeah, Elon. Yeah, after Sean Duffy said what he said, mark my words, HLS will land with Artemis 3. Mm-hmm. Yep.
Yeah, how'd that go?
Can we see NASA's response for it? Yeah, we'll see.
Yeah, that's one of the Appendix D, I think. Or sorry, Appendix C.
Okay, let's see what we got. So you said Lori Glaze. Yep. Associate Administrator for Exploration Systems Mission Development Mission Directorate. That's basically running the Artemis program. That's how I always say it. Hang on one second. Yeah, you ain't kidding. Give me one moment. Okay, let's see. So let's see what Laurie has to say. Sedated. Columbia is the first shuttle mission I remember. 7-year-old me has been following spaceflight since. Oh, well, that's interesting that that's what got you into it. But hey, whatever. I mean, Columbia flew STS-109 before that, before 107. Like, you know, 109 was a great mission. Just saying. Yeah, Nader,
Oh, it really was.
Experienced Challenger. As a kid in elementary school. Yeah, dude. You know, and Nader, you know, being, you know, an aviator, you can't dick around with this stuff. You can't. No monkey business. You really can't be like that, dude. Dude, like I said, if I was running an aerospace company, you wouldn't see happy-go-lucky fun EJ. If somebody clowning around, I'd be like, get the hell out of here. Don't come back. You're fired. Get out of here. Leave. Don't come back. You get one warning and that's it. And the warning is right when I hire people. Like, don't screw around. 1,000%. Yeah, 10,000% too. Top Gun is not real life. Maverick would have gotten grounded. Not even for what he did during Top Gun. He would have gotten grounded for buzzing the tower. He would have never flown a plane again, period. He would have been flying cargo planes, hauling rubber dog shit out of Hong Kong. After that, I'm dead serious. The Navy would have grounded him instantly. Top Gun shit, that wouldn't have happened in real life. The guy,
that actually happened to someone who did a flyover of a stadium way too low and way too fast and accidentally caused a sonic boom, and that was it.
Oops.
Yeah.
He would have been the rubber dog poop. Yeah, right. Dude, if you buzz the tower in transonic, you're basically going to kill everyone in the tower, guys. Like that's another thing. You were going to kill those people. It's like getting hit with a freight train of sound. All right. Conan, you watched STS-135 when I was 4 years old. Also got you into spaceflight. Hey, 135 was... Dude, that onboard picture of Rex Walheim with the absolute biggest crap-eating grin on ascent, that image lives rent-free in my head. He's flying the shuttle, he's just like, this is awesome! And the thing's just going, I'm like, yeah, also, I like you. You're all right.
Yeah, also looking back at the photo of my crap-eating grin from the ground on that one.
There you go.
I still look back at that.
All right, let's see. This is NASA's response. NASA appreciates the opportunity to review and comment on OIG draft report. On this OIG draft report, NASA is working closely with its commercial partners as they develop critical hardware elements for Artemis missions that will return American astronauts to the moon by 2028 to assert American leadership in space, lay the foundations for lunar economic development, prepare for the journey to Mars, and inspire the next generation of American explorers. Leveraging NASA's unique and historic experience in lunar exploration, paired with the speed and innovation of industry, the HLS program is providing the key lunar landing capability. Okay, we know what it does, Lori, all right? NASA acknowledges that due to its technical challenges and emergent designs, the partners' schedules have experienced delays. The agency is actively implementing mitigation measures, such as increased collaboration with experts to monitor and manage the partners' lander development while implementing lessons learned to minimize further impact. What lessons? What lessons? You haven't gone to the moon yet.
Artemis 1 lessons, which is not much.
Yeah, what lessons, right? Yeah, no, they'll just put people on the heat shield after it didn't work. What lessons?
Hey, that'll make the heat shields more ablative. Put people on it. They'll blade away first.
Yeah.
You meant on Orion with the heat shield, but my brain instantly went to, yeah, let's tape humans outside the heat shield and use that. Because my brain is messed up.
Operation Human Shield and Operation Get Behind the Astronauts. Hey, have you ever heard of the Emancipation Proclamation? I don't listen to hip-hop! All right. NASA dedicates in-house resources for risk mitigation and technology development applicable to the program at large. Okay, that's a lot of words. Additionally, NASA is working with both partners. Freaking Windows 98! Get Bill Gates in here! It is faster over 5. Additionally, NASA is actively working with both partners to accelerate lander development. Okay, we knew that. Final determinations on technical feasibility, financial impacts, and schedule adjustments will follow as implementation advances. Okay. Safety remains a top priority. Yeah, all right. Sure it does. The Artemis program emphasizes the importance of safety in all spaceflight operations.
About those numbers, huh?
You sure about that? Including the use of historical data and experience to continuously improve vehicle requirements and medical guidance. Well, the test like you fly process is an integral part of NASA's mission assurance and operational practices. Commercial partners can have alternative approaches to flight.
In other words, SpaceX blows up a bunch of stuff, so that's fine somehow.
For example, SpaceX's approach is a continuous loop that integrates testing and development into a single process, allowing for early detection of anomalies, accelerated iteration cycles, and improved data correlation. This methodology is essential for reducing cycle times, enabling more frequent testing, and ensuring that every test contributes to mission success. Yeah, those are all pretty good things. Yeah, those are good.
But also, test as you fly versus, I like that, early detection of anomalies, aka Flight 7, Flight 8, Ship 36, Booster 18.
Ship 36 and Booster 18 were not flying.
No, but you know what I mean.
Yeah, no, yeah, just say, yeah, no, I get it. It's an iterative test.
It's testing and development.
Yep. Yeah. NASA undertakes changes that no other organization, agency, or nation. NASA undertakes challenges that no other organization, agency, or nation can achieve. Where's your landed first stage? Oh yeah. All right. NASA is committed to working to deliver the safest and most effective outcomes, continuously learning to replicate what works and avoid past missteps, an essential discipline for preserving the agency's integrity and legacy. Lori, are we talking about the same NASA here, or do you work for a different NASA that I don't know about? Yeah, no, did that. Someone did that already. It's off of NASA's plate. Yeah, sure. Okay.
It's the National Association of Signing Autographs. That's the agency they're talking about that does that.
Yeah. Okay. The OIG makes 5 recommendations, 3 of which are addressed to the HLS program manager in conjunction with the assistant administrator for procurement to improve the management of government spent funds, 2 of which are addressed to the HLS program manager to enhance crew safety and survival during the Artemis missions. Specifically, the OIG recommends the HLS program manager in conjunction with the assistant administrator for procurement, 1. Ensure an approach for managing government task agreements that have been canceled, unfulfilled, modified, or realigned is formalized in HLS program policy.
So that was the recommendation that was set by this report.
And NASA says they concur with this recommendation. The request for GTAs and the government's ability to meet requests have evolved over time, which is not unexpected under a complex development program. The HLS program is developing an organized work instruction to clearly document execution and management of GTA processes.
OWI and GTA. Boy, this really does sound like Vice City.
That was a good game, dude.
But yeah, OWI is operating while intoxicated. Anyway. Completion date.
Estimated completion date, September 30th, 2026. Okay, recommendation 2. This is from the OIG. Ensure an approach for discriminating costs.
Lowering.
For lowering costs for GTA submitted after contract proposal. I don't know why I can't say that word, but anyway. Including a timeline for recoveries formalized in the HLS program policy. Management response. NASA concurs with this recommendation. NASA will demonstrate the implementation of this recommendation with the release of the HLS program GTA OI. Guajikatawi. Okay, so NASA basically said, "Oh yeah, your second recommendation is good. We're going to do that with the thing that we got for the first recommendation." So,
So it'll be one joint answer to that on September 30th.
Yeah, I'll just put it. It'll all be in my final report. Okay, recommendation 3. Update the use of government resources clause in both the SpaceX and Blue Origin contracts to reflect GTA policy changes. NASA partially concurs with this recommendation. The HLS program will conduct a thorough review and assessment of program policies and updated procedures. What the hell is this sentence? The HLS program will conduct a thorough review and assessment of program policies and updated procedures, and afterwards will determine if a contract clause update is appropriate. NASA will demonstrate implementation of this recommendation by providing OIG with the results of the assessment. If an update is appropriate, the HLS program, in coordination with the Office of Procurement, will incorporate a revised clause through bilateral agreement with the commercial partners and will align with the next anticipated modification.
See final report.
See final report. Decrementing. No, Acolytes, I know how to pronounce it and I know what it means. It's just brain not do that word today. Like, that's the best I can come up with. Bumblebee tuna. Bumblebee tuna. Chicago, you're out of here. All right. Recommendation 4. Consult with the Commercial Crew Program to review post-variance acceptance risk assessment findings related to its manual control waiver for lessons that can be applied prior to HLS certification. If you don't understand what that said, that means go look at the Commercial Crew Program, because HLS is a similar program, and figure out what they did and do whatever they did.
Yeah, to allow them to fly manually, because that was kind of an issue they had.
Mm-hmm. I agree with the OIG there. That should absolutely be a thing. You just never know. It should be unlikely, but absolutely a thing. Like Dragon. Dragon, you can do manual control, but it's very unlikely. Wait, didn't Commercial Crew allow Starliner? Yeah.
But they allowed Starliner with manual control ability, unlike SpaceX, who at this point sounds like they don't want to have that manual control capability given. They want things as automated as possible with essentially zero interaction from humans.
Spoiled, I would argue that Starliner having manual control capability is why Butch and Sunny are home with their families today.
Yep.
Yeah,
concur.
I would say that's why that is a thing. That thing absolutely would have crashed into the ISS had Barry not taken control of the vehicle. Like, this is within the keep out sphere during RPOD, rendezvous proximity operations. Dude, I cannot stress enough how bad that Starliner mission actually was. Like, dude, that is about as close as you're going to see to a failed mission without actually failing, without, like, someone getting hurt. Like, it's that bad, dude. But manual control definitely made it less worse than it could have been.
By the way, not only did that allow him and Sunny to go back to their families, but also the crew aboard the ISS. Because if you had another mirror incident where you have to manual dock and you miss and you create a
Crash.
giant hole inside one of your modules and decompress, that could be a really bad day.
Yeah, Progress 15 back in the day crashed into Mir because the autopilot didn't work. So somebody on the station tried to remotely pilot the craft in and missed the docking port. Yeah, that's a good call, Sawyer. Yeah.
Yeah.
That's dangerous. That's
So yeah, he saved the
bad.
lives of everyone on board the ISS in addition to the two of them on Starliner.
Yeah, Shogun Apollo 11 was the biggest one. Yeah, that's 1202. Hey, that's what happens when your processor gets a stack overflow. Yeah, because you didn't turn the radio altimeter for rendezvous and docking off. Buzz forgot to shut it off. So
You forget to shut it off? I thought it was he had it on as a way to have an extra source of information coming in.
Yeah, I think you're right, dude.
And then it overloaded the computer because it wasn't expecting that to be on the way down.
Yep, 1201, 1202, 1202. Transport this is solo. I can't get to you. I gotta take control. Take control manually. I'll get down on the Falcon. What? That's Han Solo. Neil Armstrong's is just as cool, if not cooler, than Han Solo.
Cooler.
I agree. Does that make Buzz Aldrin Chewie?
I mean, he sounds about the same right now as Chewie, so it makes sense. Listen to him get angry. It's about what he sounds like.
Does that mean the AGC is R2? And Michael Collins is C-3PO?
Anyway.
Nah, Michael Collins is cooler than C-3PO.
Say.
Like, way cooler, actually.
His biography is great if you haven't read it.
Yeah, if you don't want to read Michael Collins' whole biography, guys, read about his Gemini mission. Your perspective about that dude will change. There's a reason why he was there for the first crewed lunar landing. There's a reason why he was on the Apollo 11 crew. What he did with the Gemini program, NASA was like, yeah, you're good. You should go on this mission. And he's like, I should go on that mission. They're like, okay. Yeah, read about Michael Collins on his Gemini mission. It is some ballsy stuff. Yeah, his EVA on his Gemini mission is freaking insane, dude. Like, dude, you are out of your mind. It's some Mark Watney stuff in real life. I'm serious. It's absolutely insane. Go read about it. Yeah, good stuff. And the moon is Luke Skywalker. So who's Darth Vader? Richard Nixon.
Anyway, what was management's response?
And JFK is Obi-Wan.
Oh, Jesus. I was trying to stop this from going any further, and yet it continues.
Yes, but it's my stream.
Get worse.
It's my stream. It goes off the rails. You know why it goes off the rails? Because we're not on a train. We're on a hovercraft. Boom!
Oh my gosh. I'm sorry, I'm so used to being the host that has to rail things back in. Keep going.
Dude, you don't need to do that here. That's all I'm saying. That's all I'm saying. You don't need to do that here. It's my stream.
Where are we going next?
This is just... Yeah, all right. Somebody give this sub to What's Up 1985. Thank you. Updated crew survival analysis, including decision packages to include strategies for extended crew survival. Management response. NASA concurs with this recommendation. The HLS Crew Survival Analysis Report was updated in September 2025 to Revision B, with the latest identification of crew survival gaps. The HLS program has developed 2 decisional packages addressing 1, elevator failure backup method, and 2, depression crew cabin transfer, which will be presented to the HLS control board in calendar year 2026. Depression crew cabin? I'm assuming that's something we didn't read about.
No.
Do you mind if I just...
It's under the constraints, I think. Oh, no, that's for lunar landing. No, this is the only mention of it in the entire report.
That...
Nowhere else does it talk about crew cabin pressurization. Talks about schedule pressure. That's about it.
Yeah.
And lunar depressions in terms of mounds that are too deep for the legs.
Yeah, where we're going, we don't need rails. Insert Doc Brown flying train. Yeah, exactly, dude. Yeah. Yeah, depression crew cabin transfer. So yeah, so Twitch already said it. This is if the docking port doesn't work. So did you just say that? Sorry.
No, I'm saying they could have just said that.
Oh, they could have just said that. Yeah. It's like, yeah, Max, I don't. All right. Guys, here's the thing. I don't necessarily think this is like SpaceX is SpaceX's architecture is crap. Oh, Blue Origin's architecture is crap. I mean, if it was up to me, we'd just build another LEM. I'm not even kidding. You just build another LEM. And I know what people are going to say. Oh, that would be so hard, EJ. Yeah, harder than this? Harder than this? You're landing a 14-story building on the moon. What do you mean? What do you mean? What is harder? Like, just, I'm just putting it out there. But this, honestly, guys, what the big gist that I get from this GAO is that, NASA's very much like, we're working on it, but, we're not landing soon, so none of this has really been fleshed out yet. We'll figure it out. No, which is, I mean, honestly, that's bull crap. That's bull crap. I don't care. Dude, you're gonna land. You want to land on the moon in less than 2 years. This should be thought of now. Like, anyway, we have reviewed the draft report for information that should not be publicly released.
I'm guessing they gave him a separate report of, hey, here's stuff that we don't want put out to the public, and they went, okay.
As a result of this review, we have not identified any information that should not be publicly released. This should have been thought of. Yep, Turbine, if somebody gives me a deadline of landing on the moon in 4 years, that problem needs to be solved in 2. Because the rest of those other 2 years is training astronauts, building the equipment, getting ready to fly, doing tests. This should all be fleshed out. Like, there should be very clear con-ops to the surface of the moon and back. Once again, thank you for the opportunity to review and comment on the subject of the draft report. Okay. Digitally signed by Lori Glaze on the 3rd of March. Or 2026 3-2. Yeah, or is that the 2nd of February? I don't know.
No, I think that's March
2nd.
I don't know if I would think that's doing the...
What date format is this?
What? But is it... Okay, now I'm confused.
Is it year, day, month, or year, month, day? I don't know. Like, that's not even the date format that the Europeans use. Like,
right, why couldn't they just do like they said for estimated completion date, August 30th, 26? Why couldn't they just say? I don't know.
At least the Europeans have an argument for theirs making sense because it's how you'd say it in English. Like, what the hell is that?
2026 0302. I would think March 2nd, but...
So year, month, day?
I mean, I was just filling out a form that asked for it in year, month, day. So...
No, day, month, year. But then again, we do month, day, year, which really is stupid. But hey, whatever, doesn't matter. That's dumb. I like my way better because it's what I'm used to.
It was signed either on February 3rd or March 2nd.
Or March 2nd. it was one or the other,
At 9:25:49 at -5 UTC.
Sorry. I just banged my knee on my desk. Ow. All right.
I can't relate.
I mean, you can. You just wouldn't know. Just saying.
Well, to your pain and agony at the moment, I cannot relate.
Oh, okay. You ever hit the funny bone on your elbow?
Yeah, it's not funny.
Yeah, it's not funny because it's my leg. Like, it's my knee. That's not the elbow. It's not your funny bone.
What do you mean? That's one of the funniest parts. It's your humerus.
That is your arm, man, not your leg.
I don't know. I went to school for journalism, not biology.
All right. Yeah, it's like the cast today. Somebody's like, EJ, you didn't say that word right. I'm like, yeah, you know, I'm a nerd. You want somebody to say the word right? Find a languager. Oh, geez. I love how NASA's
Also, I'm from like New York, New Jersey. We don't know words anyway. We don't know what part of the body is what. We just talk about this or that. That one. What hurts? That.
No, that's fair. In my experience with government folks, it's all year, month, day, year, month, day. All right, cool.
So March 2nd.
Yeah, all right. That one.
Which makes sense that it got released 8 days later.
Mm-hmm. If you're going to build a base on the moon, where are the designs for habitats and materials? Yeah, that's probably something you should be figuring out at this point. That's Shogun. That's part of the reason why the Apollo applications program existed in the first place, because part of it was figuring out how to, there's landing and then there's spending 3 days on the moon, which is what Apollo 15, 16, and 17 did. And Shogun, I know you probably know this. I'm just telling you guys this just as a matter of fact. The later Apollo missions, so there's 11, 12, and 14. The first 3 landings. Those were kind of land, put the flag down, do some things, and then leave. The 15, 16, and 17 were uprated missions. Those guys spent 3 days on the moon on 15, 16, and 17, the ones with the rovers. They were out there for a long time because they were figuring out how to live on the moon. That's what they were doing. And doing a ton of science. Like, yeah, it's... they had all that stuff figured out, basically. Dude, they had all those later missions. I believe they were called K missions in Apollo.
I think it was
K missions. They had an alpha, a letter designation for the complexity of mission for the Apollo program, going from A all the way to K. Actually, it went way further. There were Apollo I missions. There were Apollo, like, all the way down to S. Yeah, and G missions too. Yeah. There were technically apology missions, but people use that as a pun. The idea was your iterative testing to get all the way to the surface, and then the missions to live and work on the moon after that. The K missions were the start of it. The J missions were Apollo 11, 12, 13 technically, even though it didn't work, and 14. The I missions that came before that were missions like Apollo 10 and Apollo 8. And it went all the way up to A being the first Saturn 1 launch. Yeah, they had letter designations for the missions, and every time they got subsequently more complicated. But they had all of this figured out basically by 1964. 64, 65 is when the Apollo program architecture kind of coalesced. And then they spent the rest of the 60s building it and actually doing it. Point being, and Shogun, this is the reason why I mentioned it. Point being is that, dude, I agree with the OIG. It is unacceptable that they don't know what the HLS demo flight is going to look like. You don't know. Dude, this is a mission that's 2 years away. That's ridiculous. Yeah, it's unacceptable. You can't do that. And honestly, I like Lori Glaze, but her response is like, yeah, we'll put that in the final report that we've done. That's bull crap. Like, not to say that Lori will or won't do it, but there's nothing of substance there. That's just nodding and smiling in PDF form. Yep, we'll do that. Yep. Okay.
Yeah, that's absolutely the government non-answer answer.
Yeah, like, I think, but then again, I think the reason why she answered that way, Sawyer, was because they are currently doing a review of and consolidating the timelines and redoing the architecture, which is probably why she said that, if I had to guess.
Yeah, because that was before it went public, so it was kind of the generic filler until a couple days after she gave her response, where they totally revamped the entire program.
Mm-hmm. Yeah. Yep. So somebody asked me, actually, Space Noodles, you're asking, could Gateway be repurposed as a lunar surface habitat? I would want it as a low lunar orbit, low lunar station. It would be fine there, and its propulsion thrusters would be plenty good to get some good science out of that thing. Its propulsion systems would be great. It's solar electric, and you could resupply it. So I would do that with it rather than bringing it down to the surface. It's much more suited. That's like saying, you know, I have the money to buy a fully working 747 with pilots and maintenance crew to fly it around, but it's cheaper to operate it as a house. Like, no, gateways should fly. Like, if we're going to do something with it, make it into a low lunar station.
Anything but near rectilinear halo, please.
Yeah. But in order to do that, that's really contingent on either A, Orion having a much better service module. No offense to the Europeans. They built exactly what we told them to build, and they did a damn good job with it. The problem is that that service module is gutless. It has nothing. It doesn't have a lot of delta V because it's not that the version of Orion that decided to get made after the Constellation program got canceled was the Orion MPCV, not the CEV. There were two versions of Orion starting in 2004 all the way to when Constellation got canceled in 2010. There was the Orion CEV, which had an upgraded service module for lunar exploration. And then there was the Orion multi-purpose crewed vehicle, which had something that's much more of an amalgam to the European service module. It actually had a lesser service module because the short story with this is the reason why you would do that is because the Orions that you were ultimately going to send to Mars are not going to need an uprated service module. You don't need that because you're not doing not a TLI. You're not doing a lunar capture and insertion burn around Mars. The transfer vehicle does it. So you don't need as big of a service module. It just works as a lifeboat. So they chose to take that, the multi-purpose crew vehicle, and make that Orion instead, and then contract the smaller service module out to the Europeans to try and make the program more sustainable. But the reality is that if we're going to explore the moon like this, Orion either has to have the upper stage do a circularization burn to get Orion into low lunar, or B, have an uprated service module so Orion itself can get into low lunar. And if they do either one of those things, if they figure out a way to put Centaur 5 with aces, their ULA's reusable Centaur upper stage that can mitigate propellant boil off with an internal combustion engine duct tape to the side. You think I'm kidding? This was a concept. If they do that, then the Centaur 5 could be used to circularize Orion in low lunar, and then you could just go over to Gateway. And you could refuel Gateway, you could resupply it, but it could be in low lunar, so it goes over the landing site like every, I don't know, hour instead of every 6 days. Yeah, the problem would be it would be shorter due to orbit elongation issues. Well, Aqualex, to be 100% honest with you, high flight rate. We're talking about how high flight rate ensures safety. It ensures safety and ensures operational capability. If you're launching to the moon 4 times a year and you can refuel the Gateway with the Esprit module that they're proposing, who cares? Who cares? Everything else is a coping mechanism. Oh, it lasts longer in rectilinear halo orbit. Yeah, that's great. It also doesn't do anything up there. That's kind of important to understand. Could the power and propulsion element be used as a tug to bring Orion into low lunar? No, not enough kick. Good idea, though. That I would argue, Pigzig, that would be a good idea for a future spacecraft. An electric space tug would be great. You made that internal combustion engine in automation and put it in a Miata. Nice. That's awesome, Bill.
Nice.
Isn't the ESM something like a quarter of the delta V of the Apollo service module? Yeah, Vaquero. Once again, dude, and hi, by the way, I really like the way Apollo did, and Vaquero, those are good conversations on the Flame Trench on Friday. That was fun talking. I really like the way Apollo did it. So Apollo made a service module that's capable of putting the LEM and itself into low lunar, but they ended up doing low Earth orbit missions with it for the Skylab program, right? You know what their solution was? Their solution wasn't to build a whole new damn service module. Their solution was to fill the service module up with a half tank of gas. Yeah. It's only going to low Earth orbit. You don't need 1.5 kilometers a second delta V to rendezvous with a damn space station. So just fill up the tanks halfway and call it a day. And who knew the capsule ended up being half the mass? That's really strange. And, you know, you don't have to design a whole new service module.
What a crazy concept.
I know.
Huh?
Those guys really knew what they were doing, man. I mean, Joseph Shea is the guy that came up with the con ops for the Apollo program. He really, like, legendary. Dude, he would have been the best Kerbal player of all time. Like, let me put it that way.
Nice.
He was the best guy around. What about Apollo 13? What Apollo 13? Joseph Shea, I believe he's dead, yeah. He's the one that came up with Lunar Orbit Rendezvous, sending it all in one shot, him and Von Braun and a couple of other guys. He's the one that came up with a 2-stage LEM. He's the one that came up with the design for the damn LEM. Joseph Shea, look it up. Smart. Bro, he would have destroyed Kerbal. Like, I'm talking full RSSRO playthrough, he would have absolutely thrashed on it.
Wow, that's a bold claim.
Dude, it's Joseph Shea. He came up with the Apollo. He came up with the LEM. The LEM was his design. I'm pretty sure he'd be good at it.
I don't know. No, I'm kidding.
Yeah, I don't know. It's pretty hard. Yeah, right? Yeah, Vaquero, people were getting pissed at me in that Flame Trench chat for saying nice things about SLS. Dude, I was like, what the heck, man? I don't think what I'm saying is that crazy. And people are like, no, you suck. And I'm like, why? What did I do?
Wild. That's wild.
Yeah, I was like, dude, I just want to always have a way to get to the moon. Is that hard to ask? No, EJ, you're an idiot. I'm like, I mean, you're right, but damn, dude, you don't need to say it. Joseph Shea equals R2D2. Yes. Mm-hmm. Mm-hmm. There's some valid reasons why they wanted high eccentricity orbit for Gateway, though. Low perturbation at AP and low impulse requirements for corrections. Yeah, I understand, Aqualex. But if, you know, and maybe I've changed my opinion on it because you're right. I understand the requirements, dude. It's not that I don't understand the requirements. It's that Gateway is just a speed bump if you're trying to achieve a high flight rate. I'm sorry, it is. Oh, great. It has low impulse requirements. That's awesome. You're trading low impulse requirements to keep this, frankly, sack of trash space station up there, right? And you're making your lunar lander like 10-fold complicated because of it. That's dumb. That's really dumb. That's not smart at all. I screw a space station at that point. Just put a relay up there. In fact, just put the PPE up there and have it act as a gateway, as a relay station, and just don't ever go near it again. You know, ever. Just use an ion engine. Spoiled Gateway has ion engines. It has big ion engines on it and gigantic solar panels. Did Firefly push again? Oh, I don't know. What's up, Sawyer?
Wouldn't be surprised. I mean, the Gateway hardware is spectacular. The planned purpose and use plan for it is not. It's not like we're, putting up junky pieces for Gateway. There are some modules that I feel like could really sustain a great lunar presence, but not in near rectilinear halo orbit and something where you're maybe visiting it once every 30 days and not really maintaining it.
Yeah, I agree. Gateway is just a liability if you're trying to go to the moon all the time. I'm sorry. It's maybe I don't know. I'll take high flight rate.
It's its own permanently, crewed thing with excursions down to the surface. Or not, even if it's not permanently crewed, where there's weeks or two where there isn't people. But
yeah,
I don't know. I like the concept. The execution has been.
Dude, I've always said my criticism of Gateway really is like I don't mind it. Would I do something different? Yes, absolutely. My big thing with Gateway is that the right time to launch Gateway was in 2021 or 2022. That's what, if it was up there right now, it'd be superbly helpful. Like, superbly helpful. In fact, I would send, I would have sent Artemis 2 to that dang thing. Or now maybe Artemis 3 after Artemis 2 did a free return. You know, like it would be awesome to have that out there, you know, but we don't. It's sitting in a factory somewhere, you know, and somebody tightens a bolt like to a torque spec and then walks away and then comes back and tightens another one the next day. Anyway, Sawyer, we got breaking news. Look on the screen.
Oh no, I saw. I've been keeping track in the back channel because NSF is providing some of the live stream services for Firefly. So, yeah. Blame hydrogen, blame helium, now blame fluids.
We are standing down for today's Alpha Flight 7 launch attempt. After the team saw some off-nominal readings during fluids loading, we continue to be intentionally cautious with a focus on quality and reliability leading up to the test flight. We will work with Space Force Delta 30 to determine the next available window. More to come.
So this isn't one of those missions, is it, where they were planning the rapid turnaround where government goes to a provider like Firefly, which they've done in the past, and says, hey, we want to launch this within the week. Can you do it? This wasn't one of those, was it?
Say that again?
Wasn't there a thing where they had one of the missions that Firefly flew was meant to be that, you know, a military like the Space Force or whatever, or Air Force could come up and say, hey,
rapid response
this is a high
capability.
priority.
Yeah.
Was this one of those?
Stairway to 7?
I hope
not. Let me check.
I hope it's not, because
Yeah,
if
really,
so, that
yeah.
rapid part is, yeah.
Alpha Flight 7 will test and validate key systems ahead of Firefly's Block 2 configuration upgrade on Flight 8. So it's a test mission.
All right. At least it's not. It's at least they're being cautious, and it's not one of those where they needed to get it off quicker.
Maybe I should save this for Flame Trench. They keep encountering these off-nominal readings and out-of-family things with this rocket. Guys, okay, look, there's only so many times you can, and I don't mean this to denigrate Firefly or anything. I like those guys. Those guys are cool. I know a ton of people that work there. Really cool people. But honestly, whoever's making these decisions, I think, has the red line parameters for this rocket set a little too conservatively. It is a test flight. You're testing a lot of Block 2 configurations here, yes and no. But if you get to your launch campaign and you have problems like this, we're being intentionally cautious with a focus on quality and reliability, that's all fine and dandy to say for the press. But honestly, these problems would have shown up in testing, stuff like this, off-nominal temperatures, off-nominal propellant, off-nominal reading during fluids loading, stuff like that. Why didn't this show up during a wet dress rehearsal? Did you do a wet dress rehearsal? Long story short is, guys, like, I love Firefly. I love them to death. These problems should not be showing up now. If they're showing up now, that means you didn't do your homework good enough, or whoever's assessing risk for Firefly is being way too conservative in their parameters. It's one or the other. Like, I'm not sure. I don't even know if Sawyer, did Firefly's IPO go through, or are they planning on doing that still?
I don't know. I haven't looked, so I'm not sure.
It makes sense, especially after a failure. No, Max, it doesn't. It doesn't make sense. It doesn't make sense at all, because after a failure, I would want every part of this rocket gone through with a fine-tooth comb. Every single part, every nut and bolt. Every single one of them should be done exactly the same way that you did, minus the failure mode from the last flight. But no, they went around changing things. This is introducing Block 2 components. Okay.
It is traded publicly, by the way.
They are traded publicly, so their IPO did go out. So that might be influencing the judgment here, you know. Point is that after a previous flight failure, you decided to upgrade your flight hardware. Okay? That's all fine and dandy. Start from scratch. Start from scratch. You change the configuration of the vehicle, not just to address a failure mode from the last flight. You change the configuration of the vehicle in anticipation to buy down the risk of a future version of said vehicle. Start from scratch. Wet dress rehearsal, tank tests, composite tests, engine tests, everything. If Firefly had a stage blow up on the stand a couple of months ago. No, this is not how you do this. Like, these problems should not be showing up right now. They shouldn't be showing up. Like, I only say this out of love, like, because I would genuinely wish no commercial spaceflight company any wrong. Like, this stuff, you have to be on top of this. We just got through talking about this. Like, the fact that they're having all this bad luck on the road, there's no, I mean, I do believe in bad juju in spaceflight, but there's no bad luck with fluid loading. It's like SLS with those damn seals. You know, on Artemis 1, they rolled it to the pad, the seals leaked. So they swapped out the seals on the pad to the hydrogen umbilical, and then it worked. On Artemis 2, they rolled it out to the pad. Right? Started to do a wet dress rehearsal. Guess what? The seals leaked. So they swapped them out on the pad, and then the seals worked right. Why didn't you just do that in the first place? Because that's what you did the first time to make this work. See what I mean? There is, like, I do believe in superstition when it comes to launches, but there's no bad luck. Like, you are the one that improves your chance of success here, especially when it comes to something like fluid transfer. Like, once again, I'm not trying to be a jerk. I really am not. I love Firefly. Like I said, I know a ton of people that work there, and they do good work. And I think Jason Kim, the CEO, is fantastic. But these problems should not be happening right now. This is stuff that should have shown up in testing. Yarg, Alpha has failed an awful lot of times, dude. Firefly is down 72% from IPO. That's what happens after an IPO spoiled. Watch. SpaceX, when SpaceX does their IPO, which I still think is a dumb idea, when SpaceX does their IPO, it's gonna go down into the toilet right after they do it. Everyone's going to say, they shouldn't have done this. They shouldn't have done this. I'll probably say it too. And then it'll go back up. Oh, you're talking SLS seals. Well, I'd give them the 2 times, but if they don't do that the 3rd time now, then it's a major question. Oh, they're not. They're not going to do it a 3rd time. They're going to roll to the pad again with the same seals that they swapped during wet dress rehearsal 2. They're changing the LOX seals, actually. Yeah. They're changing the LOX seals, which have worked right every time. Do I have a pulse? Like,
that's debatable.
Yeah.
You got Duncan going through your veins. That's what it is.
Yeah, that's right. Freaking love Duncan, guy. It makes sense not to change the seals until they are out at the pad. There you go. But they're not going to. Part of when they rolled Artemis 2, when they rolled the Artemis 2 stack back to the VAB, part of it was like, okay, we're going to swap the seals here. We're going to swap the oxygen seals. The hydrogen seals are fine. We're not going to touch that. Yet every other time they've installed the hydrogen seals on the TSMU, on the core stage umbilical, inside of the VAB, it has never worked out on the pad on the first try only after swapping the seals out. Like, I'm just saying, like, maybe you should roll it to the pad and then change the seals. Like, I don't know, maybe you should do that. But anyway, either way, guys, like that's what I mean. Like, these problems show up in testing, so you make the mitigations and change it. Like this kind of thing right here, we continue to be intentionally cautious with a focus on quality and reliability. Reliably doing what? Sitting on the pad and doing nothing? Because that's what it's done. It's pretty good at that. Like sorry for my kind of, you know, candid tone. It's just you can't. This stuff, a fluid transfer problem, bro. Come on. What are we doing here? Just don't hook up the umbilical to the pad. Oh, I don't know, Mutter. That's a good idea because that's what worked. Give me a second, dudes. Anyway, Sawyer, what do you think? You think they're gonna go this week?
I don't know. It's all going to depend on what the issue is. I'm going to be very careful on what I say, though, given that I do work for NSF, and NSF is the launch stream partner for this.
Yeah.
Yeah, that's the Lori Glaze answer, I know, but... Anyway, I think I'm going to head on out then and let you guys continue talking about other topics, and we will go much more into depth on this and analysis on the Flame Trench Friday.
Yeah. All right, man. Well, hey, thanks for going over that OIG report. I still got a bunch of space news left for you guys if you want. You tell me what you want to do. It's getting a little late. We could always do it again tomorrow because there's going to be more Texas tank watching, and we'll probably go right into space news. That seemed to have worked pretty well today. So post them on Discord, Aaron Rod. Yeah, I want to see that.
Well, EJ, it was good hanging out with you. Let's do this again later in the week.
Absolutely, man. I'll see you on Friday.
Sounds good, and possibly tomorrow, given whatever testing happens.
Yeah, that's right, dude. Yep. I'll see you.
Bye.
Thanks for being here. See you, buddy.
No problem. Bye, chat.
See, Sora's going to give you the diplomatic answer. I am not. And I don't do that because I hate Firefly. I don't do that because I have a bone to pick. I do that because I want Alpha to fly, and I don't want to see it explode. I've watched every single Alpha flight, and I've watched a lot of them fail. And I know the people there are jonesing for a good mission. Like, it's tough love, dude. But I ain't no dissenting opinion or anything. I think they do a good job. Look at Blue Ghost. They're one of the only commercial companies to land something on the moon. They got the balls to do this, figuratively. You just figure out this stuff, dude. You can't dick around with it. Anyway, that was Sawyer Rosenstein. He's a commentator over at NSF, popping in about the OIG report. I want Firefly to fly as well. Yeah, no ruds. Yep. But honestly, fellas, look, if they go to fly this thing and this happens once, no big deal, right? But how many times has this thing scrubbed now? Like, dude, going back to like NASA, props to them to have the stones to be like, yeah, roll back the vehicle. We're going to do that. Yeah, it sucks. We're going to end up launching a month later, but we're got to roll the vehicle back. We got to do it. We got to do it. Like, what do you want? Sometimes it's better to just be like, yo, bring it back. Start over. We'll figure it out. See, look, this is the tweet before that. Alpha Team Flight 7 completed testing and verified all sensors are reading normal. We've stepped back into the final launch operations for liftoff to Stairway to 7. Standing down because the team saw some off-nominal readings during fluids loading. Out of an abundance of caution, Firefly made the decision to stand down today on Alpha's Flight 7. This was from the 9th, that's from yesterday, to investigate sensor reading that was out of range. Stepping into the Stairway to 7, the team completed the launch readiness review, and we are going to move into final operations. I don't think you are. In collaboration with Delta 30, Firefly confirmed March 9th. Is it available launch Alpha 7? Yeah, we covered that. That's the Antares 330 interstage. That's sick. That's really cool, actually. If anything, Firefly is the A+ on their composites game. It's good stuff. Flight 7 has been scrubbed today due to high upper level winds that exceeded FAA safety parameters. FAA safety. Huh. They didn't say upper level winds, spoiled. They said FAA safety parameters. Maybe I'm reading too much into that. Something that's something funky. There's something funky going on here with this. Now I'm not so sure. Something's funky with this. Something's very funky there. Why would they say FAA safety parameters? That's such a weird way to put that. Everybody else just says upper level winds. Is there anything else here? Hold up. See? Look. The range assesses high upper level winds. Something funky is going on here, dudes. Yo, that's a really weird way to say that. The range assesses high upper level winds, and then they say it exceeded FAA safety Okay, there's something funky there, guys. All this sensor data stuff might be because all this weird sensor stuff, all this stuff might be because they were ready to go and the FAA said no, and now their rocket's been sitting on the pad for an extremely long period of time. Yeah, that's FAA safety parameter. No one's ever called it that. They always say the upper level winds from the range, like they did in the previous tweet. Something funky is there. I'm not entirely sure that this is all Firefly now. Sorry, I had to do some digging there. I apologize for the tweet scrolling on stream. Huh. Huh. It also could have been because of air traffic with California. Yeah. But there's no flight corridor up there by Lompoc. But probably a new guy tweeting for them. Well, Strickler, that new guy tweeting for him, said those two tweets, the one that says range upper level winds, and then the one that says FAA safety parameters, those tweets were a couple hours apart. Yeah, guys, I'm not entirely sure that it's all on Firefly here to be 100% real, but also at the same time, if the FAA says upper level winds are a problem and are a problem for your vehicle, and they say don't launch, and then the vehicle has problems that have nothing to do with that, what are you doing? I shared them on Discord for you in the car channel. Sitting on the pad shouldn't cause issues. That's a good point. But do you know that? Do you know that for sure? Just because other rockets can sit on the pad for a long time doesn't mean yours can. If anything, I would be very stringent about it because Alpha is using carbon composites. It's all carbon composite structure. I would be very careful. And it's not like they can go knock on Peter Beck's door and ask him. Does the FAA have set parameters for upper level winds? You know what, Rarest? I don't know. I'm not sure. My gut is telling me that because it's the FAA, there are probably flight rules on a per vehicle basis, just like there's flight rules for planes. Like a 737 can only land with a maximum crosswind. That's all FAA mandated stuff. You know, there's only a certain cross-range capability for like a Cessna. Basically a Cessna cannot land in a crosswind. We tested that in Flight Simulator. It did not end very... I mean, I did land the plane with a gnarly crosswind. I basically flew a Cessna 152 in sideways with like a 30-knot crosswind and landed the plane. The problem is that 30-knot crosswind was enough to flip the plane over sideways. It was enough to push my wing into the ground, and the plane just kind of just started doing circles because one wing was in the dirt. Anyway, let's do a little bit more space news. Let me find the rest of the links. Actually, I might move some of this till tomorrow. We got the OIG. We got Firefly. Okay, here. Check this out, dudes. Yeah, they must have submitted documents that state their addressed levels for wind. They might know their modeling assumptions are super conservative, and it would still push if it was over 2% over and the FAA prevents them. Yeah, Jock, this is not it's not, yeah, I don't know, man. They really got to make some adjustments. They got to figure this out, and they got to figure out fast. All right, check this out, guys. Dave Limp posted this today during tank watching. It's a picture of, picture of New Glenn's factory down in Florida, specifically Glen Stage 2. Look at all of them. They're all in a row. Oh, boy. This is... I have a feeling we'll see improvements with the Artemis lander program with Steve at the helm. I agree. So we've seen up to Glenn Stage 5 being tested, because Dave Limp actually, here, I'll show you guys another thing that he posted. Check this out. Dave Limp posted this the other day. So Blue Origin had the New Glenn second stage test stand out at LC-36. And they hot fired the 5th New Glenn stage. Nice. Here's another shot of it. Nice. Nice. So that's Glenn Stage 5. That's for the 5th flight. GS2 Flight 5. Serial number 5. That's what it is. That's their naming convention. So that means in this freaking picture alone, 6, 7, 8, 9, 10, and 11 got to be in this picture. At least pieces of most of them. That's a lot of upper stages. Do you guys... This kind of feeds the theory that I was saying a little while ago about how Blue entirely wanted... They entirely thought they were going to nail Glenn Stage 1's first landing on the first flight. And how they do not have a lot of New Glenn first stages in the pipe, but they have a lot of second stages. See what I mean? They're using Pad 36 as their McGregor. Yep, that's their main launch pad that they put that second stage test stand on. Scaling like you want to launch a mega constellation or something. How many New Glenn flights do you think we'll get this year? At least 3. I'd say at least 3. Because Glenn Stage 3, 4, and 5, right? We've seen 1 and 2. 1 and 2 flew, right? 3, 4, and 5 are operational, right? They've been tested, so they're ready to go. And then you have 6, 7, 8, 9, and 10 here. 6, 7, 8, 9, 10. And then those are Glenn Stage 1 stuff over there. Look, this is a New Glenn engine section. You could tell because of the nacelle on the side. See this thing? That's what this space right here where my mouse is, where the landing legs are. And then right there in that picture, there you go. There's your 2 other operational stages. So that's 3, 4, 5, 6, 7, 8, 9. Oh, and then those ones right there have to be the ones in the other picture. Hello. Okay. Wait, let me take a look. Where's that barrel segment? There's that barrel segment that's in the other picture. See it over there? See this cylinder? From this angle, that cylinder is right there. Man, that's a lot of upper stages. Did you count the white one in the upper left? Yeah. I'm pretty sure that those are the ones in this picture. These ones are fine. These ones are completed. 201. These are finished. Or they're very freaking close to being finished. Man, those upper... Put it onto the SLS core. Oh, fingers. Dude, SLS would very much benefit from having one of the... You don't think. You don't think. Surely you jest. Not all of them, Leon, but not even one. You don't think? I mean, sorry, it popped into my head. I for what it's worth, I agree with you. I think these are all Glenn stages, but also that's a lot of stages. Don't call me Shirley. All right, Linda, or something. Could they refit ML2 to the NG second stage? Sure. I mean, it'd be a pain in the butt, but sure, similar commodities, right? Yeah, for what it's worth, guys, I think these are all for New Glenn. I would say that, I would say that that's 3 and 4 over there, and then 5 is this one. So that means they have 3 flight ready stages right now, or at least 3 stages that are extremely close to flight, and these ones are a little ways out. That one is the most completed out of all of these. Actually, it's this one or this one. That one has the cap closed. That one has the cap open, meaning that there's still some open items inside of the tank, so they have the hatch off. Every tank does have a hatch. It's just not, once you bolt it down, it's not really designed to come off. It's not like a ingress hatch or something. That is for doing work inside of the tank. That one, notice that it has a cap on it with a FOD cover. So I would say that one's closer, and then that one, and then this one, and then that one over there. See, that one over there doesn't have its aft dome. The jig is empty. So this is the jig for integrating and installing the aft dome. That's what that whole stand is. And then your stir welder is right there. The eye stir welder for stir welding the dome on is right. It's right there. You can see it. So basically, this big old thing is a gigantic rotisserie, and it's a rotisserie where they can kind of skewer all the sections of the stage together, and then they rotate it, and the welder just turns on, and they just stir weld the entire thing. Any plans for after hours? I don't know, man. Yeah, maybe. How's the second first stage coming along? I'm going to go ahead and guess that that's probably a piece of it right there. That's definitely a New Glenn first stage engine section. That one, they blurred the picture, so it's kind of hard to tell, but this still has a lot of safety scaffolding inside of it, so I would say that's not near finished. It's close. I mean, it's definitely along. It's got its corrosive primer, and they have thermal protection system, the Comet stuff on the outside, so... You have a Starship booster, probably. Probably want to get some sleep for tank watching. Yeah, there is more space news, but yeah. Like, and I think just because of the tank watching, it's probably a good idea. Crazy idea. Super heavy that with a GS2 on top, then another GS2 on top of that, then Orion. I mean, how are the people getting in that, dude? And what pad is it launching from? I bet they have that pic over there in the corner just in case people forgot what it looks like. Yeah. Yeah, Bob, it's like how assembly lines have a picture of the car on the wall. Too real? Dr. Longballs, you're a Ravens fan. Call me. I'm crying. The butterfly effect from Loop missing that kick is insane. The Ravens pulled out of the Max Crosby deal. Knee is gone. Oof. What are we building again? Right, right. Another testing window popped up tomorrow, DH, after they closed the road, after the road closure ended today. Oh, jeez. Yeah. Fellas, I'm a little bit on the tired side. Yeah, crazy idea. Yeah, that's fair. That's fair. All right, dudes. Well, that's going to do it for the Space and Rocket review. There is still plenty more stuff, but I hope you guys enjoyed that OIG report. Sawyer and I are probably going to talk more about that on Flame Trench. I'm just trying to see if there's much more here. So tomorrow, if we ever get some time, go dream of Cractorio. See, like, that's the thing, dude. If we weren't doing tank watching tomorrow, I would absolutely play right now, but nah. So I'll pencil in us for noontime, but we'll see what happens tomorrow for tank watching. Yeah, I'll pencil us in for noontime. I might be here a little bit earlier because we could do work on the car. We can do some car stuff in the meantime. While we're waiting for tank watching, or I don't think playing Factorio is a good idea tomorrow, fellas. I really don't. I want to just sit there and shoot at bugs with the artillery pieces all day. Is that bad? Yeah, so let's tentatively schedule some car stuff tomorrow, tank watching, and then I really want to try to make that X76 in Kerbal. I really want to try to do it. We'll play it by ear tomorrow for tank watching and space news, okay? You're saying the game has become a hindrance to productivity, but if I'm productive in the game, then it works. So I have to. It's either be productive in Factorio, or literally like be productive in everything else. Is that bad? That's bad. But then again, being productive in Factorio is good for the business. But I'm too tired for this, man. I'm gonna go get some rest. I advise you all to as well. Tomorrow's gonna be there's gonna be a lot tomorrow. So it's like when I'm doing good in the game, I'm doing good in real life. Yeah. So I'm gonna get some sleep for the time being. Let's see who's still over live on Twitch. Let's see if we can drop a raid on YouTube side of things. I hope you enjoyed the Space and Rocket review, and on Twitch as well. Yeah, there's not many people around right now. Yeah, don't worry about it then. I'll see you guys all tomorrow. We'll plan for 12, but I might be here a bit early depending on what happens, okay? Thank you very much for watching, dudes. I hope you guys have a great rest of your night, and I'll see you all then. Good night. Thank you.